Dank u. Right. Good morning. Hello. Welcome to NLNOG Day 2023. My name is Natalie Tredeman. I'm the chair of the NLNOG Foundation. It's the 7th time we're here at Podium Mosaic, but it's the first time on a Tuesday. And this has to do with the limited availability of Podium Mosaic. As board, we didn't mind moving it from a Friday to a Tuesday, but we're very curious to hear what you think about this move. And so in the breaks, do please let us know. As usual, all the presentations will be held here in the theater, and all the food and the drinks and socializing is downstairs. Also, the toilets you can find behind the bar downstairs. For lunch and dinner, we've set up a buffet style this year. And so if you informed us about any dietary requirements, you can take care of that yourself or ask the staff from Podium Mosaic for more information. Our friends from Event Infra took care of our Wi-Fi. And, which of course is IPv6 enabled, and it does RPKI filtering. The login details you can find on the doors, and also the slides for all the presentations will be on our website. Then we have Anna Cox from Red Dress Effect. She's our event organizer, and as usual, we have the amazing audio-video team of Sven and Denise working behind the curtain to live stream this event. We also, they had expansion, family expansion, so yesterday evening they brought Luca, their 5-month-old baby, to help us up with the setup. Pretty cool. Talking about streaming, I would like to welcome all remote participants. I say participants deliberately because you can ask all your questions to all the presenters, as usual, on IRC, or, and this is new, we've set up a Discord server for NLNOG. Ooh. Cas will tell you more about that and also has the QR code and the invite link, so join us there as well. I say as well. NLNOG has an excellent reputation for being a friendly and welcoming event, and we take great pride in that. Therefore, I would like to ask you today to be your friendliest self. I'm not reading out our code of conduct, but if you experience unpleasant behavior or you witness unpleasant behavior, please come to see me or Niels Bakker. Then I would like to introduce our board. Niels Rijer, over there, he's our vice chair. Melger Amans is downstairs. He is our secretary. Then we've got Niels Bakker, also downstairs. He's very tall, you can't miss him. He's our treasurer, and then we've got Teun Vink and Cas de Reuver, and they're both there. They're also board members. So we're a small group of volunteers with day jobs, and we do this next to our day jobs, and I'm super proud of the team, I just wanted to say. And last but not least, there would not be an NLNOG Day without our wonderful and dedicated sponsors. NLNOG Day is not a commercial event. We don't have sponsor booths. We don't have sponsor talks. And we definitely discourage sales activities today. But NLNOG Day is for free. The food and drinks are for free. The streaming is for free. And for that, I cannot thank our sponsors enough. Now, as you know, I always read the full list of sponsors, and you have to bear with me because the list is even longer this time. We got an additional 5 new sponsors. That's why you see the banners also expanded a bit in size. We're super happy with that. So here we go. In random order: Juniper Networks, KPN, RIPE NCC, Power DNS, M6, Duocast, i3DNet, NLAX, LoanApp, Arista, Ratten, Internet Society, Quansa, OpenBSD Amsterdam, Nokia, Smart Optics, LeaseWeb, Fibering, Fusic Networks, 10IT, second page, Alkira, NTT, Solid Optics, AVM, Kentic, OpenKeer, Nexpertise, BIT, SpeedIX en Tweede Golf. Thank you very much. And now I'm going to hand over to Teun, who's going to give you an NLNOG update. And I wish you a really pleasant day today. Have fun.
Okay. Right. Okay. Here we go. Good morning. So I'm going to give a short update on what we did with the NLNOG ring last year. Since, well, the ring was running Ubuntu 18.04, which was about to go end of life, so no security. Oh, too neat. Sorry. Yeah, that's the trick. Like this. So yeah, Ubuntu 18.04 was going end of life, so we need to do something to have security updates and have the ring secure. So our plan was to upgrade everything to 22.04, which was the obvious next release from Ubuntu. And well, the first step we did was make sure that we could provision new ring nodes, which was not that hard. We had to do changes in some of the Ansible playbooks we use, so that we could provision them, because well, some services changed, some configurations changed, stuff like that. We had to redo some scripting, because Python 2 scripts were used on the old ring, and well, Python 2 isn't available by default on Ubuntu 22.04. Wasn't that hard either, so that was the easy part. But then, how do you upgrade like 600 nodes all over the world? That was a bit harder. So how would we do that? Could we just do that manually? Well, that was really out of the question, because, well, that would take so much time. We would never be able to do that. We could ask the ring owners to do it, but that would still take us a lot of time, because we had to contact every single owner, hope that they will be able to help us in time. So no, that wasn't really an option either. So maybe reprovision everything then, or ask the ring owners to do that. Bit of the same problem, we still need to contact all the owners. So, not an option either. So, well, we had Ansible, so let's use Ansible. And basically, we wrote a script that upgrades 18.04 to 22.04, but with one small challenge. You can't do that in one step. You have to go 18.04 to 20.04 to 22.04, because in one go you can't do that. So we did 2 upgrades instead of 1. And what we did was do first via playbook trigger the upgrade from 18 to 20, reboot the node, set a cron job that after reboot the upgrade is triggered again to do 20 to 22. Well, and if that's done, we have a working 22 node, and everything is cool, and we have profit. It wasn't a bad plan. Roughly 3/4 of all nodes upgraded without any issues from 18.04 to 20 to 22. But yeah, that still left us with about 100 nodes with issues. And those were challenging. We had nodes that crashed on all sorts of reasons after rebooting. broken grubs, networking issues, you name it, we've seen them. We had nodes ending up in boot loops, where the Ubuntu do release upgrade command actually didn't do anything, but our playbook had said, please reboot after you run do release upgrade. So the node rebooted, tried to upgrade itself again, failed, but the at reboot job was still there, so boot loops. And one of the challenges we had was small /boot partitions, and that was really an issue on a lot of nodes. Since the start of Ubuntu, or the start of the Ring, kernels have grown a lot, and by default the older Ubuntus had really small /boot partitions where you couldn't even fit 2 current kernels anymore. So we had to ask a lot of owners to either grow the boot partition or, well, reprovision the node. That meant that we had to do a lot of manual fixing, asking Ring owners to help us out with stuff, especially if the nodes were unable to be contacted. And for us, often the easiest solution would be just reprovision the node. Give us a clean Ubuntu install and we'll kick off our installation scripts and we're done. And of course, then you run into a few new challenges. One of the hardest ones is getting no contact with the Ring owners. Quite often, we got no response. Addresses of the contacts we had were bouncing. Well, basically, the nodes were on autopilot and no one knew about them anymore, because that was the other problem. In some networks, there were Ring nodes, but the employees left there who set up the node, and nobody knew anything about the node anymore. So we had to tell them, well, there is this machine in your network, and no, we're not a customer, but can you please reprovision it? And that is sometimes a bit challenging. So a request for all Ring node owners. Keep your nodes as standard as possible for your organization. So, and that basically means document them in your ticketing system, in your content management database, in whatever you have to register your tools. Don't make it this secret virtual machine hidden somewhere on a place where nobody knows about it. Another thing is, please add Ring admins to your customer contact database, because in a number of cases we just couldn't contact the email addresses we had because we got an out of bounds. Sorry, you're not a customer. Yeah, that's not really helpful. And if you have any updates on your customer information, please contact us so we can fix it in our database. Final results after, well, a few weeks of a lot of work was that we, well, basically were able to recover most nodes. I think we lost a few, but not that many. And the good thing is we tried contacting people via email, via IRC, mailing lists, stuff like that, and it actually brought us new nodes, so there's an upside to it as well. Well, as I said, even with all the automation in place, it was a lot of work, so I would like to thank all the Ring volunteers for helping us out, because, well, it really took us a few weeks of a lot of work. And also thank you to all the Ring owners for helping us, for making it easy for us to upgrade the nodes. Well, the final results, well, nearly no nodes lost. Everything is running 22 now, new nodes, and sadly no profit. But we have a secure Ring still. Small new problem we encountered on the upgraded nodes. The SSH server running on the Ubuntu 20.2 is a lot newer and deprecates some SSH RSA signatures. And that means if you have a very old SSH client, you may get a connection refused result if you try to connect to the server. I sent an email to the Ring user mailing list about this. We have received quite a number of questions about it. The solution is either upgrading your SSH client, which is a smart thing to do anyway. But you can also use a different key type like ECDSA. And should you be unable to log into your Ring node, please contact one of the Ring admins and we help you out. So, where are we now with the ring? We have 629 even ring nodes currently in 507 ASNs, nearly 500 organizations, 59 countries. Now, as you can see, we're mostly balanced to them, well, the West, which isn't that surprising because, well, we're an analog. We mainly communicate on the local or regional fora, on RIPE events, stuff like that. But there's still a lot of countries we don't have nodes in, and of course, countries is one thing, ASNs is another. So if you run a network and I'm willing to help out, please consider applying for a ring node. One other thing I wanted to talk about is about IRR Explorer. There were presentations on it last year on what you can do with it. Just a small reminder, it helps you out figuring out differences between routing registries and actual routing tables, RPKI data. So you can figure out if there are any problems with your prefixes being announced or not being announced. In the example you see, I still like to use this one because it's pretty clear what it does. The famous Cloudflare DNS prefix, as you can see, the 1.1.1/0 is, everything is good. There's RPKI, there's a valid route object, and it's visible in BGP. And then you see that there are a few smaller prefixes, /32s, in the RADB database, which shouldn't be there, and still are there. They were in, they've been there for years. If you don't use it, try it out, check out if your prefixes work properly, if you have any problems with that. We currently see about 1 request per second on our platform. A number of people have used the JSON output to automate their monitoring of their prefixes. Something you may want to consider. Last year we did some improvements on IRR Explorer. We had a few issues with stale data or outdated information, which is pretty. It's not wanted because you want to see the actual current status, and if we're not properly syncing one of the databases, that's a problem. A number of software fixes have been made to improve synchronizations. We did a complete reinstall of their setup. So new Ubuntu, new Python, new Postgres, IRD, IRR Explorer with the latest fixes. And that seemed to improve this. Should you be experiencing issues with a prefix where you think data is stale, please contact us. We have a few databases which notoriously are not that good in updating their data, which makes it for us hard to synchronize, but we think it's much better now. And most of the problems are gone now. That was my part of the presentation. I'm now going to give the mic to Cas, and he's going to tell a bit about our social stuff. So.
So I have a quick few updates about our social channels. The first one is that after the big Twitter/X debacle back in May, we decided to join Mastodon. So if you are on Mastodon, you can follow us at NLNOG at mastodon.nl. And something else, Natalie already mentioned, we noticed that the people active at NLNOG is a pretty stable group, and we're really happy about that. But we also want to attract some new people to NLNOG, and we're finding that they have a lot of struggles finding their way to us. So we decided that we wanted to be where the people are, and we started looking around where these people are active, and we noticed it's mostly at Discord. So we decided to open a Discord community, and we're really happy to announce that today it's gone public. So you can scan the QR code on the left or go to RC and then click on the link. And you're welcome here. The tooling, like you know, Pietbot in RC is still a work in progress. But as Natalie already mentioned, the Q&A can be done from Discord at the NLNOG Day channel. And one important thing I want to note is that Discord won't be replacing RC, so don't panic. RC will still be around for quite a while. So that's the update. Now I would like to give the word to our beloved host, Niels Raaijer.
Thank you, Cas. I very much appreciate your wording on this. I noticed that you called us not old, but a very stable group. Thank you. As Cas said, my name is Niels Raaijer. I'm your host for the remainder of the day, and it means that I get to introduce the next speakers. Now, I am a very stable group, so I remember my 468 Tower PC, and it had this wonderful lock on the front. And if you turned the lock, you could not use the keyboard anymore. And I know that there were also models of computers that actually closed the casing of the computer if you turned that lock, so you couldn't do anything. So it was like a security feature on the hardware, right? Well, there has been some progress on this front, and to tell us everything about hardware security and hardware security modules, we are very happy because this has been a subject that we wanted to cover on NLNOG Day for quite a while. Joining us today is Oscar Couraud from the Ministry of Public Health and Sport, and he will tell us about hardware security modules. Oscar.
So this is my location, right?
Yes.
Okay, cool. So I'm Oscar Couraud. I'm the Chief Information Security Officer for the ministry. Yeah, so this is, to me, it's new, because typically I lurk the streaming service from the other side, and now I'm in the room, so that's a bit different here for perspective. So I'm on IRC for quite a while, lurking mostly, but I worked at NICF, but then on the laboratory side from 2003 to 2013. Then I worked at KPN in the CISO office there, and now for 2 years I work for the ministry. And we had some learnings to do, because typically we worked with, of course, hardware security modules in specific areas, or outsourced even in some cases. But ultimately there was a motivation to learn very quickly in a very small amount of time, and I'm going to tell you something about that. So our ministry, of course, is for public health, so we're here for you. We work for you as civil servants. And we have all kinds of variations of services. And we could basically boil this down that we have your informational or special healthcare related information multiple times in various databases, or pharmaceutical information, you name it. Everything that has to be behind the scenes, not at the hospitals, but everything that we have to do centrally, we are responsible for that, and we take very great care in doing this, day in and day out, with great engineers. Now, there are all kinds of threats these days, hardware, software, and especially if you think about the Meltdown and Spectre, and you can see all kinds of other pieces of software, or sometimes my colleagues would say, that's a piece of hardware, for example, or Fortinet or Citrix, but they don't really look always at the software side and the threats on that end. And I look on the inside, and I regard a Citrix as a BSD device with software. At that time, it had some quality issues. So at least in hardware, we see the same kind of threats. And we see attackers becoming very sophisticated and getting into the machines and getting into key material. Now, this is something that happened in the past a few times, over and over again. So even if you have such a responsibility and you have encrypted data, that's all cool and nice. But if you have all your data in memory or in environment variables, and the environment variables leak out, we had some issues with some great large vendors having such a situation where log files ultimately had key material in the logging because something went wrong in that area of the software. That's a problem. How do you protect against those kinds of situations? How do you protect against the developers making, of course, I'm a software developer myself. I know how much mistakes I create. The C compiler has been very strict to me in the past. Minus strict. Or pedantic, choose your poison in that case. But that's basically what I've been growing up with. So I know all those kinds of things. So how do you protect even when the attacker is on your system, in your system? What are the opportunities? Now, if you look at secure connections, I always keep up this drawing that I've made in the past, which is, okay, you have to think about TLS connections. This is what I typically work with, or at least most of the times. And you have to deal with the confidentiality part, so you have to encrypt the data, you have the integrity control, and authenticity. Now, today we're going to focus on the authenticity side, because if you mess that up, somehow, at least something goes terribly wrong. This is why I'm pretty fond of destroying self-signed certificates wherever I can find them in infrastructure. It's too tactic to actually not ever have that problem. But I always have the explanation, look, if you have a connection from one to the other end, how do you know if you're connecting to the actual server that you're basically targeting? Now, we just had an explanation about SSH and SSH keys and the quality of keys even over time. Now, this is something that we have to take care of course, but what if the keys are self-signed and there's not a fingerprint control, PKI, for example? There are quite some risks in that kind of field. So we have to be very careful in how to deal with those keys and ensure that if you have a PKI system, and I assume you all know what PKI is, so don't have to explain that, but if you have a system which is basically pointing down to just a few keys, and if somebody has a possibility of creating new keys, new signatures, you basically break down the entire security system from one little hack. And this happened in the past. And this is something that we have to ensure that will never happen. So if you look at certificate chaining, then of course you have, just for resemblance, you have the certificate of the host. But if you have the signing scheme, then basically everything starts from the other end. You have a root CA. The root CA then, of course, signs another certificate for purposes of distribution and business continuity management. You have multiple layers of signatures. And that key signs another CA, in this case an extra subordinate CA, and then ultimately you sign your host certificates. This is PKI in a very small nutshell. This is what you see. So if you look at the coloring scheme of, in this case, a macOS, for example, it says, well, this is how the distribution of keys and certificates is being handled, and you've got this root CA. Now, if you have a root CA, you can generate a new certificate and fake a new identity. Now, identity faking is not just something for humans, but also for machines. So if you can fake a machine's identity, that's pretty bad, and you can do all bad things with that. I think we, as internet society or internet community, we don't have to explain what you could do if you can actually fake a connection, and if you can do interceptions and so on. This is a really bad thing. Now, how do you take care of that? Well, we also have to take care about the keys on our hosts and services. Because if you look at CAs, those use hardware security modules to protect them and ensure that people are not able to get a hold of the key. But then I always look at my own configurations, for this case, a piece of Nginx from my home lab. And then I look at the device and I say, I always have my keys ready to go. If I want to do a system control restart of Nginx, I want to load that key, right? Because otherwise, if the machine goes out, power goes in, I need to unlock it with a PIN code. Well, that's going to be a problem. So sometimes we have an issue with a protection with hardware security modules that's really complicated to solve. How do you ensure in these kinds of fields that you always continue your operation? I have my keys on, wait a minute.
Yeah, okay, yeah. Sync?
Okay.
Okay.
I saw it on here. I saw it on here. I did not see this. Sorry. So this is what I was talking about. Where do you store your own private keys? And we know that we have to protect the private key, right? Typically, it's on disk. Now we have to type in a password. Now, if I reload my web server, I don't really want to type in my password. Now, how do I protect this against a threat that comes into my host, on the host, has abilities of reading the entire file system, and grabbing my keys, grabbing my digital identity of this host, and then continue on. This is where hardware security modules comes in again. Again, explanation will come after that. What are these kinds of devices? Yet another set of pizza boxes in this case. Here's a quite variety of some various models and makes. I didn't want to push into one specific vendor, but in this case you can see quite a few models. They don't really distinguish that much from any other 19-inch racked mount devices. On the inside, well, at least before you go to the inside, thank you for the Crypto Museum, by the way, is here the first indication that this server might slightly be different than another one. Because if you want to service your memory modules or anything else that breaks, well, one of the typically what you do is you pop open the box, new memory modules in, and you're done, right? Well, you should, but in these kinds of cases, that even is a protected seal. And the idea of this entire mechanism is that you can store the keys on the inside of the box. You interact with the box, you have an authorization protocol going on, and you ensure that nobody else can go into that box. So one of the things that a hardware security module is also protecting you against is actual physical threats. In this case, by a very classical seal. This obviously has no actual protection against it, but the thing is that you want to see and ensure that somebody actually went into the box. So sometimes with hardware security modules, you would say, well, I could enter the box and haha, I'll take over the machine. Well, the idea is that at least sometimes it might be tamper-proofed, but there are various grades in hardware security modules. And one of the first indicators in this case is that you have a seal that you can see that there is a breaking and entry. And you have a very positive statement, this actually happened. On the inside, you will see yet another great example of the Crypto Museum. You will see that it's just a regular machine. It's not that special, actually. Of course, all the devices and all the elements of a hardware security modules are tested for radio emission, even with somewhat stronger protocols than you would typically have, to see if you can actually read or catch memory material or some other activities from the outside of the box. This is why these devices are certified for those kinds of electromagnetic threats. But this is just the outside of it. The actual hardware security module is just this. It's interesting to see the lag, by the way. So the hardware security module is just this thing. So the entire box is certified and basically holds a front display. You can interact with the device, and from the outside of the box, you can start interacting with the operating system on it. And through that interface, you can see the inside of this. Now this, as you can see, is a very sealed up piece of hardware. On the inside, you should see this as cells. So there are many cells, blocks of memory, and each of the memory blocks can be authenticated with a PIN or some other means of an authentication mechanism. There are various ways. Typically, you would say that the cheapest and more common way is that you have some kind of a PIN code for an administrator or for a user PIN per cell. And the cells are typically fixed sizes of X amount of bytes. This depends on the model and so on. So you have now an authentication mechanism of stating, okay, with the proper PIN, you can now get a hold or at least interact with a cell. There's another rule of hardware security modules. You cannot walk yourself with software inside of the cell. You can only interact with the door. The door has rules. Rules like you can create a key on the inside of the cell. You can remove or purge or delete a key on the inside of the cell. you can only have a bit of a through hole, or looking hole, how do you call that, when you just have this little trap door that you can just put the food in. In this case, the food of the cell, of the hardware security module, is the data you want to sign. So you throw the data inside of the cell, you state to the outside door with a special knock, I want to have an RSA signature, and you have the private key on the inside, please sign. Then you sign the key, or in this case you use the key, sign the data, and just the signature pops out of that room again as an empty tray. That's the thing what you could do with, for example, secure signature generation. The other thing that you could do is, what else could you do with the data if you have a private key? How much of a crypto nerds are you guys? If I send data to a server, I have the public key, so I have the public key. I send data encrypted with the public key, so I can now decrypt data, right? So if I have the private key, I can decrypt data. Now, how do I decrypt data with a hardware security module? In this case, you could enter the data, or at least the ciphertext, throw into the jail, in this case the cell. You throw it in, and it has the private key on the inside, so the plain text can come out. These are some of the methods that you could do. Now, data that you could throw in could also be time-stamped. For example, these days you have GPS satellites. Older ones don't have any time-stamping and signatures. Nowadays, time is being time-stamped and signed as well, to at least have authenticity on time servers. You can imagine what could happen in a war situation if you fake GPS data. Same kind of mechanism applies to all things that we use with HSMs. Now, this is one HSM. This is a certified box. This is a certified thing. As you can see, it's sealed. And the idea and the other concept is the data will be destroyed faster than that you can tear off this piece of metal and get on the inside of the silicon. That's the idea. That's the concept. Now, of course, you see all kinds of researchers scraping off the top side of silicon to get to the key material. This is why there's a metal box on top of it, so that that ensures that the epoxy on the inside, if you tear it off, would probably break the chips on the inside faster than that you can do that experiment. That's the concept. Now, this is one example, and there are multiple examples of chips and hardware security modules probably closer to you as well. Think of your banking transaction, SIM cards, and even these kinds of passes or identity devices where you have a chip on board and where you can have and store key material with the same concept. You can interact with it, but you can never get the private key out. You can interact with it, you can do the special knock, you can sign, you can decrypt. Those are the primary options that you have with a device like this. And it works exactly like such. The idea is that the private key will never come out. That's the truth thing. You actually give the physical device, in this case the Rijkspas, you give it to the person, and that's the identity that you first have to vet and check. But there are many forms of hardware security modules. The other option that you could see, or at least that you might even have worked with, are OTP-based, where you have a system where the private key is on the inside, but now there's an algorithm going based on time and giving you PIN codes every so many seconds or minutes. Same concept. Private key will never come out. The idea is that the device will break and the private key will break faster than that you can actually scrape all the silicon and plastic off. And on the other side, you see, in this case, a bunch of varieties of YubiKeys where exactly the same thing goes on, and there are higher level protocols built on top of that. And there's many of those examples. Passports, for example, has a chip on it, and it is near-field communication, yes, but it has a cryptographic protocol with it so that it secures the line and then interacts with the onboard system itself. And there are varieties of options where this is built into your motherboards. And this is basically what, well, Apple, Samsung, choose your destiny with respect to the devices. Apple, even all kinds of Dell systems have been built with those kinds of chips very early on. And this is what is now also being woven into the ecosystem of cloud providers, for example. If you have an identity and pieces of the identity or even keys for hard disks can now be stored on the system motherboard, where the idea is that it is tamper-proof, and the system itself is then interacting with the key or key material and then passing that key material to a hard disk, or it does the signature scheme and you have a private key on the inside of a TPM chip, and the private key is then being used to authenticate you, or at least authenticate the laptop that you've just authenticated with your identity. So your identity and the laptop's identity are now being tightly bound and can then be used to authenticate for M365 services, for example, or any other service. It could also be tied to GPG signing, which can be helpful if you sign off and not just use SSH to interact with GitLab, GitHub, whatever, but also use the GPG key to sign off that these are your check-ins. It's very interesting to actually see that, not just to use GPG and signing, but also sign that off with hardware-backed keys, extra assurance. So yeah, some of the key features. On the inside, it runs Java most of the time. Okay, personal opinion, I hate Java. I'm really a C programmer. I live with Python these days because it's easier doing C. But yeah, it runs Java and you can basically customize anything on it. So that's also a bit of a misconception. Oh yeah, but this is always tied down and so on. No, these are kinds of Java modules that you drive. So the Java crypto engine that you use on your systems, a embedded version, is being used on the inside of these chips, which means you could typically also create your own type of interactions and protocols if you wish with this system. Which also holds for the HSMs, by the way, not just for your passes and so on. So again, I've already mentioned key operations. At least the simple versions are create, delete, rollover of a key, sign, and so on. Data handling, decryption, signing, that's it. And all other things are typically protocols that are built on top of these primitive operations. Typical interactions with those are PKCS 11, so which natively works with, for example, any SSL library that basically supports this, which is nice. Long live open standards. KMIP, XKMS, sorry, which is also an open standard, which is you can basically, so if you have a CA, for example, and you want to do more interactions and you want to also work with roles, like, okay, but you are the operator of the HSM, but you're not the key owner, and you have to authenticate, and you have to have multiple people in the same room. Now, this can be expressed with more complex protocols. This is what you're trying to do here. And the example of YubiKeys, for example, then you see other protocols working in interaction with the hardware security modules on the inside of a YubiKey, which would then end up in protocols like web authentication. Now, there's many certifications. There's FIPS 140-2, and there's now -3, which is an upgraded variety and common criteria, which is more common in Europe. Now, the certification schemes is something that is really important, or going to be quite important soonish, I guess, if we want to go to a post-quantum crypto world. Then I assume that there will be a certain amount of time where new protocols come in. They all need to be certified at the same moment in time. What will happen? We will probably denial of service all the certification bodies, because it takes typically 4 to 6 months per device type to be certified if all the protocols, all the emissions, electronic emissions in this case, all the certifications, all the authentication schemes, if everything is working right, including all the cryptographic protocols on the inside of the machines. Because, well, it's running a crypto engine on the inside, of course, inside of each of the cells. Now, this is something that needs to be probably challenged up for the next 2 to 5 years, when we probably will see all these devices being certified for the new protocols. So, hold on for that one. So, and the FIPS levels are interesting. So if you look, it's always explained wrongly, it's FIPS 140-2, or in this case -3 for the modern version, and then level 1. This has basic security. So basic security means it has an authentication scheme on the outside. You can't just enter the box. There's one operator typically, and this is how you handle these kinds of devices, right? Level 2, it shows evidence of tampering. Now, this could be a seal, this could be something else, it could be the metal casing on top of the HSM card, and if you rip it off, then it should definitely show something. So the metal on the outside is typically very soft, so it dents quickly. If you touch it too hard, then basically you're tampering or breaking the entire tampering evidence mechanism if you mishandle this one. Now the next layer is this is the level 3 is typically what CAs are using on the outside world because, well, it adds also multiple operational roles. You can state there are many key custodians. For example, you could say there are 10 key custodians and I need 3 of the key parts to actually reassemble one key. This is typically done, or at least in most systems, there's a scheme called Shamir Sharing Secret, it's triple S scheme. It's the same Shamir from RSA, by the way. And he thought of a very simple math problem where at least if you state you have a key, you split the key in 10 parts, and any of the 10 parts, if you say, well, I have a rule that I need 3 parts at least to reassemble the same key, I get the same AES key. It's pretty neat. You can do this in Bash, by the way. We've tried that, it works. For the people who really like that. But you could do it. It's an interesting scheme. You could also split with that scheme, by the way, you can also split your own keys if they're even not working in this system. But on the inside of these kinds of boxes, this is why you also see the multiple colors. It's not really good to see, but you see these key fobs. Those are not USB devices. Those are, well, in this case, probably the interface probably is USB, but don't treat it as USB because that will be horribly wrong, probably. But there's a blue, a black, a green, and a red one. I'm not really sure what the green one was, but at least the blue ones in this system for SafeNet is that you are a key custodian. So you could have at least 10, or maybe you bought 20, but at least 10 you've given out to 10 colleagues, different people. The black one is the system operator key, and the red one is the admin key, and the green one probably the recovery key, but the green one I'm guessing. So if you want to have a key ceremony, you will probably have, if you state it is the policy to have 3 key parts out of 10, then there was a setup moment in time when you had the 10 people giving the 10 key parts, but when you have the CA ceremony, you're creating new keys, you're signing something new, you're creating new data, or in this case new key material on the inside of the cell. Each time when you work with that, you have 3 blue keys on the table. And one of the black keys, at least for the operator mode, so that you have an operator operating the HSM. And the cool part is, that means you have at least 4 people in that room. 3 key custodians, 1 operator doing the things, and when you have a key ceremony, it should at least have 1 or 2 witnesses, perhaps even an observer. And this is what you typically would require for a typical key ceremony as a minimum amount of people for a new key that you would create for a CA. This is what I've seen and observed as one of the internal CAs that I've created at KPN, for example. This is how we dealt with that situation. So that's something as a feature you will only get from the layer 3 and the layer 4, more. And this will also ensure that there is even more probabilities of detecting it. So you can state that sometimes these devices are also equipped with temperature sensors. So if it heats up in particular areas of the device on the inside of the box, then an alarm will go off, those kinds of things. Now, I also want to stress out, if you really want to work with this technology, it's cool that you have key material, hardware security modules, YubiKeys, whatever, but it basically boils down to a nothing, worthless situation if your total level of assurance is basically 0 because you have no idea who you actually gave the key to. Or if you have a key acceptance situation that you have no clue who you've actually accepted the key for, or public key for. This is something that I see happening quite a lot, where you have a statement saying, oh, just like with SSH and fingerprint, the first thing that I type is yes. Yes, but was it the actual box that I was touching? Is it the box that I'm actually administrating? Well, in some cases it depends. Perhaps that would be the attacker intermediate to the actual box that I'm servicing. How do I know? Well, this is where you need to vet identities for machines and humans. Perhaps in that order. Now, this happened. This is basically also one of the, so this is a bit of the closing thing, so I'm gonna kick 1 or 2 minutes. So we had this little bit of a crisis with this virus going on, this biological virus, not the ones that I typically am working with. Yeah, and basically they stated, create 2 contact tracing apps. Okay, how do we do that? Now, you've probably seen all the news about that. But we've created these 2 apps, which is the Corona Melder and the Corona Check in the past. And both of them had all kinds of key material and cryptographic things going on. This is also why you had for the Corona Check, the QR code business, there were 2 QR codes. There was one very large QR code and there was the smaller QR code. And the larger QR code, the one with more data in it, had more key material and less personal identifiable information. This was the Dutch mechanism. The other one had more personal identifiable information, which was the mechanism used in the EU and beyond the EU, actually. But all the data that we've stored and all the parts that we don't really have to store, most of the system is just a signing operation system. All the signatures went through an HSM, or at least a key signing mechanism, and everything was HSM backed, which was quite a bunch. Now the Corona Melder was really something that was created really fast, and all the other systems, we had to develop it really fast, and there was only one solution to do it open source, fully. So including all the cryptographic things, everything, if you want to have a dive in what type of mechanisms that we've used, everything is published on GitHub for the Ministry of Healthcare, VWS. We are a very strong supporter of August Kerkhoff's, at least Kerkhoff's principle, in saying that the keys should be very safe and secure, and the entire mechanism should be fully open as much as we can. No exceptions, at least we hope no exceptions. We haven't seen any exceptions so far. Any other exceptions will be prudent and stated, this is not an exception required, please publish this too. So even the cryptographic analyses are published. And we've even used, one of the hackers who actually thought of the idea of using a YubiKey as an HSM in operation. We couldn't buy the HSMs. These are very tough devices to actually get a hold to in a very small amount of time. So one of the tricks was to actually use a YubiKey as an HSM, and this is what we've actually used, and it worked very darn good. On the other system, the Corona Check, we had a bit more time, and this is where we had a park of 5 HSM devices. This is also basically because of that experience that through an intern that I had at NICHEF, I got a hold of a contact at RIPE, and RIPE people stated, hey, we're working with HSMs, or we want to use new systems and consider new opportunities for our PKI. And I thought, oh, those are cool things. The HSM thing, the cryptographic thing, and our PKI is cool. And one of the things that I basically helped with is that there is a lab in Leeuwarden of the government where we had a lab of HSMs. Now this is something really, it's really odd to actually have. It's very complicated stuff to have. Then have somebody who have an archaic knowledge about HSMs for so many years. It's interesting to see, and this is what I've helped with, and this is why I have a RIPE shirt, because, well, he brought me a RIPE shirt, and I work, sometimes for kudos and t-shirts. So yeah, so are these hardware security modules perfect solutions? Well, yeah. Yeah, So this backstory that I heard from people who are actually very near to that situation is if you leave all the keys every time on the devices, in the devices, and basically you've unlocked the device where you would say, enter PIN, you enter the PIN, then leave, go for coffee, and have a field day for next month. And then you get hacked, and that gets combined into this. This is basically what DigiNotar is in 2 sentences. Thank you.
Thank you, Oscar. I would imagine that there will be some questions for Oscar.
Go ahead.
Well, maybe I was just imagining. I hope not. There is a question from the socials, I guess.
Yes, we have a remote participant, Wouter Prins, asking, if you have multiple HSMs serving the same goal, how do you distribute private keys?
It's interesting. I just had a talk. What was the name? What was the name of the person that stated it?
No.
Oh, sorry, maybe not. Okay, so it could have been. It's interesting. I just talked about exactly this situation and how to deal with that scenario this morning when I was at Sloterdijk still and saw some old colleagues from KPN walking over, doing crypto. So there are a few options to do this. The answer of the private key and getting it out, sometimes there is a very secure escape hatch. This is where you need to have all the key custodians and the operator and so on at the same time. So sometimes there are options to escape a private key if you really wish to. But it needs to be set up as such, and if it's not set up and certified to never ever do that, this is why you need audits. There is a motivation for audits. This is one of them. If you want to state that private key exportation is never possible, you have only one option. You could buy exactly the same hardware security module and the special cable typically or something else certified, and you could have one cell. Basically, it's if you have a jail, like a jail cell, and basically you have a jail cell, but then fully interconnected. This is just like the ET scene. You know the ET scene where they have all kinds of tubes going and that the alien will never go out? Basically, that kind of tubing is what you do to the other cell of the other HSMs next to it. So you could create a private key and it will never leave out of the context of the HSMs, but it will then be certified, connected to just the other HSM of the same type of model. So if you see an HSM and you see only one, and there's not a brother or sister HSM in the other data center, you have a business continuity management issue because those keys will die when this device breaks down because everything breaks. But there is an opportunity to back up the keys to another HSM. Did not anticipate that complicated question, but good one. Very good.
Any other questions in the room or from the socials?
Saw a hand over there, but not really sure. Yeah.
Could you? I know it's a hassle, but could you please go to the microphone for the benefit of the many online viewers?
Backing of private keys on the inside of the HSM is a pain. So one of the tricks that they do when you set up a system is you can pre-populate them with keys, not really assigning them to a certificate, for example, having the pre-populated keys, do the magic with multiple HSMs, have all the keys to the other device, and then you distribute the HSM to multiple data centers, and then put them in operation.
Yeah, a question about the YubiKeys being used to sign the Corona app. How many YubiKeys did you have to use to actually get the performance to sign all of those QR codes?
Well, the QR codes were not signed by the YubiKeys. This was the backup of the keys that they required for. So basically, you have a key on a key on a key sometimes, signed by or enveloped trick. One of the keys, at least that was the root for the Corona melder, so this is not a QR code solution, was on the YubiKey, if I'm not mistaken. There were other applications which were also very important. There were 20 or somewhat unknown applications. Everything is open source, you can read the code. But all those other applications used, at least in the early things, used the YubiKeys to back up their keys. And the other things, yeah, those were Itimacos, two of them in a data center, 2 production, 2 acceptance, 1 testing.
Okay.
We still have those. It's interesting to actually have spare HSMs. prototyping. So if you have ideas and want to prototype on the Utimaco, have a call.
There's one final question from Robin. Knowing you, you will probably be asking about a do-it-yourself solution now, right?
You're absolutely correct.
Okay.
About the YubiKeys, I've got a spare one lying around in my drawer.
Yeah.
If I want to improve the security of my own private keys, is that possible? And where do I start looking?
What do you mean? Do you want to clone them between the two,
Or
the kind of keys?
I currently have my private keys somewhere on my computer,
Yeah?
which is somewhat secure. If I want to improve my security and I have a spare YubiKey lying around, is this possible with open source software? Where do I start looking?
No, because the YubiKeys are typically set up in such a way that you can never export the private keys, so you cannot clone them. But look, this is a picture of yesterday night. No, 2 days ago. So this is my setup. I've got, you don't see him. So these are my keys, and I've got 4. That's because I know I should have 3, but I have a spare. And the black one, for example, always stays home, but the other one's always at me. So this is how I basically deal with that. And then the services, like for example, let's say GitHub, for example, is pretty well known. I just load in multiple keys and then have my business continuity management with having multiple keys that could each of them break down and not have a sweat. That's my solution. Hardware backed, but I need to back up the keys into, in this case, discrete 2 private keys, and I have to assign the 2 private keys to me and my account.
Okay, thanks.
All right, thank you very much, Oscar. We have a small present for you for your presentation. And that means we go into the coffee break now. It will be until 11, exactly 11, and please be back at 11. All right, welcome back for the second part of this NLNOG day. And now we are going to dive into the networking bit, and it's going to get complicated. Oh no, that's only what our customers always say when they have to do BGP. Anyway, I don't think it's that complicated, but you can complicate matters if you are a network vendor and you don't, well, I don't know, maybe you don't read the documentation, or you misinterpret the documentation, or you do whatever. But anyway, network vendors have the tendency to write software for their boxes, and there may be one or two issues with that software every now and then. Recently, something has been discovered, and to tell us all about it is fresh from Schiphol Airport, Ben Cartwright.
Cool. Hello, everybody.
You should be good. Yep.
Okay. Cool. Cool. Hi, I'm Ben Cartwright-Cox. This is BGP error handling, which is a sort of upgraded version of my blog post that you might have read. The first and most important mandatory, I suppose, I run a business which involves being peered to many IXP root servers and people's routers and stuff. I won't test exploits on them, I promise, unless you give consent to have your router target practiced. All testing in the post was done on VMs and physical hardware, for the rare case for Juniper, where it's harder to emulate that stuff. Starting off, recently, a Brazilian ASN started announcing a IPv6 route with an interesting BGP attribute. It was interesting because it basically killed every Juniper device that ingested it, which is cool. Of course, that's okay for pairing to some degree. Like, if your pairing sessions come down, like, it's not great. That's really less okay if it's a transit session, because that's potentially like going to disconnect you from the internet. The one interesting thing, the one that brought it to my attention, I know many different ASNs got impacted by this, but Colt, like British, like super carrier, mostly British, I assume, basically got de-peered from the internet entirely. Other ASNs got hurt too, as mentioned, but Colt was the big one, and that's what actually drew my attention to it, because it inconvenienced me. So the offending payload on this packet was extremely boring. Basically, it's attribute 28, BGP entropy label capability. Looking at the RFC, it's interesting. It's effectively, I assume this was originated from a Huawei device, and somehow like an iBGP attribute got regurgitated back straight out into the internet. This attribute is technically not corrupted. It's, as one would expect, like a BGP entropy label capability attribute to look like. But however, just this presence of here and it interacting with a Junos version of around 17 and above, I don't have all the versions, so I can't do a binary search on the exact vulnerable version. But around 17 plus-ish would basically blow up the session, which is bad. So BGP attributes. There are two sections of a BGP attribute. There's the NRI and the withdraw data, aka basically what prefixes you're dealing with. And then there is the attributes. In BGP multiproto, those things are also in the attributes, but that's a detail that it's not worth thinking about. So attributes contain useful stuff like the AS path, your community values, local pref if you're iBGP, med if you're on eBGP and you care about med, aggregation info, stuff like that, stuff to describe a route. There are a lot of attributes out there. There's about 200, the 209 are technically unassigned, so up for grabs if you are willing to work with the IANA. 14 are deprecated, 32 are active. And that basically just means that there's no formal definition for them being not used anymore. Most of these, however, like still, even the active ones are not actually used anymore, or increasingly rare, or only used in iBGP environments. A very, very vanishingly small amount of these attributes you'll actually see on the real internet that you would get from like a transit provider. But you know, what about the ones that are technically deprecated? What about the ones that like you wouldn't normally see over a transit session? They surely must be handled all correctly, right? So, picture this. You're on a friendly internet exchange, everyone's nice and happy, and they're all connected to the root server. And then someone goes, hey guys, check out this really cool BGP attribute I found. And some people get blown up. Basically what ends up happening is, upon receiving the attribute, the people who are vulnerable to the session on the other side will basically go, I don't know what that is, and immediately like reconnect the session. Just disconnect it down and probably reconnect. So this is pretty bad. Losing root servers is a fantastic way of shifting a large amount of traffic for a large amount of networks. This is bad, but the really bad one is this sort of scenario. in where, once again, hey guys, check out this cool attribute I found, and where you can target specific devices, because not all of the operating system vendors are vulnerable to the same things. So you can effectively skip vulnerabilities across the internet and have them target the device that you're looking for. So for example, if in this hypothetical situation, where NTT runs GNOS, Cogent runs iOS, and then you are running Extreme, then you basically can get blown up because you can send an attribute out through NTT, which will get carried to Cogent, and regardless, both of your sessions will explode, because Cogent will happily carry an attribute that it doesn't understand. Funnily enough, in RFC 7606, which is one of the RFCs that if your vendor implements correctly should mitigate all of the problems I'm about to describe to you, has a securities consideration section that I can best describe as bang on the money. RFC's security consideration sections have always, in my eyes, not been massively helpful. However, this one perfectly describes the situation that I found myself in. I won't read the entire thing to you, but I will basically read out the bit that made me laugh when I read it for the first time. Since significant fan-out can occur between the attacker and the routers that do recognize the attribute type, this attack could be potentially particularly harmful. That's pretty correct. It can be particularly harmful. So how do you find all these problems? So first, you're going to basically build a fuzzer. A fuzzer is a type of security program that basically cycles through as much random data as possible to try and highlight as many different code paths. And the idea is that the more code paths you highlight, the more broken stuff you're inevitably going to find. The way this particular fuzzer works, basically I just custom built a script which goes through all of the BGP attribute types and just fills those attributes between 0 and a random number of bytes. Hoping that at some point some device will pick it up and be like, oh, I'm going to try and decode that, and then potentially explode while they do. This is fine and all. However, what I also want to check is whether it has a internet bullet status, and that basically is defined as something that you can actually worm across the internet, because you can peer-to-peer, you can blow up any session you want. You can just send random data, and yeah, sure, the session is probably going to shut down. The really interesting / terrifying stuff is something that you can give to someone and unknowingly they would pass around the world to pass to their peers, which then causes bad things to happen to people onwards. That's the really interesting stuff. And so that's what I was looking for. So to do that, I basically used Bird2 as a sort of filter for the stuff that clearly wasn't achievable, or just stuff that you couldn't worm, because Bird handles a lot of bad attributes very well. RFC 7606 compatible, and so I might as well go and use that. So all of the stuff went through Bird before it got handled to the target vendor being tested. And to clarify, the way the fuzzer works is it can run unattended, so it means I can just spend most of the time setting up a router vendor, and then just turn the fuzzer on, go and do something, make a cup of tea or whatever, and then check back later to see if the sessions have exploded. The way it knows whether the session has exploded, given it's not directly connected, is that the victim router announces a IP block that it monitors, and if the block is withdrawn, then it knows that it just sent something that killed the other side. In which case, it'll then withdraw the dodgy attribute, or the dodgy announcement, wait for the other side to come back up, and continue fuzzing onwards. This is roughly what it looks like. So you run the program, it connects to the first hop, and then on the Bird side, you can see it announcing the highlighted bit, the bgp.ec. EC is the hex code for the type, and then the contents in there is the random bytes that the fuzzer generated. So how did we do on this fuzzer? So surprisingly, MikroTik, no issues. Didn't log a single error. This is also Router OS 7.7. Obviously, Router OS is slightly infamous for having different behavior version to version, even the minor releases. So unknowing if anyone in the room is actually using 7.7 in particular, but if you are using 7.7 in particular, then you're actually safe. Ubiquity, also, to me, surprisingly, which will become clear later, no problem. No issues detected. I suspect the Edge OS devices forked off Quagga a long time ago before Quagga and then FRR grew any of the features that would soon to become problematic. So yeah, I thought that was very interesting. Arista EOS, at least the versions I tested, no problems. Didn't log anything, although then again, I'm not a deeply experienced with EOS, so it could be logging it to a place that I never found. But I did do a good look, and I couldn't find any errors, any error logs, which would be helpful, because it's useful to know when you encounter something on RFC 7606 that handles, basically if that RFC handles a bad attribute, The old behavior was to blow up the BGP session. The new behavior is to turn it into a withdraw. So it would be nice to know if that behavior has been triggered. iOS XE, XR, and Classic. Also, no errors. They log the issue perhaps a little bit too verbosely, to the point where if you're logged in on the serial console and you're getting slammed with this stuff, your serial console will also be getting slammed with this stuff. That's slightly annoying, but also it is what it is. It's better than nothing. You can turn off all of the messages if you want, but once again, it would be nice to know. Junos. So we know about attribute 28 already because that's the one that started this entire adventure. It turns out attribute 29, one up, also has a similar problem. I say not disclosed publicly, that's an old slide. It is disclosed publicly, as you see, as seen in JSA 75210. Basically, similar thing, corrupted attribute causes thing to explode. So you can mitigate this, and you should mitigate this by going into your Junos config and adding bgp-error-tolerance. You can enable this without any downsides. So it will instantly activate the new behavior. It won't reset any of your sessions. I don't think there is any downside to adding this. So please, for the love of God, add this. There is no reason to not, in my eyes. And Nokia SROS, there are loads of ways to pop a Nokia SROS session. I won't describe them all, but some of them overlap with Junos. Nokia also has a way of handling this correctly. It is also not default, so you have to add that there. Basically, you go into your BGP groups and type error handling update fault tolerance. That then makes it work correctly. Because I think that this one was particularly obscure, people were already stung by the Juniper issues, but the Nokia stuff hadn't seemed to have been impacted by any of these problems just yet, probably because the attributes required here are slightly obscure, and so just had a very low chance of actually appearing on the internet. So I viewed Nokia when I was researching this as sort of like a high risk, because I suspect no one had actually, I suspected and was actually reasonably correct in the end, that almost no one had actually activated error handling update fault tolerance on their SROS boxes. I would like to thank the following people. Okay, I redacted a few. I would like also to thank the people who probably know that I notified them for enabling it. Me contacting them and be like, hey, are you aware that your router, your edge could be exploded? They generally took the message well. So yeah, thank you to those people for doing that. It's also worth pointing out that Nokia has released a statement or a bug issue thing under 230450B. You can only view that if you're logged in to the Nokia alerts portal, but if you are a Nokia customer, then you can view that. It basically says everything I just said. Huawei Net Engine, no issues detected, which I think is very, it surprised me at least. I was expecting something from that platform. But also, finding Huawei images are extremely difficult due to the nature of sometimes import restrictions, things like that. I can't even acquire test hardware, which makes it very hard to actually just get a physical box off eBay and test it. So there may be bugs in other products, but I couldn't find anyone in this particular product. FRR had a very similar issue. If you sent a corrupted tunnel encapsulation, which you can send regardless of whether it's an IBGP session or not, the session would explode. It was assigned to CV, and it was fixed post-public disclosure, is what it is. Was a little bit annoying to have to go through public disclosure and then have FRR fix that problem, but open source. OpenBGPD, which was surprising to me, exploded on an invalid origin to customer, only to customer. Handles the behavior correctly with all the other packets. It's actually turned out to be a much more interesting bug in the OpenBGPD that seemed to only be reachable with this type of attribute. This was fixed in OpenBSD, signed to CSV, CVE, whatever. Extreme. So Extreme explodes on two attributes. Both are pretty obscure. And actually, the problem here is that if your attribute is obscure, you have a higher chance of it being exploitable. Because as per the rules of BGP propagation on unknown attributes, if your router understands the attribute, then it may handle things, it may apply RFC 7606 processing to it. If it doesn't understand the attribute and the transitive bit is set, then that's going to go across all around the internet until it hits the target device that does understand it, or understands it. And so that's really bad. So if your thing explodes on an obscure attribute, that's really bad, because that allows you to target extreme devices in particular. What's also very bad is after contacting Extreme about this, there is no mitigating config by default, and Extreme does not want to patch this. Their argument is that the RFC, the original BGP RFC, declares that you should explode in these situations, and therefore they will explode in this situation. There's a bit further on this, but basically there's a CVE assigned for this. It's currently being disputed by Extreme, whatever. So this is an email that I exchanged, the final email exchange I had with Extreme. I won't read the entire thing to you, but I will read my favorite bits of the highlights. We are not considering this a vulnerability due to the presence of RFC 7606. We are evaluating support for RFC 7606 as a future feature. There are some nuance in the middle, but this is one of the strangest security discussions I've had. So extremely strange that I would really recommend you actually read the entire email exchange, which I posted and mostly redacted the names out of, just because I wouldn't believe if I said that to me in the future, in the past or whatever. So I reckon you should look at that exchange. It's very strange. Yeah, to clarify what Extreme is saying, to clarify what this is, any AS can emit a BGP message with a corrupted v6 extended community attribute, a v6 address specific extended community attribute. It will get carried around a bunch of global networks, and when an Extreme device ingests it, it will reset the session. Now, because it's going to be propagated globally, that's going to be your transit session. That's going to cause your transit session to flap. That's going to be bad. Even better, though, it's going to flap over and over again, because when it reconnects to do a feed, it's going to ingest the same poison pill and then reset again. Not great. Actually, the better part about this is that if you are running, this doesn't even impact your edge devices. If you're running Extreme in your cores, then if it's got a full IBGP session, it's going to ingest that inside your core, which may be even worse of a place for it to do, because that might be a place where you have even less redundancy. So having that device go offline, as far as routing is concerned, could be even more catastrophic to your network. So yeah, thanks, Extreme. I don't, yeah. Here's my rough review of the security responses. You know, both of the open source vendor did a very decent job. My only slight regret is telling them a little bit too early on. I felt slightly pressured to allow OpenBSD to release a disclosure publicly a little bit too soon than I wanted to, but I've later been told on that OpenBSD is much more willing to handle coordinated disclosure in the future. I just didn't feel like it was that way when I talked to them for the first time. Juniper, they replied, they eventually pushed out a Junos patch. They didn't commit to enabling this behavior to be safe by default. They haven't committed to that. Nokia replied, and later has confirmed to me in the last few days that from March 2024, SROS versions will ship with this default safe behavior. They eventually did customer communication. I have a feeling they only started doing customer communication after I started going after their customers, because I was worried about the risk. So yeah, not so great that needed to happen. FRR, when I emailed them, very quick reply, acknowledged the issues, and then disappeared completely. No email replies after that, and then only patched after public disclosure. And Extreme, well, you saw the Extreme. Yeah. Most importantly, or at least to me, none of these vendors have any bug bounty program. So kind of reporting this was a giant waste of my time. You know, I would, in a normal situation, had this not been potentially internet bricking, I would have just sat on this and sort of put this in the filing cabinet, being like, oh yeah, cool, there's a small nuclear weapon in my home directory, because this took a long time to deal with. Like dealing with these vendors, sometimes it was frustrating for some of the vendors to be like, you know, reminder, like I'm not paid to report this to you. And you know, you're asking some sometimes very tedious questions, or alternatively forcing me to argue my point of the risk. You know, sometimes I now have to go, in the case of Nokia especially, like I now have to go, and Extreme to some degree, I now have to go to your customers and be like, hey, over IRC, do you have this option set? Because if you don't, that might be bad news. I shouldn't need to do that. You know who your customers are. Please tell them that there are problems. So that's very frustrating. There's no bug bounty program. I find it kind of shocking that the internet is increasingly important to everyday life, and these vendors don't seem to have a high bar for, or at least a modern view of security handling processes. Of course, it's worth pointing out that there's a second newer level, there's an A+ on the security response. It's for the people who didn't have the bug in the first place. So I never thought that MikroTik would get an A+ here, but you know, it's fine. Credit where credit's due, they did the right thing, so good for them. Are there any questions?
Hi, Sander Stefan, Juniper customer and consultant to Juniper customers. To the Juniper people in the room, Melchior, could you please ask them to make the safe behavior the default? Thanks.
Yeah, I mean, honestly though, like in all seriousness, it would be really useful if vendors did. I understand the vendor's point of view around default changing. It's potentially terrifying. Go for it.
Hello, Melchior from Juniper.
Hello.
I'm more than happy to discuss it. I don't know. I trust that you say that it doesn't have any other impact, but I will discuss it with our BGP coders team.
It's a case of like I understand from the Juniper's point of view, I understand the hesitancy. Changing a default on platforms that have held strong defaults for the last 10, 20 years is a very scary thing. However, also the internet is kind of real now and does pretty pretty important things. You should be able to change defaults when it's of sort of critical security to do so.
Agree. Yeah.
Thanks.
There we go, solved.
Joris, yeah?
Hi, yeah, Joris from Arista here. So I just wanted to add that there are indeed show commands to show the BGP update errors.
Ah, okay, cool.
I've dropped them in the IRC. And there should also be some logging, but well. If
Yeah, I might honestly for the VEOS stuff, I might have honestly missed where it was going. So
right, okay.
Any other questions? Yeah? Good. Make your way to the microphone.
I know the person asking this is here, but was Brocade MLX or SLX tested as well? Since you mentioned.
Sorry, say again.
The Brocade MLX or SLX?
I don't have a Brocade MLX to test, and I don't have virtual platforms, which, given that the average size of a Brocade is huge, I didn't want to lug that into my living room.
Okay, thanks.
Also, power is expensive. We're in Europe.
Hi. Do you have any experience or thoughts of applying filtering onto the attributes?
So that's an interesting point. So when I explain this to someone, they're like, "Oh, that's fine because like surely if I filter these routes, there's no problem." There's two problems with that. One is that almost all, I think, in fact, actually, I'm pretty confident to say all of these bugs happen pre-filter step because it's happening when the BGP daemon is parsing out the BGP update, and so you can't really filter these out. However, there are hidden options on certain platforms. I think Juniper has one, and I think Cisco has one as well. Don't know which flavor of Cisco, where you can drop these. You can drop a list of certain attributes, and so there's a whole bunch of. I know a bunch of tier 1-ish carriers who are dropping certain attributes inside their cores to stop propagation of certain bugs. Okay. But I don't know if it's fair to disclose which ones are doing that and what attributes they're doing. But yes, there are technically hidden functionalities to do this. I think.
So since you have a reach to a lot of vendors here, how would you recommend to them to implement the bug bounty programs?
I mean, I'm not the right person to ask, but I don't know. Like, there are platforms like HackerOne. I don't know if they're any good, but like, yeah, I am. As I said, I'm not I am the BGP tools guy. I'm not a network person, or I'm not a security person at least. So I don't know the actual decent answer to that. I'll happily let that to someone who actually understands how bug bounties are supposed to work.
Hi, Will Hargrave from Lonat. Sorry, this microphone's configured for Dutch people. I'll stand on tiptoe. So to be clear, what, as a set of recommendation to vendors, I think what you're saying here is the gold standard is RFC 7606, treat as withdraw for bad attributes, and that's what you would like vendors to have that turned on by default. Yep. The kind of silver standard is yes, at least we have a knob so that people can turn this on, and the poo standard is we don't have any support.
Yeah,
for
we don't think
withdraw.
that the bug is real.
Okay. Yeah, that's the kind of useful key thing I think that I'd like to see as perhaps a closing slide there on your presentation, because it says what pressure we should apply to vendors to look after the internet better.
I mean, sure, but on getting back to that though, the response also matters on like the quality of reply, right? Like if I if this, once again, had this not been completely internet breaking and I had reported it, I would have probably given up. I'd just be like, you know what, guys, whatever, do what you want, because actually I'm just going to keep this in my drawer and you do whatever you want with it. In fact, for at least one of these vendors, there is a further on bug that I just don't care enough to report anymore. Because, like, why would I? Like, if they were relatively, like, unhelpful in the first place, why would I report more to you again?
The absolute shocking thing for me is that actually I worked on a bug like this in, 2009, I think, with confederations, and that's what led to that treaters withdraw behavior, and it's like, that was a long time ago now. I look at mailing list posts and it says, 15 years ago I posted something. What?
No, and there was a previous one in like the 2000s when, early 2000, maybe this is a 2009 one, where Ripe published a route with like attribute 255, which caused a bunch of Ciscos to explode. This is not a new bug by any means. I think what's interesting here is that I sat down and was like, okay, let's do a like comprehensive test on every single major platform, in my eyes at least, ones that people are using, at least at the edges. And it turns out there's still broken stuff.
Yes, thank you for doing that.
Thank you all for your questions. Thank you, Ben. I have one more question myself about the reporting of the issue. You wrote in your blog that it was very hard to get in touch with the vendors, basically because you were not a customer of them.
Yes.
I can imagine that there would be people in this room who would be able to help you with this sort of thing in future.
So it turns out when you blog about something like that, your inbox suddenly becomes flooded with lots of really interesting people at vendors who are like, I'm really sorry about that. You can just email me personally next time. I'm actually set for that now.
Perfect, thank you. We have a small present for you, which I'm sure you'll like. Yeah, Ben Cartwright Cox, everyone. BGP.tools, if you don't know it yet. As you will have noticed, and I'm going to jinx it now, of course, the internet connection here today is absolutely perfect. The thing is that we have a special deal with a sponsor and another company, and actually what they did was they got us a temporary port on the existing fiber that goes here, and so we have a network here today that is totally separate from the Podium Mosaic one that we used in the previous years. Now the funny thing is that this connection, it wasn't working yesterday evening yet. I mean, we came to the venue here and the question was, how do we get that port up? Well, at the goods entrance at the back here of the building, in the pavement, there was this small cyan tube that stuck out of the pavement. And I think everybody knows what that means. Delta is on its way. Fortunately, this was not the fiber connection we were looking for, but it does show you that there is some importance, not just in BGP and BGP error tolerance on the application level, but there's also importance on the layer 1 side of things. And just like with the HSMs from that Oscar presented about earlier, there is another subject that we wanted to show, to have in this NLNOG Day for a long time. And the subject is undersea cables. How does this actually work? So we asked Martijn, because we thought he is the expert on this, but he disappointed us and he said, no, I really don't know much about it. You need to talk to Bob. So here is Martijn, and there is Bob. Gaan jullie allebei of afwisselen? Om de beurt. Ja. Hier staan dan, alsjeblieft.
Yeah, so cables under the sea and other nautical nonsense. First of all, a little bit of a disclaimer. We don't operate an optical network ourselves. We run some DCIs with, on smaller distances. But we are not a transport provider, so most of these experiences is what we've encountered day to day. And also in the past, when I started as an intern at KPN International, visited some sea cable stations in the Netherlands. So there we go. So i3d.net, we are a game hosting provider. Oh, it's a bit weird, but we have a presence of 60 POPs. We have over 40 compute sites shared across 6 continents, and our backbone is connected mostly using leased wavelengths. We have capacity on over more than 20 subsea cables, mostly 10 and 100 gigs, but on a bad Monday, Martijn tends to source an STM16 or 2.5 gig if he has a bad day. We are connected up on more than 100 internet exchanges, and we are connected up to 9,200 unique ASNs.
So I'm taking over on this one. So why do we actually go through all this effort, right, with the subsea cables and the own backbone and whatnot? Because generally speaking, IP transit is cheaper than building your own backbone. But the thing is that you're paying your euros per megabit for that blended traffic consumption. So the transit providers are including some clauses in your contract, like you cannot use more than X% of your total traffic to another continent. You cannot do more than X% of your traffic to any one neighbor if that is a particularly difficult peer. And that means that while backplane transit is practically free, it subsidizes the expensive long haul, where they would otherwise be losing money. And why in i3d.net's use case it's possible to be cost efficient anyway is because we originate the traffic and we peer locally in all the continents. So our subsea capacity can effectively be used bidirectionally. So you can see that in the graph in the bottom right that it's pretty much symmetrical traffic. And you can also see how much of our traffic is actually using the backbone. It's around 26% of the total. So on the technical side of the equation, we also have some reasons to do this ourselves. So we get some extra control, stability, and visibility because long distance performance is very important for games. Think about it, if you want to play with your buddy in Los Angeles or in Africa or whatever, somebody needs to travel the distance. You can't cache that, right? So not all network service providers or their customers have the same priorities. So that's why we decided to build it ourselves. We also have blast zone reduction, right? Because instead of having 1 or 2 or maybe a couple hundred neighbors, we have a couple thousand. So if something explodes, we are not that badly affected usually. And we can also see what is truly the capacity to some destination, or we can perform our own mitigations if it's saturated. We also have some great visibility on what's happening on the internet, right? So Arjan's BCP38 talk later today will show you some cool things we can do with that. And the last thing why we are using our own backbone is for DDoS mitigation. So we found in the past, when we were still using tier 2 upstreams many years ago, that especially in complex regions like Middle East, Africa, whatever, they would literally melt under the DDoS attacks that we are getting. So the graph that you can see is like 1 week of DDoS attacks in our network. And yeah, it's very busy. So we are scrubbing that basically at the ingress, or like at the point where the backbone becomes expensive, right? So the connections that go to the Middle East, to Africa, to India, and so on. And then we backhaul just the clean traffic over the expensive subsea capacity.
So now we will do a little bit of a history lesson. So the first transatlantic telegraph cable was laid in 1858. It could carry one signal at a time, and there is a little piece here. It's very neat piece of engineering at the time, especially since it only was active for 10 days. So in 1956, you had the TET-1. That was the first transatlantic telephone cable. It was coax-based. It could carry up to 30 telephone or 35 telephone talks at a time. Then in 1988, there was the TET-8. That was the first fiber optic C cable, and it had 2 active fiber pairs, and it had 1 spare fiber pair in the cable. And after that, an important milestone, as what we see now with all the content providers, was in 1997, the first non-consortium-based cable was laid, so it was not owned by a lot of telecommunication providers that all own a small piece of the action. Then in 2000, there was the longest sea cable built until to Africa is finished. The CMW3 cable is 39,000 kilometers long. And what I have here is a piece of the TET14 sea cable. It was the first cable capable of doing STM64s or 10 gig transatlantic. And special about this also was that there was in Katwijk a sea cable station where the cable actually landed. And this is a piece of the cable that I got from one of the engineers when the station was shut down. And we no longer have a direct transatlantic connectivity in the Netherlands. So in my time at KPN... Huh?
AC1.
Oh, AC1, correct. So, it was important for the Netherlands. And I learned a lot there from a lot of passionate engineers. So this is why I also know a bit on the topics that will come up next. So the different designs, most sea cables that are deployed nowadays are point-to-point. So especially the content providers, they are like really swamping and building out big. I saw this morning that Google also announced another new sea cable between the US and Portugal. They go directly from point A to point B. And in that sense, these cables have a direct route. They are purposely built and have a specific route. The more exotic cables, like you see on the bottom right, the CMW3, they have a fishbone design. They are more complex to operate, build, and also they have some express paths for regions that need a lot of connectivity. So if you, for example, want to go from France to Hong Kong, you can get a direct wave. But if you want to go to some more exotic locations, you will go via a few branches. And a branch is actually what you see in the top right. This is where the cable is split off. And some fiber pairs will continue. And other fiber pairs can be rerouted to another nation. Also multiple PFEs. I will have a slide later on about the equipment used for that, but this is actually the cable uses multiple repeaters, and they also need to be powered up because in the repeaters there are amplifiers. So it's a complex system to build, operate, and also where Martijn will talk about is the politics involved to get the cable laid, supported, etc. So a ring system, the TOT14 was a ring system. Those were mostly laid in the SDH SONET era. They offered protection to the customers. So instead of having a wet segment that is unprotected, you would have a fast switchover if an event would occur. And the last design used is a festoon. These are usually unrepeated paths. They run from landing station to landing station next to the coast. So usually that's used in regions where it's more efficient to not have all the power and the haggle of operating it. So this is a picture of the young me in the Katwijk sea cable station. So cable landing stations are mostly used to power up the sea cable or where the backhaul equipment it connects up to the sea cable. These buildings are usually just like data centers designed. They have all the UPSs, the generators, the cooling, etc. for all the transport equipment. Close to the beach is the where the wet segment connects up to the terrestrial cable, because as you can see, if you want to touch it, that the cables used here in the close to the sea is that they are very heavy. They have a lot of wiring to protect the cable, so it's very costly if they would also want to run it up to the landing station. So they're on the beach joint, the terrestrial cable and also the wet segment are connected together. Back in the day, also most landing stations offered co-location rooms. So a lot of providers would pick up circuits from the cable landing stations. But in the world we live in now, mostly you go to a vendor, and they will just deliver the connection from data center to data center. And yeah, what we also encountered is that on some of these cable stations, they will charge insane landing fees, where if you want to cross-connect from the sea cable to one of the providers, you will pay insane amounts of money to get it actually wired up.
I think the record that I saw is $40,000 per month for 1 gig.
So it's it's a crazy business there. But also with most of the consortium cables, the local incumbents that operate and are part of the consortium, they operate the cable landing stations. So for example, what you also see with Dunant is that Orange is heavily involved on the French side. So they will organize the backhaul. They also lit up some fibers themselves, so they can operate the sea cable station, have personnel, etc., to operate the cable. So there are 2 types of cables. There are unrepeated cable systems. They use laser class 4 amplifiers. These are high power lasers, so they can indeed, if you look into a laser, you can get blind. So for the personnel working in the sea cable stations, extra protection measures need to be taken, like glasses, stuff like that, to make sure that they are trained and know how to handle the equipment. Up to 400 kilometers can be crossed with this type of designs. We see it a lot between the UK and the Netherlands on the smaller distances. Compared to repeated cables, where I will talk about on the next slide, they don't have limitations on electricity. These cables hold much more fiber pairs, and I think that the Zeus cable had 200 or 96?
96 fiber pairs.
Yeah, 96 fiber pairs. The economical lifetime of these cables are mostly dictated by the amount of repairs. So you can imagine that in a heavily fished area where trawlers and anchors cut cables, cause damage, that over time the attenuation will get bigger, and the subsea cables will be less usable over time. Repeated cabled systems, they're every 60 to 80 kilometers a repeater is placed. These repeaters are powered from the shore, so on these sea cables, they reach voltages of 6,000 volts to power up all the repeaters. On the longer segments, there can be up to 150 plus repeaters in one of the sea cables. They are designed to have an operational life of 25 years, so they are really over-engineered. The amplifiers and the lasers in the repeaters, they have a big power budget, so even if they degrade over time, that the cable can still function as expected. The repeaters are powered from both shore ends. So what that means is that on the very long cables from both sides, the cable is fed with power, and this is also really necessary because it can't be powered from one side. So it means that if power is cut, then the whole cable is down, and also a shunt fault can cause, I will talk about it later, that the cable will be completely down. So the repeaters are also managed. So from the shore end, they monitor the performance and the status closely. They gather data on the degradation and the power usage of all the pump lasers over time. So this is really closely monitored to see if there are any indications that a repeater might fail before the end of its lifetime. And the funny thing here as well is that on a lot of the very old cable systems, also the computers installed at the time were also designed to have a long lifetime, so floppy disks are still part of the day-to-day operations for a lot of the engineers working on the sea cable stations. There are different type of cables, so for different segments of the path, also different requirements are there. So you have the lightweight cable, lightweight protected cable, the single armored and the double armored cable. And depend on the depth, the risks that are in the area for trawlers, anchors, fishermen, and also how much activity there is in the area, for example, with sand dunes that move around and that can expose a cable on the seabed. There are higher risk areas. And this is a single armored cable. It's also pretty heavy. And yeah, for here in the North Sea, yeah, there is a lot of activity. And on a regular basis, there are outages caused by fishing and anchors. And the lightweight protected cable, they are used for yeah, the deeper segments, because what you can feel is that if a ship needs to yeah, dive up a cable 5,000 meters deep, then it will, or the cable will collapse on itself, or the ship doesn't have the power to get the cable on board. And at real depths, there is also very less risk of impact, because there are no anchors, etc. at that depth. So the power depth of the power feed equipment. Yeah, at the time I also had a mullet, so you see also me evolve over time. Yeah, as I touched upon before, the repeaters are powered with the direct current from both landing stations. You can also see in the cable, yeah, the copper that is used to power the amplifiers. The cable is fed by negative and positive current, so one side will power up the cable with positive DC current, and the other side will use negative. Yeah, half of the cable is powered by one side. Shorter cables can be fed from one landing station, so in that sense the dual feed is there to improve reliability, and if there is a shunt fault, for example, that the system can still continue to work. Yeah, all cabinets, buttons and switches are really locked by import of very documented and strict procedures. You can see it a bit what you saw in movies on a nuclear launch pad, where all type of keys and buttons need to be pushed in an accept order to power off or power up the system. Also, a tone generator is in the power feed equipment, and this is also what is used by the cable ship and the other underwater robot to track and find the cable during repairs. So the SLTE, so this is the submarine line terminal equipment. This is where actually client signals are connected in from terrestrial backhauls to the wet segment. In this sense, you see a line shelf, and on a line shelf, multiple types of equipment and vendors can be connected in. A lot of the older cables were designed in the SDH era. So, for example, also with the TET-14, when it was designed, most of the waves or the channels were designed to also be connected up to SDH, so that yeah, they could multiplex multiple signals onto the cable. But when the cable went live, a lot of the providers already really wanted 10 gig, so all the SDH equipment wasn't even used. It's also optimized with enhanced VAC capabilities, all well monitored by NOx worldwide. And during the lifespan of a sea cable, usually the active equipment is updated, upgraded to improve yeah, the speeds and the capacity on the cable, because it's much cheaper to upgrade some active equipment in the cable stations than lay a new cable. The different types of faults that impact the different cable systems. You can have a complete outage or of power and fiber. So, for example, if an anchor of like a big tanker cuts a cable, then usually the cable is completely broken. Like you can see here as well, is that you see all the, yeah, you can see it as well. All the wires are sticking out and the cable is not working. You also have a shunt fault. This is where the insulation of the cable is damaged, causing a short circuit of the power. It's really hard to detect and measure from land, so these are the more difficult faults for the subsea teams to repair. And what you see as well is that on some cables, if they have the opportunity, they can reconfigure the power feed equipment to get the system up and running again. Yeah, repeater and branching unit failures. There are some horror stories about bad batches or repeaters failing. Yeah, then they also need to be replaced by the ship. That will come in the next slide. And also partial failures. This is also an interesting one. So, for example, in a cable with a lot of branches, if there is an unpopular branch with not much capacity down, then you see that the choice is made by the consortium or the cable owners to not repair it or leave it at a later point to not interrupt the majority of the traffic on the cable system. Cable repairs, well, on the right is the Sophie Germain. This is actually what I saw on X or Twitter a few days ago, that Orange Marine launched a new cable ship. Back in the day, mostly there were converted ships. Nowadays, they are purposely built, so they are really optimized that the ROVs, that the submersible robots can be launched in rough seas. Repairs go much smoother, and yeah, they're really optimized for the job. And what we see with the more modern cable ships is that repair times for the transatlantic cables are really good compared to other areas in the world. So, for example, within 2 weeks, usually you see a cable up and running again. And yeah, the ships work very closely with the cable systems because, for example, with the laser class 4 cables, if there are like 96 fiber pairs and everybody is ramping up laser class 4 amplifiers on it, then it can be very dangerous for the personnel working on the cable ships. So yeah, there are really safety measures in place. For example, that the board is really disconnected from the chassis, and also that the fiber is disconnected with a picture and a date on it, so that the cable ship knows for sure that there is no active laser on the cable. Cable systems usually join a maintenance agreement. So, for example, like the ACMA that we have on the Atlantic Ocean. This is more of a non-profit organization that contracts multiple cable ships for repairs and other emergency work. They have multiple ships on call-out, and usually yeah, the ship will then sail to a local depot, pick up the parts that are needed for repair, so like the exact cable or the exact types of fibers that were used at the time for that segment of the sea cable. And what we use ourselves is also marine traffic. So if we receive updates from providers, like, hey, we see that cable ship Pierre de Fermat will repair the cable, then we also like to see where the ship is at, where it is sailing, and if it already reaches the cable ground, because different providers have a different quality of updates. So.
Yeah, this is where I'm taking over again. So Bob talked a bit about when things are going according to the plan and the design on the layers 1, 2, and 3 of the OZ model. But I'm these days spending more and more of my time in the higher layers, so to say. So things can go badly wrong with these subsea cables, and it's not unusual to have like outages expressed in months or even years. So it's a game of playing the odds. Like, you have to see what is the frequency of the outages on a particular part of the world, what are the duration of the outages, and what's the impact of the outages if they happen, right? So I really like RFC 1925, the April Fool's joke from the 1990s, which contains the 12 networking truths, and it's also applicable to sea cables in many ways. So yeah, it has to work, so you end up building enough redundancy. It's more complicated than you think, right? Even knowing the technical parts, there are problems that you may not have considered from an engineering perspective. And it always takes longer to solve than it seems like it should. So you remember how Bob was talking about calling the cable maintenance agreement and or association and just going, right? But not all subsea cables are operated by groups of companies that subscribe to one. So they are instantly to the back of the queue. And then if there are more cable faults than repair ships in a given CMA zone, how do you determine the repair sequence, right? Like if there is a natural disaster that takes out a whole bunch of them. So are you going to go, the first cable that was down is the first one that's repaired? Are you going for the highest capacity cables first? Or are you taking the least connected countries first that have maybe only 1 or 2 paths to the outside world and are therefore at risk of total disconnection? Well, sometimes it can even be you repair in the sequence where there's no nuclear fallout at the repair grounds, because that happened with Fukushima in 2011. And even in the very best case, you're talking about a multi-week repair job, right? Because the ships don't move as fast as the repair crews on land. And yeah, the repair work can also sometimes pause in the middle of the repairs. For example, if there's bad weather, like a typhoon or a cyclone or whatnot, or even a live fire naval training exercise from the military near the repair grounds. They don't care about your subsea cable outage. So then, did you think you could just sail out? The governments are also following RFC 1925, and then especially the part where it's always possible to add another level of indirection. So you need a permit to operate the repair ship in the country's territorial waters if it's not in the middle of the ocean, right? And it's no big deal in Western countries. Like, for example, UK, Netherlands, you will see that it's almost instant to get a permit. But if you are in a certain part of the world, then it can take a very long time to approve the repair, even if that country is itself a direct victim of that outage. What if multiple countries are even claiming the same territorial waters? Like, there are cases where there are like up to 4 different claims on the same section of ocean. Are you going to get permits from everyone? Or are you going to skip some of them and risk offending people you do not want to offend? And then there's the beauty of cabotage policies. So some countries have like a policy that any job in its territorial waters needs to wait for a certain amount of weeks for domestic bids to come in. And if that country has no company that operates cable ships, then you're basically just waiting for a couple of weeks before the real bidding process can start. And then even if you do have like a domestic bidder, then certain countries may not want to use the services of certain other countries. And then we have a thing that's fake network diversity. So even if you're using multiple subsea cables, you may have some interesting multiple faults that can happen, right? So coastal waters especially are really the danger zone for subsea cables. Bob mentioned the trawlers, the anchors, and so on. And yeah, underwater landslides can happen. In Africa, the Congo River mudslides are a recent occurrence. In fact, in August, we had an outage that took, I think, 3 out of 4 cables on the west coast out. And then you could have, for example, flooding on the area where all these cables are landing, right? So New York City is a well-known landing position for these cables. But Hurricane Sandy in 2012 flooded a lot of data centers, not where the compute infrastructure was, right, or the technical equipment, but like the mains grid may go out, you can't refuel, maybe even the generators and the fuel is stored in the basement, right? And yeah, then you are pretty much stuck. Then if you are all forced to use the same incumbent's fibers in a certain country, right, to do the backhaul, then you might have maybe 10, 20 cables that are crossing through that country, but yeah, really it's just 2 cables. And then you could have, for example, terrestrial backhaul overlaps. If you are landing in the same area, let's say that you did your best job with the KMZ design. Turns out that some providers, they have the thing called they need to have the same path, but that means they just follow those hops between the ROADMs. If there are 2 paths between the same ROADM, it can happen that you are on the wrong path. And yeah, then you have an interesting challenge. So when we are planning for true network diversity, well, we built in our case, for example, the transatlantic segment on triple paths. And those landings are in locations that are hundreds of kilometers apart. After we were taught a lesson by Cyber Squirrel, so rodents against internet basically, and the same exact path mistake that I just mentioned. So we have at the moment London to the Newark, New Jersey area, the default route for many network service providers. We have Amsterdam, Montreal, which is passing through the UK but avoiding London completely. Though it's a relatively longer path to the big interconnection hubs, right? Because in Montreal you will find Canadian ISPs, but not even all Canadian ISPs. And the US ISPs, you have to go down at least to like Boston or something, where unfortunately we do not have a i3d.net POP. So we might need to mess a bit with IGP metrics to find the correct balance of traffic. And then you've got Paris-Ashburn on the Dunant cable that Bob mentioned. So you have a far southern route, which doesn't cross again with any of the other two. But yeah, the latency is higher because the further up that you go to the north, right, the more that you benefit from the curvature of the Earth. Like you can really see the globe and the way that it's like distorted when you try to flatten the sphere. So as it turns out, if you stick to the north, like the distances are much shorter than they appear to be on a flat map. And so now we are adding even a fourth path between London and New Jersey in our case, because traffic is naturally gravitating to that bundle because of the size of the interconnection hubs of London and New York on both ends. And yeah, it further improves the diversity, but yeah, with the caveats that I just outlined. Then we've got capacity crunch, for example, the political edition. So building a cable is a multi-year endeavor. You're talking about 2-3 years in the very, very best case, and often more, right? So you have to find investors, you have to perform marine surveys, you have to contract with the manufacturers, the cable layers. You might have to build a CLS if you're not reusing an existing one, right? And what we saw is that the US-China rivalry affected new trans-Pacific cables. So PLCN is a cable that was going from around Los Angeles to Hong Kong, and it was already late. But then Team Telecom, from the US telecom regulator FCC, decided that they would reject this cable activation unless the Chinese consortium members fully divested and the Hong Kong branch was deactivated. You also saw, for example, Bay-to-Bay Express that was reconfigured to CAP1 without the Chinese consortium members, and again, the branch towards Hong Kong and so on, replaced by the Philippines. And now you're also seeing that several other cables are being cancelled, are starting to be replaced by various others, but yeah, it really resets the planning process. And in the diagram that you can see, it's not really showing properly, but there are basically 6 fiber pairs on that PLCN cable. 4 of those were supposed to go directly to Hong Kong. 2 of those were supposed to make the stopover, but because of this policy, they can use only 2 out of 6 fiber pairs that they put in the cable. Then we have in some places missing subsea diversity or even blank spots where there is no cable at all. So for example, LA-Link is the only direct European LATAM cable. It carries around 100 terabits per second according to the documentation they provided. But for example, Atlantis 2, which was the previous cable there, it only carried 160 gigabits per second. That was the design capacity maximum, right? So it was basically shut down soon after LA-Link came online, simply because it was no longer economically viable to operate that. Nearly all of the European to Middle East and Asia cables are passing through Egypt. So small capacity bypasses are possible, right? Like you might be able to go through like Israel, Jordan, and so on. But until Blue Raman is launched, the new Google cable, it will be very hard to get high capacities there. And Asia to Sub-Saharan Africa is another example. So there's only one cable, which is called SAFE. It's got a design capacity of 440 gigabits per second. Well, these days, even a single OTN super channel can carry more data than that. And then we have some missing paths that are completely not there, like Oceania to Africa, Oceania to Latin America, and Europe to West Asia. You can see that the Polar Connect diagram there, that they are looking to change that with some cables that are passing through the Arctic Circle. And then looking forward, so there is such a thing as a Dutch Subsea cable coalition, I found out recently. And various government entities and market players, so builders, operators, users, etc., are pushing for new cable landings in the Netherlands. One of the things that is already looking quite good is the Erasmus cable. So that would go from Rotterdam area to London to avoid the Zandvoort and Lowestoft landing areas where all the new cables like Zeus and Scylla have landed recently. Other one that they're trying to bring to the Netherlands is Polar Connect and Far North Fiber that are meant to connect Europe to the Americas and Japan. And then last, some possible latency gains, right? So RFC 1925 says you can't increase the speed of light. But actually the speed of light in a fiber optical cable is only around 2/3 of the speed of light in a vacuum as a result of optical refraction. So if you find a new medium that has a refractive index that's closer to 1, you might be able to go faster in terms of propagation rather than throughput. And the other thing that might be cool is the space lasers of SpaceX and co. So when you've got meshed low Earth orbit satellites, you can point lasers between them to kind of relay the signal between these. And because you're doing that with a radio signal or in vacuum, you're not limited by the refractive index that you would experience in a fiber optical medium. But because there is like 25 milliseconds to go from the Earth to orbit and back to Earth, even for a low Earth orbit satellite system like Starlink, that's only really efficient at very long distances, like if you want to go to another continent, basically. And I think that's it.
Ruud? Yeah, I'm there. Thank you, guys. We have time for one question, I'm afraid. One very good one.
Hey, we have a number of links and we pay for a service to track ships. But we've found that sometimes the fishing ships turn off their locators or transponders when they go near our cables. And that's an issue for us. Do you find the same, and do you have any solutions?
Well, I think that's illegal, but it doesn't stop people from doing it, right? So what you see is that instead of trying to keep the ships away, people are doing more and more to really protect the cable better. So instead of, for example, just the armoring like this, you might see, for example, Zeus and Scylla are covered by rocks. So we're going back basically to RFC 1925 again, that every old idea comes again. And this one is a prehistoric one. If you don't want something to be found, you put rocks on it.
Bury it. Okay, thank you.
And also the sea cable systems usually have like a more advanced AES tracker where they have like the boundaries where the cable is laid, where no ships can, like the ships that are allowed to work in the area, they have permits. So usually you see that if a cable lays there without a proper reason or is not announced, then they call the Coast Guard and they will take a peek if the ship is just slowing down or is really working there without permissions.
I'm afraid the rest of the questions will have to be dealt with during lunch, which I'm sure you will be attending. Yeah. Thank you, guys. We have a present for you as well. Now, there is a next talk, and it was submitted by Bart de Bruin. Bart and I go back a long time. We have been working diligently on making the EuresaNet network disappear. And usually we were celebrating our success by having a nice hamburger at the end of the day. Unfortunately, owing to circumstances beyond our control, Sebastian now has to do this whole job again. But that is not the subject of Bart's talk. The subject of Bart's talk is about autism. And this is kind of a different subject than BGP attributes or subsea cables. But to be honest, I looked at his slides and I thought, wow. I think there is something in here for everyone. And I'm also sure that Bart will repeat it himself, but he is not a doctor, and this presentation does not contain any medical advice. Please take that to heart. Bart de Bruin.
That's a lot of people. Hi, my name's Bart. And I'm going to tell you something about autism and working in IT today. And this will be based on my own experiences. My psychologist told me to get outside of my own comfort zone sometime, but I doubt that this is what he had in mind. I practiced that joke. I practiced that one as well. Who am I? Well, obviously, you know, my name is Bart de Bruin. I'm 42 years old for the time being. I turned 43 in November. I work in IT for YaWorks. I know this is not supposed to be a sales pitch, but I had to get out there. And I was diagnosed with autism last year during the summer. So that's me, and obviously the dinosaur from Toy Story hates me. So, what are we going to talk about today? I will give you some context on autism. Like Niels mentioned, I'm not a doctor. I don't want to be one, but you have to have some context, otherwise the rest of the story won't make any sense. I will tell you something about myself and working in IT, what the strengths of people with autism is, and there will be some time for Q&A, depending on how hungry everybody is. So, what gets you an autism diagnosis? This is very important, and you will know later why that is. There's a couple of areas where you have to score sufficiently in order to get diagnosed with autism, and this consists out of having persistent deficits in social communication and interaction. I guess that one's obvious. For instance, I don't like looking at people, which is kind of a telltale for people with autism. You have to have restricted, repetitive patterns of behavior, interests, or activities. If you ever find yourself spending days on end with something you really like, that might be an indicator. Symptoms must be present in early developmental periods, so they have to manifest themselves when you're a child. Now, this is obviously interesting since I was diagnosed with autism last year, and well, some people may think I'm a child, but honestly I'm not. Symptoms have to cause clinically significant impairment in functioning. This one can be tricky, and I will explain later why that is. And the most important one is that all of the above is not better explained by intellectual impairment or developmental delay. So this is basically a diagnosis that you get if nothing else applies. Sort of. Right. So what isn't autism? As I mentioned in the previous slide, there's a bunch of things you have to qualify for in order to get an autism diagnosis. So having someone who's fond of organizing things, or someone who's enthusiastic about a hobby, someone who doesn't like crowd or noise, or someone who doesn't quite fit in, that's not necessarily autism. The way autism is defined nowadays is that they say it's a spectrum disorder. And along that spectrum, there's other people with other diagnosis that can be there as well. ADHD is one of the other ones, for example. So whenever you say, well, my inner autistic person went off because this didn't make sense, please stop doing that. That's not very nice. And autism is also more than just a collection of symptoms. It is basically a life-defining situation where you find yourself in, because to people with autism, the world looks different. I hope to introduce you to that bit. So, cause and prevalence. Well, the cause is that autism has a neurological basis, primarily in information processing. During the first 2 years of your life, you have an event called synaptogenesis. That means that your brain is producing a lot more brain cells than it needs to be. And afterwards, you have synaptic pruning, which gives birth to this, the saying, if you don't use it, you lose it. For instance, if you start playing the violin at a very early age, you become better at it than when you start later on. That has to do with that same phenomenon. Now, the idea is that something during that synaptic pruning goes wrong, and that's where autism stems from. More specifically, autism is not learned behavior. We are definitely wired differently. We experience the world in a different way. We deal with inputs differently, we internalize things differently, we think differently, we're very detail-oriented, for example. Prevalence, well, roughly 1% of the people has it, as we know now. Well, there are give or take 200 people here, so there should be at least 2 people with autism here. I'm one, who's the other one? In contrast, about 4 or 5% of the people has ADHD. What complicates matters is that, well, as with most medical diagnoses, autism looks different in women. I can't tell to that because I'm not female, but it looks different with women. As I mentioned earlier, people with autism and ADHD share part of the spectrum. Some of the symptoms that we have are shared. You can have both, by the way, although that doesn't really matter because, well, it's on the spectrum, right? So either you're on the spectrum or you're not. And also interesting, we know that people with autism tend to gravitate towards tech. Why exactly that is, not entirely sure. I guess it has to do because it's less people-y and more tech, but that's just a guess. So, my story. See if you can spot the sore thumb sticking out. That would be me. So my story. From an early age, I've never really felt like I fit in. And how is this, well, what does it look like? For instance, you get picked last for when you're doing sports or teams or football or whatever. You get picked on quite a lot. People with autism are very easy to trigger. And apparently, kids like bullying people who are easy to trigger. Surprisingly, choking the life out of someone takes care of that, but it's not recommended. So yeah, that kind of gives you a childhood where you exist, you function, but you don't really fit in, which makes you feel alone and misunderstood. For example, if I were to talk about something that I found interesting with my peers or people of my age, they would look at me like, what are you saying? Why are you thinking about this? If that happens often enough, you stop sharing that. And this is something that is very important to recognize. People with autism, some of it is because it's a biological function. The other half is because your surroundings condition you to behave in a certain way, which doesn't really fit who you are. I also had academic challenges, despite being considered very intelligent. I will not say how intelligent, and even smart people can do stupid things, so there's that too. And how do you cope with that? Well, you learn to mask, and masking is a phenomenon where you assume a certain identity or way of behavior that doesn't get you targeted. And that's the best way I can describe it. So people have expectations of you, whether academically or socially or whatever, and you try to develop a schema with items that you do in order not to get picked on. So whenever I'm talking to someone, and this is automatic now because I've been doing it for a while, but earlier on you have to recognize what gets you targeted, or people look at you like you're weird, or not. So when I'm talking to someone, I will ask myself, should I look at them? Because eye contact I find incredibly annoying. Should I laugh? Should I crack a joke? Should I not laugh? Or am I being too funny now? Or something else? Because like any person with psychological challenges, I use humor to deflect my issues. So that doesn't really work all that well all the time. But also, if you have to think about how to behave yourself, and you're concerned more with how you present yourself rather than having the energy to think about what you're doing, that takes an incredible amount of energy, and that really takes it out of you. More so in a very public setting where I have to be really considerate about what I do and what I say. So how did I end up in IT? Well, my background is chemistry and psychology. I didn't finish either of them, and that's all I'm going to say about that. Afterwards, I started working at a small IT MSP company. That's where I met Job Snijders. Actually, I met him at the psychology study at the University of Amsterdam. Well, Job Snijders is obviously well known. I didn't have any affinity with networking or IT or whatever. I mean, of course, I built my own computer, but who doesn't, honestly? No pressure there. So I got the opportunity, and also I taught myself how networking works, what MPLS is, how you enable MPBGP, various IGPs, and all of the likes. Got introduced with layer 2 networking, and I really wish I didn't. I worked there for a while. I switched jobs. I kept learning things, most important of which is Python, which I find very amusing and enjoyable. Also, Teun, please don't use Python 2 anymore. And I ended up as an IT consultant or a specialist for the past 8 years. Being a consultant is, for me, a relatively perfect fit. And whenever someone with autism says perfect, it's an approximation of perfect, because we think very binary. Either something is really good, or it's not good and therefore shit. So, yeah. Take that with a grain of salt. And now, why is being a consultant so good for me? Well, like I mentioned earlier, I kind of stand out. You wouldn't necessarily say so if you saw me in public, but that's because I'm trying very hard to keep that from you. It's kind of like the iceberg phenomenon. You see one or two things sticking above water. That's the thing you see. Then underwater, there's the thing that sinks your ship, right? So, yeah, that's autism and people who mask in a nutshell. But why is being a consultant a perfect fit for me? Well, I get to change jobs regularly or different projects, which means that, well, you kind of stand out already. So, right, you're an external brought in to fix something or make things better or create order where there is none, which is also a good one. So that kind of caters towards me, where I don't necessarily have to fit in with an existing crowd. I mean, I'll join people at the coffee corner and talk about football, but, well, you do what you got to do, right? But yeah, so it caters towards me not having to fit in exactly, but also it allows me to do stuff that I really like and really enjoy doing, which is the other part of being a consultant, because you're brought in to fix something or provide hands-on experience. So that fits relatively well. So, to give you a little bit more of an example of what autism looks like, what are my challenges while working in IT? Reading people or email. Funny enough, it doesn't really matter which one it is, because if a person responds to what I say or I speak with someone, it's difficult for me to fully grasp how they react to it. I mean, I can see if someone gets angry with me, because you can see their way of behaving change, right? But if they don't do that, then, well, what are they thinking? I mean, I need visual feedback from someone in order to understand how they're experiencing something, and even then it's a best guess. Now, with people, you actually have someone you can look at where you have that type of feedback, possibly. With email, you don't. There can be a line of text, and it can mean one simple thing, but I can think of 1,000 different ways of which you can read that and understand that. Now, thank God for smileys, but there's also people who don't use them, which is really annoying. Cubicle culture, or the typical kantoortuin. Most people with autism, and me specifically, we handle stimuli very different from other people. If I'm in a cubicle culture office and somebody's talking, doesn't matter what it is, I pick it up. Someone's talking about something else, I pick it up as well. If I pick up a conversation, I'm like, well, actually, you're supposed to do it like that, I will say it. This is usually frowned upon. Being diplomatic is also an issue. I tend to say things as I perceive them. So if something is good, I'll let you know. If something is bad, I will also let you know. The former is usually not a problem, the latter more so. Educating people, I have the tendency, if I hear someone talking about something and I'm like, well, that's not entirely correct. Actually, it's like this and that, and you should do things like this. For instance, if someone starts talking about their layer 2 network and I'm like, well, act like a grown-up, redesign it into layer 3, it tends to make people feel stupid or offended or both. Half the time I can't tell. Masking or fitting in, overthinking, this is also a good one. Like, for instance, the email example, if there's a single line of text and I can read that 1,000 different ways, that's a classic example of overthinking. It has its benefit as well. If, for instance, if you're starting a migration or something where you go through all of the different scenarios, but I'll get to that later. Imposter syndrome. Part of masking is that you hide who you are or how you experience things. Imposter syndrome means that, well, what if someone finds out that I'm secretly somebody else? And I'm not 007, but just some guy with autism, right? That constant fear is also something that can drain a lot of energy. So this is really a challenge. If I have a couple of those days in a row, then I really need to like zone out and fix myself. Also, another challenge is that I can become irrationally angry about something small. And this ties back into the, if it's not 100% good, then it's bad and entirely bad. If something doesn't go my way, even though I specifically planned or engineered it to do that, yeah, that ticks me off. That's, that's why I do kickboxing once a week. Of course, there's more than one challenge, so second slide, continued. Typical for people with autism is that you focus on details. Now, this has an upside. You look at the details. The downside is there's so many focus on details that there's not so much big picture. This is really something I have to work on for myself. I get lost in the details quite easily. I get sidetracked quite easily. A nice term for that is side quests. For instance, I can think of, oh, I'm going to go get some coffee, and then I get sidetracked along the way with cleaning something up or looking at something, or there's an article in the newspaper, and I'm like, oh, I can read that. Or my phone alerts me that there's some social media interaction that I really should look at, but you don't. But hey, you get sidetracked, right? But also another challenge, who do you tell you have autism? I don't think that there's a good answer to that. It really depends. And that's something that you'll have to figure out for yourself when you have autism. Most of my coworkers know, my employer knows, my girlfriend knows, obviously. Also another challenge, I have very good motivation for things I like doing. The downside is that I don't have any motivation at all for things I don't like doing. Now when it comes to work, this can be an issue, right? Because some things you just have to do, like writing time. Autistic shutdown, brain fog, over understimulation, they all boil down to the same thing really. Like I mentioned earlier, people with autism process the world differently. And autistic shutdown or brain fog is a result of that. If you get too much thrown at you all at once, that can trigger a response, either the classical kicking and screaming, which is what I don't do. The other one is that you kind of withdraw within yourself and you don't interact anymore. Doesn't happen that often, but it can happen. And then there's, of course, depression. Yeah, I think that speaks for itself. So, that was all the bad. Now some good. People with autism, although they perceive the world differently and have issues with social interaction, we can actually function and thrive in that surrounding. You would be surprised to know that people with autism are mostly honest, caring, and hardworking, and very genuine, bordering direct and blunt. And most importantly, even though we lack social adaptability, we don't lack empathy. I mean, if we see that someone, for instance, is going through something and that makes them sad, we know that they're sad. We just don't know how to deal with that. Also, we're usually very analytical, creative, and detail-focused. That really has its benefits in some scenarios. For instance, if you're going through software testing or migration scenarios or different things where you really have to have a focus on detail, that's where people like me shine. That's what we're really good at. And also, we can thrive, but please meet us halfway. Typically speaking, we live in a neurotypical world. That's the majority of you. And then there's some neurodivergent people. That's people like me. And we're always expected to fit into the neurotypical world. But it would be really nice if the neurotypical world would also move towards us every now and then. So quit cubicles. Don't do them. Working at home is also a very good one because you don't have all the additional stress. But yeah, like I mentioned, we see and experience the world differently. So for instance, if it's on a personal level and I can tell that you're upset or stressed or something is really important to you, that part I can tell, but I don't have any idea on how to deal with what you need. So tell me, be explicit. Tell me what you need from me. I can't see what you need. I can tell if something is wrong or that something is important to you, but I don't know what you need, so please tell me. And also when communicating, be very specific. Don't infer or imply or be very subtle about something because I will miss it. If you start a sentence, well, it would be nice if, yeah, cancel that. It's not happening. No, take out the vacuum the house, and we're done. That's how it works. Yeah, I found this quote during one of my many searches on the internet about more information for an autism diagnosis. It's almost like a language, right? Because neurodivergent people like me, we can speak neurotypical, we can fit into a neurotypical world, but we speak it with an accent. You can tell. If you have someone in your surroundings who has autism, you probably already know what the triggers are. Not making eye contact, fidgeting, not wanting to go out all that often, disappearing from the radar every once in a while, have difficulties maintaining friendships or other relationships. So, yeah, that's how you can tell. And last but not least, are there any questions? This is my dog, by the way.
Thank you for standing up with this, Bart. And you could hear a pin drop during your presentation.
Yep.
There are questions. Erik, go ahead.
Yeah, first of all, I'd like to applaud you on bringing this out in the open. I have a personal question for you on how do you unwind from all the things you need to deal with in the day-to-day? What makes you happy? Your own place? What kind of sports do you do to reload?
Well, I have a dog. I take him for walks quite often, which is good for the dog and good for me as well. Yeah, gaming, sports, stuff like that. Something I can focus my attention on and can enjoy, and provides just the right amount of stimulation. That's how I cope with it.
All right.
But
thanks.
it may be different for other people.
Yeah. Thanks. Thanks again.
You're welcome.
Yeah. Well, I think there are different categories of people of people who are perhaps not your group, but have a lot of the same things in life they run into, like ADHD, you said, ADD, people with misophonia, if that's the English term for it. Well, what you're doing is you're a consultant. I'm not sure if you have your own say in where you're going or where you're not going. I'm a contractor as well. One of the things that I sometimes find a challenge is that if you work at a certain place, like if you would have a normal job instead of being a contractor, it's easier to come into a safe environment where people can move halfway, people know about you and everything. But if you are a contractor and move to a new environment every year and a half, how do you cope with surviving that? Because that will take extra energy. It will be a new place where you have to find your place, everything. So
it depends, and I can really only answer that from my own perspective. My schemas for, well, behaving in the social setting are quite good. So even though it's not something that comes naturally to me, I can cope with it. But I think that in the end, it's the most important thing that if you've accepted that you have autism with all the challenges that come with it, that the next step would be that you find or try to find a place where they can accommodate what you need. And I think that especially in this day and age, it's not that unacceptable for employers to reach out and say, oh, hey, how can I help you? But the most important thing is that you also communicate that people understand why you would like that or why you need something. Because, well, like I said, most people with autism spend their lives trying to hide what they really do, and that doesn't help people who would like to help you but don't know how.
One question from the remote audience.
Well, actually, it was a personal question and not one for... Yeah. First of all, thanks for all the insights. I think it was a very useful talk. What I was wondering is, how do you find an event like this? And is there anything we as organizers should do to make it more accessible for you? And I realize you're not a spokesperson for everyone on the spectrum, but...
Well, it would have been nice if I could walk around, but that's a very personal thing. Okay. But that's also a way of dealing with with the stimuli, right? You find a way to deal with it, because otherwise a good one would be to click a pen numerous times. But I doubt that people would find this very...
We do have pens in the goodie bags.
No, but it's accommodate a way in which they can vent their excess energy, so to say. Yeah, that's basically it.
Okay, thanks.
All right, one final question, please.
Yes, first of all, thank you for sharing. That was very interesting. This is UK-eyed, I think.
Yes.
I'm going to put it up a bit. I noticed you got diagnosed quite late in life, 42. Maybe you can elaborate on why that was or what the trigger was for that diagnosis. Maybe there are people here that also have a worry or a fear.
Well, I got referred to a psychologist when I went through depression. And after that, or during that actually, the psychologist suggested or asked me, have you ever been tested for autism? Which I wasn't, of course, or at least not to my knowledge. And that's how that ball got rolling. I mean, you have to ask your GP or huisarts if they want to refer you to a psychologist for an autism, or well, is investigation the right word? Or, well, at least something like that. But yeah. And then you go through that, and also to give you a little bit of information, that whole process of finding out whether you have autism or not, in my case, took about 5 or 6 months. It's very exhaustive, because they have to go through a whole lot of things, because, well, as you saw, one of the key indicators for autism is that it can't be adequately explained by anything else, right? So they have to rule out a whole bunch of stuff. And in some cases, it's quite easy. And in my case, it was a little bit more difficult, because I'm so used to masking that it's second nature for me. Thank you. Yep.
Thank you again, Bart. Right, I'm sure this gives everybody plenty to talk about during lunch. Speaking about lunch, this is now. Melchior and I just had an impromptu board meeting, so the rest of the board can... we decided to extend lunch until 2 p.m. So we will reconvene here at 2 p.m. See you then. Welcome back, everybody. If you would like to take your seats. Welcome back for the post-lunch part of the day. We as the board have noticed some logistical challenges during lunch, and it will be worked on. Now, in this part, before the tea break, we have 3 presentations. One is a slightly longer one, and 2 will be slightly shorter. The longer one is the first one. And, you know, there are people in your life that are like personal heroes. Well, Pim van Pelt is not one of them. Yet. Because I know him in many capacities. He is a master in everything he does. And when I learned that he is working on a forwarding plane for Linux, something that makes, you know, with Juniper, right? The great idea of separating routing and forwarding. Pim is doing that for Linux. And I thought, oh, is there something that this guy cannot do? Well, I hope you will share my enthusiasm for this VPP project that Pim is working on. And he will be here to enthuse you about it in the next 42 minutes and 42 seconds.
Okay. We good? So Teun asked me on IRC a little bit timidly, hey, would you be willing to, it's kind of difficult, you live in Switzerland, I can understand if you have to think about it for a couple of days, but it would be nice if you can come talk to NLNOG about your project to do very fast forwarding with Linux on commodity hardware. And it took me all of half a second to respond, hell yeah, let's go. So I have 3 acts today, but before I start, I wanted to maybe ask by show of hands, who knows what this VPP stuff is? Oh, that makes me feel so much better. So for the audience online, it's maybe a third or so raised their hands. And that's actually really good because this talk is like talk number 2 after talk number 1, which I've given a number of times. And so I'm kind of assuming there is a base level of knowledge about this stuff. But if not, I'm apparently supposed to leave like 3 minutes at the end for questions. So the first act is introductions of me and VPP and all this stuff. Second is on MPLS, which I never thought I would use. I tried to skip it, but it came back to haunt me. And then the third is a note on performance, because I'm making these claims that this is a really, really fast data plane implementation that runs in user space. And so I'd like to give some stats and figures and numbers on how I can prove that. So first, a little bit about me. I'm Pim van Pelt. I sound American, but I'm not. I'm Dutch. Earlier, someone said we should probably do this in Dutch, but my Dutch is not as good as it was before. I've been a member of the RIPE community since about RIPE 34, which is 99. Registered IPNG.nl. IPNG stands for IP Next Generations, which was the original tag name for IPv6. Went to Switzerland in 2006, obligatory vanity domain there as well, and then I got bored in the pandemic and incorporated a small company in Switzerland that does routing. So IPNG Networks GmbH is a developer of software routers based on DPDK, the Data Plane Development Kit, and Vector Packet Processing, VPP. We are an absolutely tiny operator from Bruggezellen, which, trust me, nobody even knows in Switzerland, so don't worry about it. But we also operate across Europe, and that map maybe looks a little bit more familiar, from Zurich to Frankfurt, and then up to Amsterdam, to the north of France in Rijssel, which I'll have to call Lille for reasons. Paris, and then back to Geneva to complete the ring. We run VPP on all of these routers, and they're connected to maybe 12 or 14 internet exchanges with roughly 1,900 or so adjacencies, which makes me, ironically, the number 3 best connected ISP in Switzerland. We appear on the flap, but for us the L is not London, it's Rijssel, which I'll call Lille. And we acquired AS8298, which you may recall from back in the early days, belonged to 6-Axis, an IPv6 tunnel broker that I used to operate out of my basement. So this DPDK that I speak of is kind of a counterintuitive thing. Normally we think the kernel is the fastest place to get stuff done, but it turns out the kernel is actually really slow at networking. This is true for Linux, but also the Windowses and also the BSDs. Some are a little bit better than others, but they're all relatively slow. So DPDK was originally written by Intel to do what is called pole mode driver, where we take the network interface out of the Linux kernel, bind it to some user space I/O module in the kernel, and then attach to it via a program that runs in user space. Doesn't even have to run as root. And it's called kernel bypass routing. So what we use is things like SRIOV, user space I/O, and virtual functions to give this user space process access to the hardware. Typically what happens then, DPDK will start a thread, 1 or more, consume 100% of the CPU, and continuously ask the network card, do you have anything to do? Which is called a pole mode driver. And some pole mode drivers as well know what type of hardware they're speaking to, and the hardware may have some offloading capabilities like checksumming or VLAN tag insertion or Q&Q and things like that. And so they can leverage the parts of the silicon that are amenable to be leveraged and then end up giving a list of packets back to the user space, which it can do with as it pleases. Furthermore, DPDK has a bunch of lockless queues, which are really important because you want to be able to scale up over multiple processors, multiple threads that run on disjunct CPUs without having to lock on one another. And it provides all sorts of infrastructure, that's useful to write networking applications with. So DPDK runs with threads. They're called logical cores, and they map 1-to-1 to the physical cores on the machine or the hyperthreads. And then they subscribe to the NICs and ask the NICs for work. And most network cards today have a thing called receive-side scaling, which is a hardware trick to be able to sort all these packets into multiple queues, so you can have multiple CPU threads listening on the same network device. And on the way back out, all of these threads will be able to marshal traffic into any one of the network cards below by using as well transmit queues. And there's something that you get in terms of performance that's actually really magical. VPP now is vector packet processing, and it's an open source data plane implementation that comes from the house of Cisco, but is today in the Linux Foundation. And it provides this really, really fast networking data plane that uses DPDK and other drivers too, like RDMA, or VirtIO, or VMXNet, or AVF, and there's a bunch more. And what it does, instead of doing routing one packet at a time, like your kernel would, it actually asks the network card for maybe 100 packets, and then brings all 100 through this directed graph that I drew on the left-hand side. So there's a tiny bubble called Ethernet input. If you assume the DPDK gave you Ethernet frames, and you give all 100 to this bubble, the bubble is relatively small in code, and so it will fit in your CPU's instruction cache, and maybe the packets themselves will fit in the CPU's data cache, and so they get read from the PCI bus into the CPU. You do stuff with them. The first packet you might handle may need to call stuff from RAM, like page in, all of these instructions into the iCache, but the second through 99th or 100th packet will go really, really fast because you didn't touch RAM at all. And as such, on a simple machine, an affordable Dell or Supermicro, you can easily do hundreds of mega packets per second and hundreds of gigs of traffic with commodity hardware like Intel NICs and Intel or AMD CPUs. So I did a first talk, that's why this is talk number 2 at SWNOG 2 years ago that started talking about this work. Someone called me out on Twitter, X, and said, you can't do 100 million packets, I don't believe you, so I felt compelled to prove them wrong at NLNOG in Hamburg last year. And then this year I'm talking about the next step, because people tend to troll me on Twitter and say, why do you not have MPLS? Because MPLS is awesome. And so the rest of this talk is about adding MPLS to the vector packet processing. So this Linux control plane, as it's called, will take this interface that you got from the user space and is therefore no longer in the kernel, right? You used to have an ETH0 or an ENS3. You no longer have those, they're gone. And it puts that interface back to the kernel so you can manipulate it, which would allow you to add control plane stuff to it, like BGP and OSPF or VRRP, SSH daemons and SNMP and whatnot. So what it looks like is this. This is a condensed version. As I said, Hippo, the machine that's running VPP, has lost all of its network cards. They're now tucked away in UIO in VPP. And there's a binary called VPP control, where you can plumb back the interface that is called 10 gigabit Ethernet 300 and bring it back to the Linux kernel as a TUNTAP device called XE0. And from that point on, you can manipulate that interface just like you would a normal network card. So you can give it an MTU, set it up, give it some IP addresses, maybe create a sub-interface called IPNG, VLAN tag 101, give that an MTU and some interfaces and set some defaults, and you're off to the races. And so this packet went from the Linux kernel through the tap into user space, where VPP picked it up, and then marshaled it out on the wire using the magic that VPP does. And on the way back, if it sees any packets that go to an IP address that I configured on the router, it'll copy it back to the Linux kernel called punting. But if it's through the router and it's only on the data plane path, it won't tell the Linux kernel about it at all. And so you get this really fast forwarding plane that eventually pops up these packets that go to the Linux kernel, and you can handle them there as you would any other. But of course, TCP dumping will only show traffic that goes to my IP addresses or multicast groups. It will not show traffic that goes through the data plane. Now, this is great. VPP is awesome, but it's a data plane and has an API, and it doesn't do config persistence, and that's by design. So I wrote a utility on GitHub that reads a YAML config file, essentially saying, here's my interfaces and their IP addresses and their sub-interfaces and all that stuff. And it tries to be smart, doing some syntax checking with YAML syntax validation, but also semantic checking because some configurations just don't make any sense. And then it tries to plot a path by reading from the API what is the current state of vector packet processing data plane, and then computes a path from where I found it to where I wanted it to be in the YAML file, and then emits a bunch of API calls to make it so. And that gives us the configuration persistence. So what that would look like is like this. So VPP config allows me to dump the current configuration of the data plane in a file called nlumps0.yaml, which I can edit and add some interfaces. In this case, I've added a sub-interface 100 on gigabit Ethernet B01, and I've given it an IP address. And sub-interface 200, which I've cross-connected, layer 2 cross-connects with this other interface called gigabit Ethernet B02. And so these two, the sub and the PHY, are cross-connected, L2, and the other one just has an IP address. Now I can plan a path from where I found the router to what I configured, and I can output that to a file which will show me the API calls that it would do, right, to get the data plane into that state. And those things would look roughly like this. Create some things, delete some other things, do them in the right order. You know, you need to remove the IP address before destroying the sub-interface. You need to build the sub-interface before adding an IP address, things of that nature. And then ultimately, I can apply this configuration from the YAML file into the data plane, and now the data plane, unless it crashes, which never happens, will look like what I configured in the YAML file. If it does crash for you, let me know, because I actually literally meant that has never happened. So those of us that hang out at Coloclu will recall Case, a pretty fantastic piece of software that I use to configure the higher level control plane, so the BGP stuff. I kind of did rewrite it entirely, and I'm willing to share it back in case people have an interest. But what it does ostensibly is, again, read a YAML config file that says, here's an internet exchange, I'd like to peer with this AS number, and then it tries to figure out all the rest, like what is its IP addresses, which peering mesh is it on, what is its filters, like things of that nature. And so what this does for me is it constructs a per router configuration hierarchy, kind of like an Ansible playbook would, and then it writes it to a directory, copies that directory to the router, and then somehow reloads, you know, the things like Unbound, the name server, or the firewalls, or Bird, or Borgmatic, the backup tool that I use, SNMP, all that stuff. And of course, it generates the VPP configs as well. So thanks again to Coloclu, because I learned an awful lot from that club. So how this looks like in my rendition of Case, let's say that I wanted to add this router to Friesix, a very cool internet exchange, which you should all be on, talk to Arend. I'll create a group called Friesix. I'll refer to the internet exchange by peeringdb IXP ID, which is 3512. And then I'll add a bunch of sessions, right, to the route server that gets a different set of BGP communities, to SurfNet, Coloclu, and the bit guys that I really like, so I give them a higher local pref. Then I tell the router that it's a part of this group by essentially giving it a local address that will match with what peeringdb said, you know, all these peers have. And I'll generate a file, or a set of files, that just goes to the peeringdb, gets all the information. I really only specify the IXP ID and the AS number, and it figured out the rest. It tested the configuration to make sure that it's sane, and if it is sane, I can push this thing to the router, which will reload Bird, and I'm off to the races in maybe like 15 minutes or less on a new internet exchange. Commit this GitOps style. You can also imagine a CI/CD runner that I do the commit for, and it picks up the diff and then pushes it out. So that's the control plane side. Tying it all together, because the punting I do from VPP up to the kernel will be unicast and multicast traffic, I can do things like OSPF, BGP, VRP, all of that stuff just natively, and all the tools that you would use under Linux would work just as well under VPP. It's really, really fast, though. In this case, I showed a snapshot of the Amsterdam router maybe 2 or 3 days ago. It takes 14.5 million routes in the RIB, and obviously full tables. And it loads those full tables in about 7 seconds, and that includes programming the FIB, and that's something most of your commercial router vendors will not boast about. Okay, so that was like the intro to VPP, which in itself is a 2-hour talk. Now, based on a Twitter troll, someone said, why don't you do MPLS? And I am a stable, what do we say, a stable person. And I'm so stable that I stopped working on networking before MPLS was invented, and then I came back when MPLS was no longer really a thing, because today everyone uses VXLAN and Geneve and all that other data center tech. So about 3 months go by and another person says, why don't you do MPLS? And it's a chunk of work, so I decline. And a third or fourth iteration, this dude called Adrian Pistol comes to me and says, I would like to do MPLS. And the way in which he said it was different to the others. So I'm like, sure, knock yourself out. And about 48 hours later, like a 2,000 line change rocks up to my inbox. So he definitely put his money where his mouth is. Now, I want to show you this picture because I'm going to come back to it in a little bit, but this is a lab situation where I have 4 of these VPP routers that are connected to this green head end called lab.ipng.ch. Each of the routers has 4 interfaces called gig 10, 0, 1, 2, 3, 0, 1, 2, and 3. And they're connected to each other as a daisy chain. And then there's 2 Debian hosts, one north side, host 1.1, and one south side called host 1.0. And they just connect one port to each of the routers. So in this case, I can make any form of topology that I would like. And because all of the VMs run under an open vSwitch fabric, I can plumb in any VLANs and any tags and .1Q forwarding and all that other stuff. And then there's a really cool trick that I learned about mirror ports on Open vSwitch, super cool. There's a 7th machine to the left here called tap 1.0, and it has 2 network cards. One receives all transmitted into the Open vSwitch Ethernet frames, and the other one, all the received interface frames from Open vSwitch. So here I can just TCP dump on tap 1.0 and see any router talk to any other router. It's super useful for debugging, because it did go wrong during the development of this work. Now, without MPLS, traceroutes. I am on lab front end here, the green machine, and I'm trace routing VPP 1.3. This should not surprise you, in which case maybe I can explain later how traceroute works. But there's packets that go to VPP 1.0, 1.1, 1.2, and then ultimately 1.3, right? Cool, a traceroute. Adrian then proceeded to knock it out of the park. He added MPLS encapsulation, which will take an IP datagram or an Ethernet datagram and wrap it into an MPLS packet and sends it out. Swapping, which is used mostly on P routers in the middle, right, that take an MPLS frame in, do something with the tag, and then send it back out another interface. And then on the other end, popping, which will be decapsulating the MPLS datagram to find out what's in there as a payload. And we also added a couple of things to the interface plugin, which allow us to turn on MPLS in VPP, which will plumb all of the Linux kernel things, like literally turn on MPLS with syscalls and whatnot. And due to a bug that we found, a thinko, more so than a bug, be able to forward MPLS traffic that's sourced by the Linux host, right, sent through the tap tunnel, and then done something sensibly with it in the data plane. So for the insanely curious, that's the software engineering part. It's maybe 3,500 lines plus tests. And it's so far been working pretty well. If I could give a demo, I would actually show an exabyte or 2 of data that went through a set of VPP machines, but I was specifically told not to give a demo by at least 20 people. So I also wrote a bunch about this. If you don't know this of me, I write on my blog a lot. And there's a 4-part piece here on MPLS in general and how it pertains and is implemented in VPP, which if you're on IOS XR, Cisco trains, you'll actually find it very familiar. And then performance parts, those of you that recall back when this stuff was invented, they had these really cute tricks to cut down on CPU time spent by routers in the middle somewhere. PHP, not the programming language, but penultimate hot popping, one of my favorite hacks. And I figured, is that really faster? And it turns out, yes, even today, that's faster if you're doing it in software. And then the actual implementation of pop, swap, and push. And the 4th part is this fix that I'll get back to in a second to allow the Linux host itself to source MPLS packets that go through the data plane untouched. So the resulting code here is in my branch of Linux control plane NG, IP NG, but we also merged it upstream, so it shipped in 2206. So it's been there, sorry, 2306, it's been there for 1 release and a half. Nobody has yet screamed that it's breaking their production setup, but if you did want to give it a whirl, Let me know. If there's an issue with it, I'll be happy to take a look. So if you've used FRR, and I don't, I use Bird. Bird doesn't have LDP. I should probably get that fixed at some point. Rage is a good way to get that fixed. So in this case, I set up these VPP routers in the lab with FRR. Pretty cool piece of kit. I hear they fixed the CVEs pretty quickly upon publication. So if you were to show MPLS LDP, how you would set this up, very straightforward, I think. This does transport with IPv4 and transport with IPv6. It advertises local routes with explicit null, if that makes sense to people who actually operate MPLS. You could also do implicit. And then it turns on IPv4 and IPv6 LDP on these two interfaces, E0 and E1. And if you'll recall, these were the two that connected to the siblings in that chain of routers. The LDP adjacencies are established. LDP starts swapping out or exchanging label information to and from peers. And how that looks like in FRR world is show MPLS table, which shows the inbound label 16 will turn into an IPv6 explicit null with a next hop somewhere link local on some interface. Same is true for normal swaps, like 21 here gets forwarded on to the MAC address of 11.8 and gets the outbound label 40. So that would be a swap operation. And there's a couple more on popping, which I'll get back to in a second. So this is all still normal. This is the control plane. It's what it thinks it negotiated with its peers. But then eventually what FRR does in general is it emits netlink messages to the kernel to program the kernel's routing tables. And in in VPP, the plugin that I helped write picks up these netlink messages and tries to do something sensibly with them in the context of the FRR forwarding plane, right, instead of the Linux kernel. But I can look at what the Linux kernel saw, and that would look like this. Like for family MPLS, show me the routing table. And this is exactly the same as the previous slide. It's just the part that Linux saw. But because FRR sends these netlink messages, any number of listeners can pick them up. And that's exactly what VPP does. The plugin picks up these netlink messages and then starts programming its fib in a particular way. And that looks like this. So with VPP Cuddle, show MPLS fib for the entry for label number 21. I'm going to show two things, and this is where actually VPP is a little bit different to Linux. Linux has a flat routing table that has labels, egress points, and new labels. VPP allows you to make a difference. It's a little bit of a nerdy thing, but a difference if it is an MPLS packet with only one label or if there are multiple labels. And in the MPLS world, this is called end of stack bit, EOS, and then the inversion of that is the not end of stack bit, right? And because I don't know how to make a difference, Linux doesn't make a distinction between the two. I'll pick up both and just program the EOS and the NEOS entry with the exact same information. Right, so if there's an MPLS frame with only one tag or with a lot of tags and this is the bottom one, I'll do the same thing, which is what Linux would do. So here's the EOS version, and here's the NEOS version. And it just goes through a slightly different internal code path in VPP, but otherwise gets forwarded just fine. So with that, we thought we were done, but it didn't work, which was kind of weird. And after a little bit of sleuthing and debugging and TCP dumping on this awesome piece of Open vSwitch mirror ports, we found that actually the MPLS packets were being mangled on the way out from Linux through VPP to the wire. And then I realized, oh, when I send an Ethernet frame that is an MPLS frame, VPP sees it as an Ethernet frame. It's just like, oh, cool, that's MPLS. Let me go do something with it. Oh, it's an MPLS label? Let me look up in the fib. What is the value? What should I do when I see like label 21 or whatever? And then it swapped it with 40 and it sent it out its merry way. That's actually not what I'm trying to do. Linux is trying to actually send the thing with the label 21. So it doesn't want to have a fib lookup. It just wants to go straight through and get marshaled onto the wire. So that fourth article is the long debugging trail, ultimately resulting in this, this two-line, well, semantic diff anyway, where if we see an Ethernet frame that's MPLS encapsulated come from Linux to VPP via the VirtIO tap, we'll just cross-connect it directly to the physical network card and marshal it without doing further work on it. And this avoids the tags getting popped or like the thing going a different direction that we had anticipated. And with that, the traceroute looks like this. It is super cool. So I'm on lab.ipng.ch, and I send a traceroute to VPP13. VPP10 sees it. It's like, I think I know what to do with this. I'm going to encapsulate it in MPLS. Sends it to VPP11 and 12 and 13, who goes, I know what to do with this, which is pop it and see this ICMP echo with TTL1, and, oh, that's me, let me just go respond. And so the traceroute turns into one hop. And this is how like the big carriers make you believe that they have a super flat network, even though they're actually just a big MPLS cloud underneath. And then further, if I go from host 10 down below, this is the south machine, and I traceroute host 11, well, kind of the same thing happens, right? So I give my packet to VPP13, it gets encapsulated, MPLS switched to VPP10, where it gets popped, and that thing responds, going, okay, that's me. And then this is one of those TTL exceeded, I guess, right? And so traceroute knows to try again with TTL2. That goes through the same route, gets popped out VPP10, and sent out that chain, to the northbound machine on host 11, which then responds. So I think we proved that it works. It doesn't work well. Spoiler alert, it does. Enter Cisco T-Rex. I'm going to come in under time, Niels. Cisco T-Rex is a load tester from the house of Cisco. It's open source as well. You can download it from a website, which doesn't have an SSL certificate that works. It's just like whatever, forget about TLS. Sorry, Oscar. Then you give it a configuration file that says, here, take these PCI addresses, 500 and 501. These are two 10 gig cards. Give them some MAC addresses, and start sending traffic from NIC 0. That's the purple line on the left that goes up to this cloud called the device under test. And then you're expecting it to kind of come out the other side so you can count it. All right, so really all T-Rex does is send out a bunch of traffic, and for every packet it sent, it expects the packet back on the other side. And you can do this in one direction or in both directions. In the light blue arrow on the right-hand side, NIC 1 can also start sending traffic that goes through the device under test and then gets counted back on NIC 0. So the simplest way to do this is to just grab a cross-connect cable like a DAC, right, and then count all the traffic from one side to the next. You can use MAC addresses, which saves you some hassle and gives you other hassle, or you can use IP addresses, in which case Cisco T-Rex will use ARP resolution to figure out who to send this stuff to. So then, in T-Rex, you create streams of packets with a Python library called Scapy. And Scapy is used to compute the actual stuff that you send on the wire. It can do anything you'd like, raw Ethernet, it can mangle the frames, make them runts, like too short, it can make them too long, it can make them at a certain rate, like 28 packets per second at a certain size. It can set streaming gaps so that one packet is sent and a little bit of time is held to wait. Enfin, you can create this stream of packets that you apply to one or more ports, and then you apply them at a certain rate. For example, 1 megabit per second, or 1 million packets per second, or 10% of the line rate of the physical hardware. And T-Rex will then start emitting it at this rate, and then counting the packets on the other side as I described. So taking an absolutely tiny computer, it's not the smallest one I could find, but it's certainly not a very expensive one. And it's a mid-class Supermicro from, I think, 2014. It's pretty old. And it has this Xeon D CPU with 4 cores and 8 hyperthreads. It has 256 kilobytes of L1 cache, which is kind of relevant because we're trying to play this out in the cache. 1 meg of L2, 6 megs of L3. And by the way, modern CPUs are starting to talk about having a gigabyte of L3 cache. This is a really, really old, small, low-cost, low-power CPU. NIC-wise, it has 2 25 gig Intel cards, 2 10 gig Intel on the motherboard, and 6 1 gig as well. Sorry about the formatting, but I'll start 3 DPDK threads. Remember that you can have 3 threads listen to 3 queues and each take 1/3 of the traffic. Using RSS, we'll sort traffic roughly 1/3 in each if we're lucky. And then with IPv4 routing, as I'll show in a little bit, I can do roughly 9.3 million packets per second per core. So I have 3 cores, and the 4th might be used for control plane, like SSH and BERT and whatnot. And I could turn on hyperthreading, which makes 2 sibling CPU threads use the same cache, which regresses, but actually not too bad. It goes from 9.3 to 6.3 million packets. But now I have 8 threads, right? And I can use maybe 6 of them, which means if with 6 threads is how I run them at IPNG, it can do roughly 38 million packets per second, and it takes 48 watts when doing so, which is roughly 1.56 microjoule per packet forwarded. Now, I also run Cisco's, which run about 4,800 watts, and therefore are not quite as cheap on power. Maybe a little bit more stable, although sometimes I laugh at people when they have, you know, a Cisco IO6R data plane crash, and then they laugh at me when I have VPP crash. So T-Rex, what I do is a saturation load test, right? So I'll just offer as much load as the device under test can take, and eventually it's gonna bork and stop forwarding more, which is typically not a crash, but it's like a flat line, right? I did 9 million, and I didn't do 10, and so you can see like the whole line just stays 9 million indefinitely. And when you start it and give it some commands to start the load test, the screen looks like this. It's kind of nice, I feel, that there is like a CLI-based or a textual user interface. And the main components on this screenshot are on the left, the number 1 here, what types of devices do I have? Are they 10 gig, 40 gig, 100 gig, 200 gig? And that works, you know, provided the network card has DPDK support, which T-Rex as well needs. And then how fast am I sending? L1 on the wire, L2 with Ethernet, and with really small frames, that matters. There's a lot of overhead on Ethernet to be able to send 64-byte packets. And then number 3 is what did I get back on the other side? That's actually where the rubber hits the road, right? So if I sent 2 million packets per second, I would like 2 million packets per second to come out the other end. And if not, I'm losing them somewhere. And then number 4 is just this insanely detailed set of counters, packet counters, error counters, bytes, you know, all that type of stuff. So the spoiler I'll get to first, this is an MPLS load test doing 40 gigs of traffic at 512 byte frames, which is roughly 9.4 million packets per second, through 3 VPP machines and 4 MPLS switches between them, which I'll show in a little bit. T-Rex is getting hot. It's 32% of its capacity, which is not linear. Eventually, it just goes up like a cliff and just craps out. And I've run it for a while. I took a screenshot this morning. I started the load test on Saturday. So it's done 0.7 exabytes of MPLS traffic in about 1.4 trillion packets, and all of them made it. Not all of them, because eventually I tried to find like saturation points, so some of them got lost, but in general, this stuff works just fine. So I want to show you 2 configurations I think are super cool, especially the second one. The first one is just on the right-hand side, you see this T-Rex machine, and on port 0, it's emitting traffic, which is going to 48/8. And on the bottom one, port 1, it's sending traffic that goes to 16/8. Right, so these 3 machines, France, Belgium, and Netherlands, are meant to forward traffic through one another, you know, northbound to port 0 and southbound to port 1. So what it looks like is on XE0, which is a 10 gig interface, give it an IP address, the one that connects to T-Rex, and then route the 16 back to port 0, because that's where it's destined, and route the 48/8 down to Belgium, but impose an MPLS label. By the way, I use MPLS labels with the country codes, and so Netherlands will be 31, Belgium will be 32, and France will be 33. And so if in Netherlands I want to send it destined to France, I impose the label 33 and send it off its merry way. But similarly, when I receive an Ethernet frame that has the label 31, and it's an EOS, which means end of stack label set, then what I want to do is pop it and just look up the result in the IPv4 routing table. So that's how I decapsulate MPLS that came from France up north. Belgium, super simple. It just does 2 swap operations, actually swapping with the same number. So when it sees label 33, it just goes pass it on down south to France and give it again label 33. France is the same, but the other direction. So that's configuration number 1. This is an L3 VPN, essentially. And Belgium doesn't have IP, right? It only acts as an MPLS label switching P router. The second config, I think, is just beautiful. And it shows really the power of the data plane that you can configure to do essentially anything you'd like. In this case, I create an MPLS tunnel, which is a virtual interface. And I say, if you get something transmitted into this tunnel, what I want you to do is encapsulate it in MPLS, send it south to the IP address of Belgium, and impose label 331. So what happens next is you get a new interface in VPP called MPLS Tunnel 0. And then I also say, well, if you get any traffic that has label 311, what I want you to do is decapsulate it and then send it as L2 input into MPLS Tunnel 0. Right? So here's where we got stuff from Belgium on the wire, and it was MPLS, and I just decapsulated it, saw whatever was in there, and stuffed it into MPLS Tunnel 0. And then I can cross-connect these two interfaces with set interface L2 XConnect. XE1 goes into MPLS Tunnel 0, and MPLS Tunnel 0 goes into XE1. So what I've created is a Martini tunnel. Belgium, again, does not do anything fancy. It sees label 331, pushes it down south to France, again with label 331, and France obviously does the same thing, but in reverse. So this is an L2 VPN, an Ethernet pipe, 9,000 MTU easy, encapsulates in MPLS, sends it to Belgium, which doesn't know what it's forwarding, because for it, it's just all MPLS traffic. So what is this thing doing, really? So this PE ingress, Netherlands, that's taking the IPv4 traffic, right, the first example I gave, actually traverses this graph, and I drew it precisely as it is. DPDK got the traffic, sent it to Ethernet input. Ethernet input said, this is an IPv4 packet, let me give it to IP4 input. IP4 input said, I don't need to do checksum checking because I offloaded that to the NIC, huzzah, let's save some CPU cycles. IPv4 lookup then in the fib goes, hey, you're supposed to impose an MPLS label, aren't you? And so it hands it off to IP4 MPLS label imposition pipe, which is the thing that rewrites the packet, turns it into an MPLS packet, and now I'm ready to send it out on its way. So that thing hands off to MPLS output, which figures out which interface to use. The interface output figures out which MAC address to send it to by doing an L2 fib lookup. And then interface TX gives it back to DPDK to marshal it on the wire. That's what Netherlands does. Belgium is slightly different. It also gets DPDK packets through Ethernet input, but they're MPLS, right? They're not IPv4. So MPLS input says, right, let's go do a lookup on the fib. Let's figure out what to do. And it said, please swap the label with the exact same label, and then send it to MPLS output, marshal it on the wire, and send it down to France. All right, so the bubbles are a little bit different. And you can imagine, because this runs in CPU, like in software, the cost you incur might be slightly different depending on which path you're taking. You can see this in super precise detail because VPP, for every node in the graph, counts the amount of clock cycles the CPU took to marshal sort of a set of packets through that bubble. And you can type show runtime on the CLI. There's an API for it also. And it shows you all of these bubbles that I just showed, how many calls we did, as in how many times did we invoke that function, how many vectors, which are packets, how many packets in total, and then how many packets each time we called. And if it was only one packet each time we called because this router was bored, it wouldn't be particularly fast. But if it's 100 or 200, it'll be way faster because it amorts all of its cache. So to do this now, you can count the clocks. This is super cool. The blue line there sums up to 259 clock cycles spent, on average, doing this MPLS forwarding. We have a CPU clock speed of 2.2 gigahertz, so divide the two, and you would think 8.49 million packets per second. And if you see, it observed itself at 848. Right, so this almost precisely adds up. The only noise you'll see there is that every now and again, the thread may spend a couple of cycles doing other work. But it's very precise. So I said CLI, but there's also an API. You can call it and get all of these numbers out, right? And so now we get to the conclusion with 3 minutes on the clock. So I hooked it up to Grafana using a Prometheus exporter that I wrote. And then I do this linear ramp up from 0 to 100% of line rate. but the graph is logarithmic, so it looks kind of like this weird, bell. But what we're doing here is starting with a 1,500 byte iPerf load test, which is trivial. It's like 810,000 packets per second or so, and it works just fine. And then iMix, which is a mixture of small, medium, and large packets. And then 64 byte, the smallest we're allowed to send, but with multiple flows, which means we can use multiple receive queues and multiple CPUs, right, to forward this traffic. And then I did something more insidious, which is I gave it one flow, which means it can only hash to one receive queue, which means there can only ever be one CPU doing this work, and now you can see the bottleneck of the CPU. And it draws really cleanly at 848, which is also what we measured in the previous slide. And so I know that forwarding this type of traffic, this is MPLS forwarding, comes in at about 8.48, 8.5 million packets per second per core. And if you look at the total clock cycles spent, you can see that it goes down greatly. The average amount of clocks in the beginning on the left-hand side, when I was doing this big load test, is 193 CPU cycles every time I want to do an MPLS label swap. But if I push it really fast, it goes all the way down to 21.6 clocks per MPLS label swap. And that is an order of magnitude faster. And this is actually what makes VPP really fast, right? The ability to apply the same operation to hundreds of packets at the same time. All right, conclusions may be a little bit more boring, but I figured since I did all these load tests, I may as well report on it. I can create these bottlenecks by forcing all of the receive queues to sit on one CPU thread. That's the command that I showed at the top. So set interface RX placement for XXV0, 25 gig interface, Q0 to thread 0, Q1 to thread 0. And therefore, I can figure out exactly when I'm doing certain types of operations, what is my bottleneck exactly. So the numbers, I'm not going to read them all, right? But there are somewhere between 7.5 and 9.3 million packets per second doing MPLS operations. Interestingly, I said it before, penultimate hop popping does help because it means the Belgium router will unwrap the MPLS packet and turn it into an IPv4 packet and just send it off to France, and then France sees it as an IPv4 packet, right? So when I do PHP, actually the middle router is faster already because it doesn't have to do the second fib lookup, just has to unwrap and forward. And the third router is also faster because it sees IPv4. L2 VPN ingress is a little bit expensive. I should probably look into this because I didn't think it would be that slow. But when I say that slow, it's still 15 million packets per second, right, on the super micro. And just for the record, if you take a Dell, like a new one, like a 640 or something that has maybe 64 cores and PCI 4 and all that stuff, it's just going to go linearly up. So the Dell that I tested with last year did about 10 to 12 million packets per second on one CPU thread and has 64 cores and 64 hyperthreads, right? So that thing does about 800 million packets per second. Yeah, that's it. Sorry. Unbelievable.
The clock is at 0000. Pim, just that fact alone makes me reconsider your position on my personal hero list. We may discuss in Thursday's colloquial meeting. Anyway, any questions for Pim? Or is everybody blown away? Which I can imagine.
I'll just continue, like as the...
Hi, you were showing that kind of lab setup with the Open vSwitch and the whole virtual router setup. Is that open sourced anywhere?
Yes.
Because it sounds very interesting to have a look at.
Yes, I'm happy to send you the link to it. It's not on GitHub, it's on my Gitty. But you're welcome to take a look at it. I actually also wrote an article about this, which shows how you create the image and how you populate it and how you make all the machines get their own IP addresses, some Ansible type stuff, as well as ZFS replication for the block devices. Totally over-engineered, but it's really nice, and I'm happy to share it.
All right, I'll maybe find you in the coffee break and ask you for the link.
Cheerio.
Hi, Sander Stefan. Pim, thanks, this is really awesome. Just a note for people, like I played with VPP years and years ago when I was doing some MAP-E, MAP-T encapsulation stuff. And I was doing some testing in the big lab from a big American ISP. And we couldn't, this was a box with 400 gig interfaces. We couldn't get VPP above 180 gigabits in total. And we were very puzzled and like looking at the CPU, like this box has plenty of CPU, plenty of memory.
Yep.
And then we realized that that wasn't the problem. We were just flooding the PCI bus.
Oh, yeah.
So people playing with this stuff, like these days you have PCI Express 4. This was a PCI Express 3 machine. VPP is not the bottleneck. It's usually your PCI bus. But yeah, this stuff is amazingly fast, and I'm really impressed by the stuff you did. Thanks.
Thanks for the call out. Also, totally true. The previous talk that I'll quickly refer to, the Sweenon talk, does actually call this out because I did it on a Ryzen, and a Ryzen is a consumer PCI, consumer CPU, and it has 32 cores, and it's like super fast. And it did 20 million packets per second per core, and it has 32 of them. And then it has like 24 lanes of PCI, one of which is the video card, right? So you're kind of screwed. By the way, there's a call to action here for the rich people. I do want to hit the terabit mark and the 1 billion packets per second mark, for which I need like the aforementioned PCI 4 and like big Rome machines or like Xeon Platinums. So if you have any, and you're willing to ship them to Zurich, let me know.
Just to be sure, that is the 1 billion packets per second mark, in case people didn't pay attention.
Yeah, 1 billion. I got one more slide. I'm not going to show the last one because I don't want NLNOG to get a copyright strike. But this is the Grafana dashboard. So the dashboard is easy. That's not very difficult, but the VPP exporter needed a little bit of work, and I'm sort of negotiating with the VPP developer community to upstream it. If you want it, it's fine. It's based off of open source code, so you just hit me up. But I didn't want to publish my own because I really wanted to upstream this one directly and not be like the rogue that keeps on writing his own code. And then the last thing that I wanted to show you, this is kind of just a cute...
Ended at 000,
cute
right?
sum up.
Yeah.
50, all right, fine. 7 exabytes sent during the load test from Saturday to right now, and just no crashes whatsoever. Data plane was brought up, MPLS configured, reconfigured, IP4, MPLS, all that stuff. Not a single crash observed. This stuff works like a boss. That's it.
Awesome. Thank you, Pim. We have a little something to keep you busy in case VPP doesn't. And then, it's an obvious link between Pim's presentation and Mike's presentation, because Pim mentioned that he has IPNG, which used to be the name of what turned out to become IPv6. Now, the thing is, Mike is going to present something about IPv6, and I always say, hey, you don't need any firewall rules on IPv6 because there are no hackers on IPv6. It's very secure. So when Mike sent us a proposal for a presentation titled, "Is IPv6 more secure?" I was obviously kind of tickled because this is what I always say. The thing is that, we may want to see some proof about that, and I want to know if I was right or not. So let's see. Michael Booth.
Hi, I'm Mike. This was originally going to be titled Corporate Politics and Security for IPv6 world, but it seemed boring and misleading, so I've changed that to Is IPv6 better for network security? And there's still a little bit of the corporate stuff in there, of things I wanted to do that I couldn't do. I started off as a junior engineer in the UK, and I said, why don't we move to IPv6? And at the time, the team in the UK weren't keen on IPv6, so that didn't happen. And I've carried that theme on as I've moved around. So I was told I'm allowed one slide of my company logo, but we have quite a few. So I work for Liberty Global, but we operate in other countries. So in the UK, we're Virgin Media. Here, we're Vodafone Ziggo, and we have Telnet in Belgium and various other names. And in some of them, we don't do so much IPv6, and I'd like that to change. And that was kind of the underlying statement here, and we should acknowledge our biases, I guess. I wrote this as an internal memo with the aim of convincing people to move to IPv6. So I think everyone should be familiar with what IPv6 is, and high level, I'll just quickly cover off here. There's two charts. So on the left, we've got Google's IPv6 usage. So this is based on consumers going to Google. That's YouTube and Google searches. And they're saying they see around 40 to 45% of the traffic coming to them is IPv6. On the right, there's slightly different numbers. This is from Jeff Houston at APNIC Labs. And he's seeing slightly lower numbers. He's saying 30 to 35. I talked to him about this. He said the difference, he thinks, is because he's also querying China, whereas obviously Google maybe doesn't have so many customers in China. So there's a 10% difference. He's saying it's probably related to China. But I think we can all agree 30 to 45% IPv6 usage globally seems like a good number. So 6830 is a tier 1 ISP, which means we get a really good perspective of a lot of the traffic going through the UK, through Europe. Okay, yeah, a bit funny. Okay, it looks better for me, but yeah. So we get a good view of what's going on through Europe. A lot of networks and a lot of traffic users are tier 1. So whoever your home residential provider is, there's a fair chance that it's going to cross our network at some point. And that gives us a really good insight and a really good bit of visibility. And then it's only fair to show our internal numbers of what we see. So these are the countries we have operations in. We also operate in other countries, but these are where our major eyeballs are. And we can see a fair number of IPv6. We're kind of slightly below what Jeff sees, but we're there. In most countries, there's maybe one outlier. And then moving on to DDoS mitigation. So we offer this to our customers if they want it, if they'll pay for it. On the left, I don't know how clearly you can see it here. On the left one, we've got a V4. It's a DNS-based amplification DDoS. So it's about 20 gig of traffic going to a single /32 address. It's quite a lot. If it's a small business, that'll probably overload them. And we have the ability to just scrape off anything we think is a DDoS and only send valid traffic. So we do a bit of anomaly detection. We say that seems weird. They've got a lot of DNS requests coming from Russia. Probably don't want that. We'll take it away. And on the right, we've got something similar for IPv6. It's a /128. So again, a single IP address. This is not so big. It's smaller packets, but it's the same thing. And it happens in both IPv4 and IPv6. We see it happening in both, and we can mitigate for both as well. And I was looking at this a while ago, and I got thinking, I see a lot more come through in IPv4, and I see a lot less in IPv6. There are some DDoSes in IPv6, but there's a lot less. And I wanted to try and understand what that difference was. So I went through and I queried our results, and I got the results for the year of 2022, and these are the differences. So this is a linear chart. So in blue, we've got the IPv4 DDoS attacks, and in green, the IPv6 DDoS attacks. It's quite different. We see about 100 times more IPv4 attacks than IPv6. That makes about 1% of the attacks are IPv6. Now, we saw earlier, and I think we all agreed, 30 to 45% globally of the traffic we're seeing is IPv6. Is it unreasonable to expect a similar number? I don't know, but we're seeing a lot less DDoS attacks on IPv6. That could be the end of the presentation, but then I started wondering why that was, and I wanted to dig into it a little bit. So I came up with a few avenues and ideas I wanted to look into, and I've got some here. So first of all, a lot of the DDoS attacks we see are botnets. So this is a bit of malicious software that's installed maybe on your laptop at home, and it sits there, it reaches out to a command and control system, it gets guidance on where it should attack, and it kicks up, it starts running, and it executes and it targets the system. A lot of malware like this is, well, there are trade-offs to be made. So size and complexity are traded off against detectability. So the bigger it is and the longer it takes to run, the more likely it is that antivirus will pick it up or something else will see it. So a lot of these programs will try and be as small as they can and use common APIs to avoid detection. The example here is Mirai. It's a Linux-based bit of malware. It's a DDoS bot, and I don't know how clear it is on the screen, so it's identifying in the middle there IPv6 indicators. And we looked into it, and on the right there, we've got the list of the IOCs. So these are the addresses that were found. Now, I don't know how clear it is, but when I looked at that, I didn't see any IPv6 addresses. I only saw IPv4. But I wanted to look into it in a bit more detail. So I was told not to do any live demos, but I'm going to give it a go. And I've got backup slides if not. Oh, indeed. So I've downloaded a smaller, simpler bit of malware from Malware Bazaar. You can pull whatever you want, really. And I've copied it already, and I've got it here. So I'm going to take this to the first line to start with. Maybe. And I've got a PowerShell window open already, and I ran a get variables just to show at the top. The system variables are set. I haven't run anything yet, so it should be good to go. This is the first line. It doesn't show so well on the screen, but it's a lot of variables with blank spaces. It doesn't really say what it's going to do. We can run it. Didn't do anything. So you can see here the environmental variables have changed. We've got a number of variables that have got names there that are just blank spaces, and they have values. So that seems pretty harmless. It's just set some blank variables. Okay. Then I've got the second line. I'm going to be careful here not to get the pipe at the end. That's going to execute the code, and I don't want to do that. There we go. You can see it. It's just more blank variables. And then when I run it, it converts all those blank variables. So that was obfuscated code. Now it's saying we've got a ton of chars. So it's converted those to chars. But it's still pretty meaningless. I struggle to copy and paste this next bit, so I'm going to... It's the same code. I just pre-did it 4 or 5 times beforehand to make sure it would work. So when I paste that in... Crap, okay. Right. Yeah, so I prepared some backup slides. Here's the same code. Oh, it's bigger. Maybe that's better to see. So at the end, I just miss out the pipe in the execution, and it runs and it compiles to this. This is a PowerShell script, so it's slightly different. But the key bit here is on the fourth line down, you've got a URL there. So that's an IPv4 address, clearly. So that's hard-coded in. And if someone was to look at this and report the indicators, what they're going to say is they're going to say, hey, we see this bit of malware, and we see it's only got an IPv4 address. Clear. OK, case closed. If we look a little bit further down, it's client new object, and then it calls system.net web client. So that's the Windows framework. Now, Windows as an operating system is dual stack. So if this is in a laptop at home running on Windows, and if that laptop at home has a residential connection, and most residential connections in this country, the Netherlands, have dual stack IPv6, this could still be used, even though it's only got a IPv4 address as the command and control system. This could still be used for an IPv6-based DDoS attack. So the malware, when I looked at this, we started to think we were on a line, and then we realized this isn't an indicator. This doesn't tell us that we can't do IPv6-based DDoS attacks. And I went a little bit further, and this is I've got an example here from a friend, Pavel. He's tried to install a new computer using only IPv6. He had a few issues with genuine software, and he said, hey, I can't get everything working, and Spotify here was his example. And I don't program in Go, but I read a blog that said in Go you've got 2 different, and I'm looking for Ben to nod here when I say this, you've got 2 different frameworks. You've got net.ip and netaddress.ip, depending on if you're, maybe I'm not true. Sure, okay. There we go, I was right. So what I came to realize is some bits of software do support IPv6, some don't. And if we go back to saying about needing to duplicate code and keeping code as small as you can, potentially you're going to be in a situation where you can't use system libraries and you've got to double your code base, which isn't good. It's going to make the malware easier to detect, which isn't good. But on the whole, we can't really say that the malware doesn't support IPv6. So that's not something I'm going to come up here and say. I'm explicitly not going to say malware doesn't support IPv6. It does. But I'm still going to say there's a lot less IPv6 DDoS attacks. So where can I go from here? Another way that DDoS attacks happen is with spoofed source addresses. So this is when, in this example, we've got at the bottom, a AS65536. They run an open resolver. They want to answer some queries. And they expect queries to come from Contoso on the right here. And any queries they get to Contoso, they're going to happily answer. What they don't account for is Fabricum on the left here, sending them some other queries, but pretending to be Contoso. So they're going to send their replies to Contoso, probably amplified. This would be a spoofed attack. So we get bad traffic coming in on the left, getting amplified and getting sent to a genuine source. And this happens. We see this quite a lot. And as a tier 1, we're able to work with other tier 1s and also some of the CDNs. And we can see where this happens. And we can trace this kind of stuff back. In this example, one hop, we could say, we can see the bad traffic coming into the network from Fabricum, and we should see it should be coming from Contoso. But we can do this globally. We can work with other providers, and we can trace things around the world. So we do that. And if we see something that doesn't look right, we can trace it back, and we can find where it comes from. And that was another factor. So I started looking into this a little bit. And this is one of the reports we've generated. I've left the names in. It's factual. This is an average week. This was in September. And we saw all of these DDoS attacks on the left coming in. So I'll call out, there's 2 government ISPs. We've already highlighted that China's potentially partly the reason that Jeff sees a 10% difference in IPv6 usage. So maybe some of the government ISPs we see that are involved in this kind of stuff are focusing more on IPv4. Maybe that's a factor. We then looked at some of the providers. So these are VPS providers. And we're thinking here again, if you're a bad actor and you want to get access to a server, you want to do something bad on it, you're aware that if you get caught, it's going to get taken off you. So you don't want to spend too much money, and you don't want it to be traced back to you. So then I looked at what I could buy anonymously and cheaply. And on the right is just a print screen from a VPS seller. So I found I could sell for 40 euros, I could buy a server. But the base models, the cheapest ones available to me, only have IPv4. So I don't know if you can see, it's a little bit blurry, but they only have IPv4. And that's very different to, I think, what Amazon's doing now, where they're charging for IPv4, and you only get IPv6 for free. And I'll call out as well, Amazon do a great job making sure there's no spoof traffic on the network. And when they see DDoSes, they're very good at blocking it. They're very responsive to us. We're happy. But this other provider, they're providing IPv4-based VPSs, and we see them on our reports, and that's not nice. So here's another option. Perhaps the sources of DDoS attacks and where they're originating from, perhaps they only support IPv4, and maybe that's why we're seeing more traffic coming through on IPv4. Another idea I had was maybe a knowledge gap. I looked at the CCNA modules, and I can tell you in there's a little mention of IPv6, but it's more of a ticking the box exercise. They switch straight back to IPv4. I think that's true for a lot of things. There's probably a bit of a knowledge gap where you learn IPv4 first, you can go ahead and start working, and there's no need necessarily to learn IPv6, because everything just works in IPv4 for now. So I called that out as another factor. And then finally, I've got the big one. I think this is probably the one that everyone's sit there going, oh, has he not seen this yet? Yeah. IPv6 space is way bigger than IPv4, and it's not possible to scan. So there's an example here that says exactly the opposite, IPv6 scanning world, and I think this was Shadow Server who said they were able to scan some of the IPv6 space, which is great. But the truth is that every residential customer has a /56 assigned to them. That's more address space the entire IPv4 pool. That's not something that anyone can scan. So I think quite reasonably you could sit at home with an IPv6 server open with whatever ports you wanted. No one's going to find it, and no one's going to be able to compromise it. I think it's very unlikely. There's a bit of security through obscurity here. And I can put my word to that. I've got a VPS that I just saw running. That's open on IPv6, and it's not been compromised since I set it up yesterday night. Yet. That's not a challenge. So then we looked at other things. So we also get abuse reports. So I've got some examples here coming in, going in to us. These are public information feeds. So Shadow Server runs a really good one, and some other teams as well. And they'll scan the internet, and in IPv4 world, they do this really well, and they say, hey, we found these ports open, and if it's one of our customers, we can write them a nice letter, we post it out to them, hey, you've got this port open, we think it's open to abuse, you might want to close it down. I should note here, we don't scan our own customers' ports, and we don't scan traffic. These are public feeds that everyone can access. And then finally, at the bottom, I've got an IPv4 scan. So we do vulnerability scanning. And we do this in our enterprise situations, but it's quite slow. This was scanning 50 IPv4 addresses, and it took 20 minutes. Imagine trying to do that for, 360 undecillion addresses? It's not going to happen. So at the end of the day, I'm kind of saying there's a bit of security through obscurity. Attackers are currently focusing on IPv4, but they're fully capable of reaching IPv6 if they want to. And when we look at it, what would an attacker gain from focusing solely on IPv6? Very little, because everyone's dual stack or IPv4 only. They aren't going to find many new targets. But there are a few IPv6 attacks out there. And we do think IPv6 attacks are going to increase as time goes on. Oh, I'm out of time. But it won't be easy to identify compromised devices. I've got one more slide. Can I go? Okay, I skipped that one. And this was an enterprise vulnerabilities view. So we sat down with our corporate enterprise teams, and this is not for our customers, this is for our internal stuff. We wanted to know what we could scan and what we weren't scanning. So we looked at what we knew. We knew our server configs and our router configs and our domain names, and we can pull these and we can make sure we're scanning all of our own systems. We know our prefixes, and we know what hardware we're running, so we can guess the addresses there. And we also run our own firewalls and routers, and we can look at the logs and make sure we're scanning anything there as well. But what we can't do is we can't scan all of the address space we have. We can only scan what we know we're using. We came up with a few examples what enterprises could do. You could scan your Slack addresses or IPv4-based addresses, and on a single LAN, you could do some multicast scanning and DNS-based scanning. But I leave it with a question from me to you, actually. What could we do to scan more IPv6 address space and better protect our customers?
Right, well, does anybody have the answer to that? Not yet. I would like to bring to the table, you mentioned that hackers don't have anything to gain by using IPv6, but I would like to bring to the table that I think that many firewalls are not configured for IPv6 at all and will just pass it. They might have elaborate IPv4 rules, but nobody ever thought of v6. I don't want to bring any inspiration to any aspiring hackers in the room or indeed on the stream, but I think it might be easier to compromise a host over v6 than it would be over v4. But who knows? We have time for a question.
Hi, you showed the provider Hetzner online. They're dedicated servers, but you call them VPSs. They actually have dedicated servers, and they do have IPv6. The IPv4 is just laid out because they charge extra for it. So it's like a feature they have, but you can pay less if you want IPv6 only. So you actually get a /64 that you can do stuff with.
So these servers do have IPv6?
Yeah.
My mistake then.
They do have VPSs, which are even cheaper. So in theory, those could be used maliciously for very little money.
Good. Good to hear. Thank you, Michael. We have a present for you. Hang on. We would like to say thank you. There we go. One more presentation before the tea break, and this is from a guy who, in the evenings and weekends, runs an organization called eventinfra.org. And they also provide the Wi-Fi on this event, which is why you all have a nice public IPv4 address on your telephones if you joined the Wi-Fi, in addition to IPv6, of course, which is more secure, as we just learned. But during the day, this guy works at i3D. And he's going to tell us a little bit about some spoofing, well, not initiatives, but detection that he's done on various internet exchanges that they are on. Arjan Kopen.
Hi, my name is Arjan, and today I will tell you something about BCP38 violations and that we're seeing on internet exchanges and how we deal with them at i3d.net. So just a very quick BCP38 recap for people that might not be familiar with it. BCP38 is all about anti-IP spoofing. It describes best practices for implementing network ingress filtering inside of your network, which will prevent end users from sending IP spoofed packets. And that will result in your network, or prevents your network from being abused to trigger denial of service attacks. BCP38 is also one of the pillars of Manners, and Manners is a routing security project. Another well-known project inside of the community is the Qaeda Spoofer project, and with the Qaeda Spoofer project they're doing automated IP spoofing measurements using probes in various networks, and they are publishing those results on their website. IP spoofing can be abused in various ways. Two common types of attacks are reflection attacks and hiding attacks. And with a reflection attack, a large DDoS attack can be triggered by spoofing the IP address of the victim and sending the request to various reflectors. And these reflectors can be services such as DNS servers or NTP servers. And by sending a large amount of requests to these reflectors, the victim can be overwhelmed by these responses. And these responses are usually much larger in size than the initial request. Hence, the attacker does not need to have a lot of bandwidth in order to trigger a large DDoS attack. And this is also referred to as amplification. Another type of attack is a hiding attack, and with a hiding attack, the victim receives a large amount of UDP flooding or a replay attack, and here the source IPs are random and also spoofed. And because of this, it's quite hard to trace back the origin of this attack. With this, there's no amplification at play, so the attacks are usually quite a bit smaller. How should you implement BCP38? Well, highly simplified, you should enable this in your router's configuration on the layer 3 interfaces that are facing your endpoints. And this could be as simple as enabling features like RPF check or URPF, or if that's not supported, it could also be a static access list or firewall filter. So in the next 3 slides, I'm showing you some traffic that, spoof traffic that we have received in the i3D network on external facing interfaces in a period of 30 days. And as is tradition, I've cut out the y-axis, but it's not super relevant for this discussion, as like in a perfect world, this graph should all be empty, but yet here we are. And this specific graph shows spoofed traffic where the IPs that are being spoofed are actually, they are owned by i3D. So this traffic is showing triggering packets for reflection attacks. And I have to note here that you would only see this type of traffic if there are also reflectors active inside of your own network, such as DNS and NTP servers. And this, most of this traffic we're seeing here comes in our network over transit, but there's still a considerable amount of traffic coming in over internet exchanges and private peering. In this graph, we're showing traffic from hiding attacks. And here we are specifically filtering on bogon IPv4 ranges. And they can be ranges such as the multicast range or reserved range, local host, etc. Most of this traffic for us is coming in over internet exchanges and private peering. And if we dig further into these kind of attacks, we can see that they are simply like spoofing the whole IPv4 internet. This graph is also showing the hiding attacks, but we're taking a little bit of a different approach here. Here we are specifically filtering out those bogon ranges from the previous slide, but here we are filtering inside of the flow data on source AS0. And source AS0 in this context means that the router who has received the traffic does not have a route object or not a route programmed into his memory. And all of these routers do actually have a full table inside of their memory. So if they're receiving this kind of traffic and they cannot match it, this is highly likely also to be spoofed. In conclusion, this kind of feels like dweilen met de kraan open, which is a nice Dutch saying for mopping the floor with the tap still open. How can you detect BCP38 violations in your network? Well, one good method is using flow monitoring. And this is, for example, generated by the IPFix protocol. You can look for flows on external-facing interfaces, filter on source addresses in bogon ranges and your own prefixes. This works quite well for private peering and transit interfaces, assuming that your transit provider is also willing to help you with your investigations. But it can work quite poorly on internet exchange information if the layer 2 information is missing inside of the flow data. Because there are many different ISPs on the same peering LAN, you would need this layer 2 information, namely the source MAC address, to figure out who is sending the spoofed traffic. In our case, we didn't have this information in the flow data. So, one approach that we took was to use a firewall filter or access list and syslog. It's not great, not terrible, but it did work for us to get this information. So we can trace back the origin of the attack. And again, with this, you would be filtering on bogon ranges and your own prefixes. There's a number of bogon ranges named here at the bottom, and it's best to exclude any RFC 1918, 6598, or IPPA addresses due to net misconfiguration or malfunctions. At least we saw this quite a lot where this was not working correctly, but usually there's no malicious intent, even though this is not supposed to be on the internet, of course. So with Juniper routers, it's possible to take this firewall and syslog approach. If you apply a firewall filter on a family INET interface, you will get syslog messages which will include both the layer 2, 3, and 4 information. So then you will have access to this source MAC address that we want to know, and you will send this this data to your favorite syslog collector. In our case, this is Greylog. Here below, there's a grok pattern that we're using, and this is a way to define a structure of the log data. And tools like Logstash and Greylog, they use this kind of pattern. What can you do with this data? So we've written a small script that does a correlation of the data using the various APIs that are available. Here we have our router sending the violation syslog data to Greylog. Greylog then uses an extractor using the grok pattern from the previous slide, and it will aggregate the data based on source MAC address, device, and interface. And then we have our script that will pull a list of these violating MAC addresses. Then we figure out which peering LAN IP address is bound to this MAC address, and for this we're using the LibreNMS API, and the LibreNMS API has a list of all of the ARP entries on the various routers. Optionally, we are doing also some lookups in Netbox to see which of our customers is being targeted, although this is, of course, not needed if we're sending an email to an ISP telling them about the BCP38 violation. Once we have this peering LAN IP address, we can do a lookup in PeeringDB to see, hey, which ISP is using this IP address, and also find the contact details for them. And once we have all this information, we will send off a generated email to this offending ISP. And apparently there was also I think a recent feature added to BGP.tools where you can also do MAC address lookups directly in their database. So that's also, makes things quite easier. But I recently learned this a couple of days ago. Right. As a proof of concept, and for academic reasons, I've sent some spoof traffic from the event infra network for testing. And the event infra network is the network that I'm also involved with, and and is also being used right here at the event. And in theory, you should not be able to spoof any packets from this network, but if you can, then let me know. We're using, this is a small Python script, and we're using the Scapy or Scapy, or however you want to call it, library to craft some spoofed packets. And then we're sending these spoofed packets over our favorite internet exchange, VisaX. And so with the script we have on the I2D side, we can generate a short list of offending ISPs. And then we can click a button to send an email, a generated email to this ISP. So here we have an example email for the spoofing incident across VisaX to event infra. Right. What experience did we gather while contacting offending ISPs? In general, the response rate is not very great on the emails, but when the ISPs respond, most of them are willing to help, and because there's usually some misconfiguration or bugs that are at play. In a number of cases, the downstream BGP customer of the offending ISP is generating the spoof traffic, which means that actually this customer needs to implement it, and the lead times can be quite long because of this. In some rare cases, when the offending ISP is not responding, we can also try to escalate through the relevant internet exchange, but not all internet exchanges, they have a very good process with dealing with these kind of issues, which will also increase the lead times up until it's fixed. For us, the largest amount of IP spoof traffic is received via transit, but not all of these transit providers are willing to help, or might only help you if you are buying additional services with them, which is a bit of a shame. One thing that's not on this list, but which will always also tend to happen, is that if we contact ISPs, they will say like, oh yeah, we've disconnected this customer, and while they should actually be implementing BCP38. So that also tends to happen quite a lot, where the offending ISPs are just kicking out the customer, but then maybe a couple of days later this customer will be back, especially this is relevant in the hosting business. Lastly, we have some statistics from the past 2 months for spoofing incidents in the I2D network. And this is only for internet exchanges. So we had 126 different ASNs with BCP38 violations, and 203 unique MAC addresses with these kind of violations. I also checked this morning to see if there were any of these ISPs that should supposed to be member of Manners, and there were 16 ISPs that are Manners member, but apparently you can spoof traffic from them. So that's So, right, what's next? Yeah, we'd like to see more operators to take a similar approach as we're doing, which means detect spoofing incidents that are coming into your network and contact the offending parties. We want to work closer with transit providers to find offending parties and talk to internet exchanges about improving incident handling. And we want to, if possible, get rid of the syslog approach that we've, or the firewall filter syslog approach that we've talked about, and convert it to a flow data approach. And apparently this should be possible with a new version of the network operating system that we're running, but it's still in investigation phase. And lastly, we also want to improve the spoofing detection for our own IP transit customers, and this could be by using the same sort of dynamic route prefix list that we're using and combining those with firewall filters or something along those lines, but this is also still in an investigative phase. So, that was it. Are there any questions?
Thank you, Arjan. Are there any questions other than what is BCP 38?
Hi, it's Will from LONAP on Tiptoe again. I was interested about your comment about asking the Internet Exchange to do something in the case of spoof traffic, because actually, as it stands, I'm not able to take action on that because it's not a breach of our technical requirements. I'm wondering if you've looked at IXPs you're connected to and whether you have started thinking this is a good idea and whether you've surveyed those kind of requirements, or whether Internet Exchange is simply saying to their members, hey, this sucks and you should not do this.
Yeah, it's mostly about we've seen issues where their members are not responding. So in this case, it's nice that the Internet Exchanges will be helping us to get in contact with the other member of the Internet Exchange.
All right,
so that's
like
mostly what we're expecting, and yeah.
Yeah, it's like a kind of please be polite and reply to these guys or help with a better contact. Right.
Yeah,
okay,
that's sort of maybe an escalation part where,
I'm very wary of changing these requirements and maybe working our way up the stack. It's kind of concerning for me. So thanks.
Yeah.
Guys, who has the best question?
I'll fight you.
All right.
We're standing in front of your coffee break. Sorry.
So, in general, when you got replies, I'll explain. I recently got a reflected denial service, and I was lucky enough to receive it over links, which meant I could look up the MAC address. When I emailed their abuse thing, I used BGP Tools as customer database because they're a member to also get their NOC addresses. They didn't respond, but their abuse system very amusingly said, due to the fact that we have so much abuse, please submit a ticket instead. We have deleted this message without reading it. How often do you encounter what I can say is almost malicious compliance on the abuse handling side? And do you threaten de-peering these people and pushing them over transit to, I guess, increase their costs? I don't know. How do you punish people who do this? Because it's a real pain in the ass, right?
Yeah, I think we've seen some cases where if we try and steer it over transit, then might be some transit providers that are actually applying BCP38 firewall filters on specific customers that are known for being sort of abusive like this, and that sometimes could be a strategy to sort of, if we're steering it to transit, it could be a way to get rid of the traffic, but that sometimes works, but yeah.
All right, sorry, we're not able to take any more questions because we are exactly, more than half an hour behind on schedule. Mm-hmm. Thank you again, Arjan. We have a present for you as always. Well, I know a very easy way to make good on that half an hour. We simply shorten the quiz to 2 questions. No? Okay. In that case, coffee break, and we see you again at 4 p.m. Well, welcome back. I see that the room is a little less crowded than it was before. I did just now, minutes ago. Yeah. But anyway, we have 2 more fantastic presentations lined up for you for this day, and then, of course, the merciless quiz. And okay, we won't shorten it to 2 questions. That might be a little bit too easy. The next presentation is by Pim van Stam, and Pim is a bit of an invisible figure, or at least he always has been. Because if you look him up on LinkedIn, there is no photo, and well, basically you only talk to him if you need him, but then you are not allowed to talk about it. So it's a little bit complicated, but this has changed. Pim is no longer with NBIP, but he's doing something else, and he uses open source software to do something else. And today, here he is to talk about that, Pim van Stam.
So, hello, good afternoon. Here it is. Bit lower. Well, let's talk about OpenLI. I don't know if there are any people here with a legal background, perhaps. Great, at least one. This is a topic where most people, I guess, don't like to talk about. The introduction, thank you. Got a bit in that direction. Tapping of internet, lawful intercepts is not something we want to talk about, except for this person and myself. But you're still here, so let's see what's on this topic. Yeah, it's on the screen. I have some abbreviations here. You can read it through if you don't know what it means, like law enforcement agency, etc. In the presentation, I used a couple of abbreviations that are non-technical, and perhaps you don't know what they are. But it is in 3 items. What are the obligations network operators and service providers have? And what is the OpenLI software? And can we use it here in the Netherlands as an alternative? That are the topics for today. And the lawful intercept for ISPs came from, well, around 2001. And I'm in this topic as well from that time. So more than 20 years of experience with the lawful intercept. And this is from the telecommunications law that all providers, service providers and network operators must have their network tappable if they have public services. That's mandatory, you have to do it. So I guess that most of you have somewhere in the network something like this. The other article was very important, that you have to cooperate if there's a warrant. And a warrant can be from the police or for the intelligence agencies, for instance. And you have to execute it. And there are some side effects, what you need to do as a provider around this topic of intercept. And you must have your network tappable. That's one thing. But you also have to make it secure if you have to deal with warrants, because it's a high-risk thing. It's about investigating, it's about criminals, etc. So you have to need your security measures. They're in the BBGT directive. What you also need to have is a SIOT connection. And the SIOT is the Dutch word Centraal Opsporingspunt Informatiepunt Opsporing Telecom. So this is the place where all the subscriber data is put from every service provider in the Netherlands in one single database where the investigators, police, intelligence agencies can look at the subscriber data, plus the IP address, telephone numbers, etc. With these security measures also comes that you need an NDA and a code of conduct for the personnel that's involved with these lawful intercept. And you also need to have a security plan and a continuity plan. Also from the privacy directive in the law. And this is how it is in the Netherlands for this taps of the internet traffic. The provider must make the intercept possible. So the provider is doing the work, must have something in place, and then in real time it is sent over to the police, where it's gathered together and then sent to the investigator that needs this traffic. This needs to fulfill the specifications that are mandatory here in the Netherlands. That's published in the Staatscourant, so the governmental newspaper, which standards you need to fulfill. That's the ETSI standard today, the TS 102.232. The standard is divided in several parts, part 1 up to part 7. And the part 1 has to deal with the handover of the warrant and the data. And the other part is how to intercept the specific traffic and how which fields and elements are necessary to hand over. The intercepted data is placed in a payload, and this payload is surrounded with a header, and this header must fulfill with the ETSI standard. And this is a European standard, also used in Australia and New Zealand. We'll come to it later on, why this is important. And in the standard is also room for national implementations. So the Dutch implementation of the ETSI standard is in the ETSI IPNL standard. So not all countries use the same things in the standard. There are options. One option, for instance, is that we in the Netherlands have the payload encrypted. Most countries don't. Well, the first part is talking about 3 handover interfaces. The handover interface 1 is about handling the warrant itself. So this is something that goes from the police to the service provider or the network operator. This can be in 2 ways here. That can be by email. That's for the smaller ISPs, the most used interface. And it can be with something that's called the message broker. And that's something the larger network operators are using. Then we have the HI2 interface. That's the handover of the intercept-related information. So that's the metadata of the intercept. And this is something saying who is connected to who, at what moment, and how long does this connect last. So for telephony calls, these are the CDRs, for instance. And the HI3 is the actual data itself. So the internet traffic, or the phone call, or the email message. The HI2 and the HI3, oh, I see a typo. HI2 and the HI3 interfaces, they are encrypted, the payload, and the header that is surrounded to fulfill for the ETSI standard is an ASN1 header. And also the transport, so the handover itself is encrypted. So it's double encrypted. And it's a good thing, encrypted transport and encrypted data. Something you should always do, by the way. Well, the situation here now, for a long time, we actually tried in 2001 to start a working group for making software in open source. I don't know if anyone here still does know about it. No. There was a working group for open source software for the intercept. Problem here is that it's not a fancy topic to make open source intercept software. So we had a working group, and it died very soon with a couple of meetings, and no one was willing to invest their own time to make this kind of software, and there was no employer willing to contribute. So we ended up in using off-the-shelf software from a couple of vendors, but they are expensive, and very expensive. And what I saw lately was that from the New Zealand network operator group, so it's a group just like we are here now, had to deal with the same thing. If we want to do a lawful intercept, it costs you a lot of money. And the question there was, can we make some software together to solve this issue of the money? In the Netherlands, we did it in another way. But there was the initiative to start making software. It was handed over to the Waikato University, to the WANT research group. And they already had some libraries for dealing with network traffic. So the libtrace library. So they already knew how to deal with network traffic. And well, that's all from the website, by the way, from the openli.nz website. Today there are 13 companies contributing the money to fund this project. And I believe there was also some project money when they started a few years ago. So this software was built, and it's in use in the New Zealand country for the ISPs to fulfill to the lawful intercept requirements over there. It is open source. And what I told you before, in Australia and New Zealand, they also like to use the ETSI standard, European standard. They are more focused on Europe than on the other countries of Asia, I believe. They are also in the Eurovision song contest, etc. So there's some bond with Europe, and they comply to the ETSI standards we use. Here's also the TS 101671. That is the previous standard that was used for the PSTN and ISDN services. But that's now incorporated to the TS 101-232 standard. Just recently, I think in the beginning of this year, the project was handed over from the university, because the university cannot do the support, cannot commit to support for years. So they transfer the support to Searchlight. So the developers of the software are now in a separate company, Searchlight. And they exist from support contracts. So if you like to use the software and use it, well, that's a good thing to have a support contract as well, to make it possible that this software is still developed. They support the part 1, part 3, part 5, part 7 is on the website, but I believe they also support part 6. And they do support VoIP, voice over IP, and I'm not sure in which part it is, but they say 1, 3, 5, 7. And for ISPs, that are all the parts that's needed. So IP traffic, VoIP, and email. The email just recently, by the way. There are 3 elements this software is using. That's the collector, the mediator, and the provisioner. And there's a 4th element. I will come to it later on. But there are 3 key elements in the software. And the collector is the part that is collecting the data, that's filtering, and that's encrypting the data, and then sent over to the mediator. The mediator is receiving the captured data and send it to the law enforcement agency, so to the police in the Netherlands. And the provisioner is providing the configuration to the collector and the mediator. So that's a management function of this infrastructure. And the major work is done by the collector. That makes sense. That is filtering, capturing, encrypting in our situation, and sending. So this is best to have this in the separate hardware. The more data you need to intercept, the more encryption you need to do, the more CPU power you need, network cards, and memory for buffering situations. It depends on the size of your network, what you need for this hardware, but best to do it in separate hardware. The mediator and the provisioner can be on the same system, and that can be done on virtual systems easily. Well, it's built on Linux systems. We run it on Ubuntu, but you can also run it on other Linux flavors. It's built in C. The other PIM taught you about the DPDK, so I don't have to explain. But filtering with DPDK and XTP, hopefully in the future is possible. I've experienced with pre-filtering for intercepts with XTP, and a similar idea that bypassing the kernel and filter directly in the network interface driver, or offload it to the network card. So you don't need the CPU to be involved with filtering. That's possible. So it's possible to have a line rate on 100 gig, for instance. We need to test how far we can go, but it should be possible with pre-filtering. The project's on GitHub, so anybody can download it. Installation is pretty easy. Can you find here? It's using the bash scripts they provide on the GitHub page. And they download the necessary libraries and other packages, and have the package installed for the OpenLI software. And there are 3 components in the script: the collector, the mediator, and the provisioner. So you can choose on which system you install whatever. The software is using a REST API for configuration. The configuration, the initial configuration is in the config files, in YAML files. But all things you can adapt by the REST API. And the REST API elements are exactly the same as in the config file. So if you read the config file, I will show you in a minute. If you read the config file, you exactly know how you can call the REST API calls. There is a web interface nowadays, but I've not used it yet. We're working on this software for a couple of months now to test and to try if it's working here. Never used the web interface, because what's interesting in our situation is that we have an administrative system for handling with the warrants, all kind of warrants, by the way. And then we can make a call to the intercept infrastructure with the REST API, but also monitoring and analyzing what's going on can be done with tools like Prometheus, Grafana, whatever. So we can integrate this whole intercept infrastructure with the normal day-to-day network monitoring and handling procedures. And with the REST API, you can make this possible. Well, I don't know, is it readable? This is a working configuration of in 2 pages of the complete intercept infrastructure, and make it possible to test. On the 3rd page or 4th, I don't know. I will show you how to test this. And if you start with the collector, so that's the intercept system itself, you need to configure what the provisioner is. And then you have an operator ID, that's something that's from the standards. An element ID, so that's the location where this intercept system is placed. If you have multiple systems in one location, then you need an intercept point ID, and then some other configurations that are possible. It's also possible to connect with the RabbitMQ system, and that you can use for buffering in case there's a network glitch. And well, which interface is used for intercepting. Then the mediator configuration is also not very hard to read. Same operator ID, if it's in the same network, of course. The mediator, the configuration of the mediator, which provisioner you like to use, that you need to do. And if you like to store intercepts locally, then you need the PCAP directory, and there's a configuration if you want to send it to the LEA or if you want to store it locally. And also here it's possible to use the RabbitMQ for buffering. And the provisioner is even worse with the configuration. It's very easy to install this. The client address is its own address. The mediator, well, the mediator in this example is on the same system, so it's the same IP address. The update address, I'm not sure. And then the intercept itself, which intercepts need to be installed. And that you can have an intercept in the configuration, but in production it's not very useful because you would like to install intercepts with the REST API interface. And for the REST API, you of course can use the OAuth authentication mechanism. So you need the provider, the REST API key, authorization key, and you can configure this in the provisioner. And the intercepts, you can have multiple types of intercepts, VoIP, IP, email, and several flavors. So you can install the VoIP servers or the email servers in the intercept. And you also need to give the LEA configuration here with the intercept on for which end station do you install this intercept. In the Netherlands we use one gateway for the government, but well, there will be situations in other countries where you have multiple LEAs for different intercepts. So you can configure it here, and you can also configure if the IRI and the content of communication, the data itself, must be on different systems or on the same system. Well, here we use the same system, so the IP addresses and port numbers are the same. And that's it for configuring intercepts. Not very hard. And the REST API, well, you need to create authentication keys, of course. That's here. There's a script for it to do this. And then here's some examples of the REST API calls. If you're used to work with REST APIs, then it should look very familiar. The agency, here's an example for looking which agencies there are. So the LEAs, the LEMF, the monitoring facilities, the tapping chambers, how you call it. But here it's called the agency, and you can look at it, and you can add one. And the outcome of the first call, getting the agency, and the JSON file you need to create a new one is actually exactly the same. So you see an example here on the right of a JSON file. But if you do this first call, you get the same thing on your screen. So the agency ID, the HI2, the HI3 address and port numbers, the keep alive frequency and the weight, that is something that is specified in the national implementation of the ETSI standard. So that is something you get from the government, these two settings. And then you have the put command to put a new agency in. In this case, I've added two addresses, the same address as the local host address. You can see this, I hope. And that you can use, and that's the fourth part, for testing. You can create a local LEA on a system. It can be on the same system as the mediator, but you can also use a different system. So you can use a local LEA with the trace packet dump program. And the trace packet dump can be used for multiple kinds of traffic, but also for the ETSI LI traffic. And that's with ETSI live keyword of the ETSI file keyword. So you can have a stream of traffic, and that's what you set up in this previous example here. And then if there's an intercept, it will be streamed to the localhost port number 41002 or 3. And with the trace packet dump, you can act as a receiver of this traffic and act as if you are a LEA. And then you can output of the trace packet dump you get on the screen. Well, I can save it on file, of course, and then you can see if the flow is what you expect. And it looks a bit like this. It should be underneath each other, but then it doesn't fit. But this is an example of a trace packet dump packet. So it's a header. It always starts with PS PDU, and then a PS header and a payload. And they're with all kind of elements that are part of the header and the payload. You see, for instance, the operator identifier, country, but you also see here the data type on the right. For instance, this is an IRI message, so it's not a payload. And the encrypted payload type is part 1, so this is probably an HR1 something. And you can then follow the trace, what's going on with the intercept, and if it's looking good or not. That's about the OpenLI software. Half a minute left. One page. And does it work? Key question, does it work here in the Netherlands? Because it's a New Zealand software, a piece of software. Yes, it does. We're working for a couple of months on it now, and testing and trying. What was missing, the major part that was missing was the encrypted payload. But they're pretty eager to bring the software to Europe as well. So the encrypted payload is implemented now in the latest version. But what do you need to do to use this software? Well, you need to have a connection with the police. That can be on IXPs here in the Netherlands. And you need to direct peering with the central organization. they need to be able to get the warrants from the police, from INS. That can be by email or by the message broker. But I can tell you the message broker is not an option for most of you. I guess one here perhaps, but the email is with PGP, pretty good privacy for encrypting the warrant. You need to have an operator ID, contact the RDI for this, and then test with the police to make this happen. You have to install the software, of course. One machine if you're a smaller network, and a virtual machine, and this should get you up and running. Questions?
Thank you, Pim. And now, if there are any questions, then be sure to phrase them such that you don't give any information away. Are there any questions? There is one, the infamous Peter Lexis.
Hello. I had a question. You mentioned that the payload encryption happens here in the Netherlands. How is the key communicated? Is it in a warrant, or how does it work?
Very good question. Well, the warrant for intercept is actually a XML file. And the XML file is standardized here in the Netherlands. That's part of the ETSI-NL. It will be part of the ETSI standard itself. And that's something we call the ESUB HI1 interface. I had it on the screen, but I didn't mention it. Here the email, ESUB HI1 interface. That is a standard way of handing over the warrant. So it has a couple of fields in this HI1, in this XML file, and also the warrant itself is embedded as a PDF in this XML file. And in this XML file is also the encryption key for the payload. So handling of this XML file must be very secure. That answers the question? Okay, great.
All right, well, thank you again, Pim. We have a token of our appreciation for you.
Thank you.
Now, every now and then in your life, you meet somebody who is kind of a personal hero. Kiriti Kompella is one of them. About 20 years ago, I had to implement a layer 2 VPN. And at the time, there was this thing called the Draft Martini. And there was this thing called the Draft Kompella. And since I was running Juniper, I thought, let's go with Kompella. Little did I know that 10 years later, I would meet the man for the first time. And now he's here. And he'll be telling us about how that went with Layer 2 VPN. I think he may become good friends with Pim. Where is Pim? Is he still here? Oh, that is a shame. Can somebody get Pim? This is the story for him and for the rest of us as well. Kiriti Kompella.
Hello, everyone. Yes, I'm between you and the quiz, and between you and drinks, so it's a hard one. I have to say I'm really proud that the organizing committee allowed me to do this. I'm also very proud that they are so innovative, because the talk earlier about autism in the tech industry, really important. And this one. So the subjects that you see here, I mean, you get down into the details of the XML file that tells you where the key is, or BGP, BCP38. And I missed a few other talks. But at the same time, you have this wider view of things, so that's really great. I do have a confession to make. This story has a little bit more I in it than I would normally have. Now that I've told you about it, you're going to be very sensitive to it. Hopefully, I'm fair. I don't name anyone else, so I'm not throwing things at anyone anonymously. But I do think I was part of the story, so maybe I'm allowed to do a little eye. Anyway, again, thank you very much for having me here. I was going to call it the origin story, and when I looked that up, it said, you could call it the pourquoi story, the French thingy. And the thing about the pourquoi story is it says about mythology. And I'm like, yeah, there are definitely many myths in here. I don't mean myths like, mythology from thousands of years ago. Myths that are just not true, but I can say them, and you'll find it hard to contradict. The problem with me is I'll contradict them myself, but you'll see that. Okay, so let's get going. When I joined, before I joined Juniper, this is a story of history. I look around and see several young people who weren't even born when I started working at Juniper. So, à peu près. So, I started off in file systems. I was at a small company called ACSC, and there I worked on a file system called Unitree. And Unitree is this file system that basically very hierarchical. And the lowest level of the hierarchy was robotic tapes. So you'd have a caching system, you'd have maybe something in memory, you'd have something on disk, and then you could have a couple of other layers, and the bottom was robotic tape. And if the file that you weren't looking for was there, you'd get the robotic tape to pull it out, and hopefully it was there. So, file system guy. At SGI, I worked on something called XLV, which is part of the XFS file system. So that was a really nice project. Even better, I joined NetApp, and NetApp had this homegrown system called Waffle, built on their homegrown microkernel. Really exciting stuff. Waffle was so well optimized for NFS. I had a great time there. But I only worked there a year. Then someone in NetApp said, why don't you go check out this little company called Juniper? So I said, okay, fine, let me go see what they have to say. Went and talked, did an interview. I had no background in networking, no background in chip making, because chip making was a big part of it. But they said, yeah, you seem like an okay guy. Why don't you come on board? So when I did come on board, I was reporting to Paul Traynor. I don't know how many of you know Paul Traynor. So he was sort of informally the lead of the software group. And he looks at me and he says, what do you want to do? And I say, I want to do routing protocols. I've just come to a networking company. And he says, yeah, that's a good answer, but you don't have any background. So let me put you in something that we need and that you seem to have knowledge about. Work on the device drivers for our interfaces. We're doing them in a very different way. The base code was FreeBSD. So it says, why don't you work on configuring device drivers? So for those of you who know some Junos, we have these notions of an IFD, an interface, the device, the physical interface, an IFL, a logical interface, an IFF, an interface family, IFA, the addresses, and then next hops and routes. So I said, we need to configure these. Typically, in FreeBSD in those days, you didn't have the notion of IFLs. So basically, I said, go work on this. So I said, okay, it's a place to start. I get to know the system. The first day I show up, and there's a picture of a hammer and a screwdriver there on purpose. It sort of means that I was working on the infrastructure. But literally, the first day I show up, it takes me to this room. There's a table. There's 7 or 8 desktop PCs on it. There's 8 Ethernet PCI cards. You guys don't know what that is, but there were such things. And he says, we need to put one of those in each of these. And I said, what? We're going to build a small network here. The only network we can build is Ethernet. And of course, these don't have Don't even talk about wireless. They don't even have physical Ethernet until you put them in the PCI cards. So that was my first task. I said, whoa, where did I end up? So the point for me was I had to learn from scratch. What is PPP? What is Cisco SDLC? Where does this fit into this whole thing? Oh, so you have a packet, you have a header, you have the body of the packet, you have overhead that may not even be part of the packet. You have these things called keep alives. So I had to write the drivers for PPP, Cisco SDLC, configuration pieces, figure out how hellos work. For frame relay, there's the ANSI standard, and there's Gang of 4. I don't know how many of you know Gang of 4. It's like, keep that a secret. So, I learned a lot of stuff down there in the bowels of the machine, understanding how these device drivers need to work, because this is how the protocols, the layer 2 protocols, work. Frame relay and ATM added sub-interfaces, real sub-interfaces. And then I moved on to doing route tables and next hops. As I said, what I really wanted to do was work on routing protocols. The next task I got into the routing protocol space. We had a big customer, UUNet, who's today part of Verizon, AS701, 702, not in Europe, yes, 701 in the US. So they were very eager to use our stuff, but they said, hey, we need traffic engineering. So we were focused on building IP-based routing, and Paul Traina and Tony Lee were pushing for MPLS, and then this became a really good reason to do it. If we do MPLS, we can do traffic engineering. Basically, Mike Odell said, we need to be able to do things like tell the router, I want to connect A to B, here are my constraints, make it so, right? So we said, okay, we'll do that. To do that, we had to have TE requirements, and then what does it mean? What are the type of constraints you have? And then we needed extensions in ISIS, which Tony worked on. We needed to implement RSVP-TE, which a guy called Durwa Gan worked on. And then we needed a traffic engineering database where everything from ISIS was put. And then we needed an algorithm that would compute paths across networks, satisfying these constraints. And that's what I worked on, the CSPF piece. And then we had to have this all work together, because initially, when you create an RSVP-T LSP, you said, here are all the hops you go through. Then we said, okay, you create the RSVP-T LSP, you say that the hops will be computed by CSPF, you give the constraints, CSPF does the computation and brings it back here. So the second big project I worked on was traffic engineering. I mean, I had a piece of it, right? And this was my first exposure to the routing protocol daemon code. I'm going to skip this, I'll come back to that. So we're going to go on a memory ride. Back in the mid 1990s, the internet was coming up, but service providers were primarily building voice networks, and then they were making the voice networks bigger and bigger. And they said, how do we do this? We can just use SONET and or SDH, and we'll channelize it down to DS zeros, and everyone will have voice. And someone said, but there's this thing called IP. There's this packet-based stuff that's sort of getting interesting. Like, we'll find some way. So there's this big challenge of how do I build a network, the core of my network, which will carry packets as well as bits. And so they said, some people said, just do it over SONET, packet over SONET. And some people said, no, you got to do it over ATM. ATM gives you really good quals. ATM gives you traffic engineering. ATM lets you do multiple things. That's the way to do it. So UUNet bought into that, and they built an ATM-based network because, again, they were very much into traffic engineering. And when they started looking at all that, they said, okay, there is traffic engineering, yes, but what we really want to carry is IP, and IP over ATM really sucks. The n-squared problem of trying to create adjacencies here was one. The 40-byte packet, which is a very common packet size in IP, became 2 ATM cells because of AL5. There were all kinds of silly problems. ATM had its own protocols, which didn't at all work with IP. So they said, we need an alternative. So they started looking at this thing. What if I had an infrastructure that would carry anything? And so we'll just do packet over SONET. But I will impose onto this traffic engineering. On the edge, my customers still come to me and say, I want frame relay, I want ATM, I have a PBX that needs ATM connections. And I'll say, yeah, bring whatever you want, but my core is going to be packet-oriented. How do you do this? And by the way, this was a separate fight. Do I build an ATM core, or do I build a SONET, a packet over SONET core, right? At this point, IP was just coming and MPLS was not really in the picture. But if you want to come down to this picture, you had to bring traffic engineering here, and you had to bring the ability to carry all these different media. So if I have PPP, frame relay, or even Ethernet, which was coming up as something you might want to use across the WAN. So that's where people said, can we have a technology that excuse me, take any other layer 2 technology and put it over my core? So can I build one core that will carry everything? And they said, this is what MPLS was for. MPLS, the MP is multi-protocol. And typically you think of it as multi-protocol at the time over whatever. So I can carry it over PPP, I can carry it over Ethernet, I can carry it over ATM. But it's actually multi-protocol above as well, where you can say, I can carry anything over this. But we had to prove that. So the question that came to me is, can you carry PPP over an MPLS network? Can you carry ATM over an MPLS network? Can you generalize this and carry any layer 2 and cap over this? So I said, yeah, this should be possible. I had to do some more reading, consult with other people who knew the stuff, Tony. And I said, yeah, we should be able to do this. We also invented something called translational cross-connect that said, if the layer 3 is specifically IP, whether it comes in on PPP here and wants to go out on frame relay there, can you do this? It's like, yeah, we'll just extract the IP part and put it here. In the middle will be whatever we need, some MPLS thing. So basically, I had worked on layer 2 and caps and had to really understand layer 2 and caps. I had to work on traffic engineering, and then I was given this task of running layer 2 over an MPLS network. This is a part of the myth that this was not something that was meant to be. It just happened, right? But I was in a unique place where I could implement this stuff. I knew RSVP TE from the inside. I knew TE from the inside. I knew layer 2 protocols or layer 2 encapsulations better than someone who might have come in with a networking background. I came in with nothing, so I had to learn everything. So I was given the CCC project. And I did everything in the CCC project, from the CLI, the Juno CLI that will allow you to create a connection, down to interacting with RPD, interacting with DCD, which is the device control daemon, going to the kernel, going to the microkernel, down to the chip. So we had these chips. It was very ingeniously named A, B, C, D. And the B chip was the input-output chip. And so it had a BI component and a BO component. And BI microcode would parse incoming packets, and BO,
could you say that
BO microcode. That's, if Siri had been around then, she'd have told me exactly how to write all this. So the BO microcode would write the output, the rewrites for the packet. So this was done. I mean, at that time we were working from work. We had just come to work. But I just wanted this focus time. So I worked from home and nothing to do with COVID, just work from home. I wanted to focus on this. I would work from 8 p.m. to 5 a.m. This is a part of another myth, because when I asked my wife about this, she says, what? In theory, I'm working from 8 p.m. to 5 a.m., writing code, 1 ear open for the baby. If the baby cries, go give her milk or change the diapers or whatever, then go back to work. She said, yeah, you might have done that twice. But like I said, nobody can prove or disprove this. What was really cool, though, is back then, I was actually a useful member of humanity. Today, I don't know. But got this project done, and that helped a lot. And this project was almost immediately deployed. People wanted this. But as we got into that, we saw that there were some issues here. If I really want to use layer 2 over MPLS, if I want to do it with CCC, I have the issue that if I have n endpoints to connect, I need n squared connections. And all of these connections are done manually. And that's a pain and prone to error. If I do create these connections, nothing in the connection says the connection from A to B and the connection from C to D belong to the same customer. They're related. And if one of them doesn't work, the customer might not be happy. So they're just independent connections. And it's like, okay, that's fine, but it's not fine if you're saying they're all connections for one customer. The last thing is you can create any topology you want, but you're doing it manually. So again, you're trying to create a dual hub and spoke topology, and you miss something, you've messed it up. Or you're trying to create a full mesh, and you've missed one connection, and it's not a full mesh. And those things are really hard to debug, because mostly it's working, but one guy can't talk to one guy. So one solution was, let's do this single-sided provisioning. In other words, I want to create a connection from A to B. The way that works today, the way that it worked in the beginning, is you create an RSVP LSP from A to B and from B to A, and then you create a connection from A to B saying, take this input interface and stitch it into this RSVP LSP. You go to B and you say, I need you to do the same at that end. And when you're done, you've connected this ATM interface on the edge to this RSVP LSP in the core. Yeah, it helps a little, but I mean, you got an n squared problem and you divide it by a factor of 2. Not enough, not really enough. And you still have the problem that you're not really connecting all these together with one unifying concept. So I said, okay, let's go to a different mode. Let's use this technology called BGP layer 3 VPNs. I used 2547 there because that's where my mind was at. Now it's 4364. But basically, this had a completely different approach. It said, you've got n endpoints. You go to one of them and say, you are a part of this VPN. Go find your friends and make all the connections you need. You go to the second one and say, oh, you're also part of this VPN. Go find your friends, and so on and so on. So to configure n endpoints in a VPN, you configure n independent things. There's no n squared, there's no, I need to do these two together in one shot. They're just independent. And that was a really, really cool idea. And I said, that's exactly what I need to be able to create my layer 2 VPN. Plus, this whole thing will be called one VPN. Back in the day, we'd call these VRFs. And so we'd say, this is a VRF for Acme Corporation. Now you'd say, this is a layer 2 VRF or layer 2 VPN for Acme Corporation. So you have a notion of all these things that are going to come up belong to one customer. If any one of them goes wrong, that customer is the one that's going to see some trouble. So there's that relationship, that idea that you have related connections is embedded in the concept of doing it as a VPN. And the last thing is you get this unified approach to making VPNs. So however you build your layer 2 VPNs, your layer 3 VPNs, VPLS, if you use similar concepts, then you train your staff accordingly. You build a set of rules of how you make them, how you build them, how you manage them, how you debug them. And so many of the concepts can be shared, so it actually becomes much easier. But if you do your layer 3 VPNs using BGP and your layer 2 VPNs using LDP, and then you maybe you use some auto discovery, which by the way never actually got deployed. It's completely different, and it's not, you get no leverage in your operations. Yeah, so one of the things that happens in this is, in BGP, BGP layer 3 VPNs, when I advertise that I have a route or even an endpoint for a VPN in some layer 3 VPN, I hand you one label, and everyone uses that label to talk to me, and I know who to send it to. That's how layer 3 works. In layer 2, I have to hand you n-1 labels because there are so many circuits behind me, and I need to know which circuit to put this traffic on. So I can't just say, here's one label. I have to give you a set of labels. So I came up with this idea of a label block. So I've got 10 connections behind me, 10 VCIs, or 10 VLANs. I'm going to send out a block of 10 labels. So one advertisement, 10 labels, and I'll give you a way to know which label to use for which of these VCIs. So that was a concept of a label block. I need different topologies. I need full mesh, I need hub and spoke, I need dual hub and spoke. Well, this was solved by 2547 by using route targets. So I said, oh, I'll just use that technology. Okay, this is all going very well. Should we standardize this? This is when the roof fell on my head. And there was absolute opposition to standardizing this. So fine, we made it an informational document, which basically means here's some information, you don't need to read it. That's an IETF informational document means, yeah, just leave it there. If there's a standard stack, you need to really dig into it, figure out how to implement it, figure out how to do stuff with it. Then people said, okay, that's all good, and yes, there's a point-to-point layer 2 circuits were nice, but we want VPLS, we want transparent LAN service. So again, people said, oh, you can signal that with LDP, but here people really understood that I can't just make them point by point, pair by pair. A transparent LAN service is N things working together as a LAN. I came back and said, I can do this with a BGP. I have discovery. I have the notion of a single VPN. All of these fit together. We have the topology that you need, full mesh. So finally, they said, okay, that one we will standardize. So BGP VPLS was the first one that was standardized as, okay, we need this. It makes sense to do it. But I couldn't even put a normative reference to the BGP L2 VPN because that was informational. So the way references work, you can only put a normative reference from a standard stack document to a standard stack document. So it had to be an informative reference. But maybe someone read that at that point. So, of course, there were a bunch of people saying, nah, this is really bad, you shouldn't do this. The biggest complaint was, BGP is for layer 3 information. You can't use BGP for layer 2. Actually, the truth is, there was no layer 2 information across this signaling, except what is the type of layer 2. There was configuration information. There's something that said there are 10 circuits there that need connection. There was information about what are the endpoints. There's the route targets that will create the topology. But there's no actual MAC addresses, VCIs, VLANs, nothing. today, we have MAC addresses at, in their full glory in EVPN, carried over BGP. So somehow today it's okay. We also have layer 4 information that came later, BGP flow spec. So the idea that BGP should only be used for layer 3 and should only carry IP addresses is something that was, it was true at the time, but we had multi-protocol BGP, but that was used as a stick to say, no, stay where you are, don't come out of your hole. One real problem was you couldn't do per connection QoS, but actually in the end, not that many people needed it. Another was BGP is too complicated. This is one of those scary things where they try to scare you into not using a technology, and it worked. And then it's the same old arguments repeated. It is actually a bit of a stretch to try to use BGP for layer 2. The funny thing is, I can tell you this now, I could have told you this back then. None of the people who are arguing against BGP brought this up. Layer 2. Layer 2 is source destination oriented or circuit oriented. Layer 3 is, I don't care where you came from, you arrived here, I look at your destination and I'll send you on. I don't need to keep any sense of where you came from. Whereas for layer 2 stuff, you do need to know where it came from. So that is what led to having label blocks and so on. It's primarily a data plane problem, but there is some aspect in the control plane that's needed. So, but here is something that someone could have said, hey, there's a bit of a mismatch. No one did, and now we don't care because we're using this in EVPN. So what that left the world with is I could use LDP, and I'm leaving out things like L2TP, L2TP-v3. So I can use LDP to create this connection across my network, tell each PE out of band who he should connect to for the connection. I can use LDP for peer-to-peer signaling and BGP for auto-discovery. I think that was a pretty complex solution, but in the end, it was never really deployed. Or I can use BGP for the whole thing. And if I did that, then I'd have to use label blocks and a few other things. But that was a solution that a few people did converge on. AT&T in particular really liked the idea of using BGP for L2 VPNs and VPLS. Well, from here, people went on to things like BGP auto-discovery, which I just mentioned. So they call this VPWS. BGP VPWS was auto-discovery and signaling. So even though this was an informational document, people said, well, now that people are deploying BGP for layer 2 stuff, why don't we do it for our even our point-to-point VPNs? So the same technology was used for VPLS. BGP auto-discovery and signaling is used for EVPN. But here, you're actually carrying IP addresses and MAC addresses in the control plane. So it's no longer that BGP is carrying control information, and the data plane does its own thing by doing MAC learning. You actually carry the addresses in BGP. So much for BGP must not be used for carrying layer 2. So people ask me, do you feel vindicated? And it's like, no, it's the wrong question, right? It's the nature of how we have discussions in, technical discussions, primarily in standards bodies, but I mean, you could have them offline as well. You want diversity in thinking. You want people coming up with crazy new ideas. And then you want to have a technical discussion of, is this going to work or not? And to do that, you have to be able to prototype and say, yeah, this actually could work, or wait, there are these issues, and then maybe you solve the issues, maybe not. And then you want to compare that with another solution, as much as you can, apples to apples. But dogmatic adherence to your ideas, and maybe that adherence comes because it's my company or some political reason. Someone earlier was talking about the layer 9, layer 8 and layer 9 of the network. Those are not good reasons for doing this. So the industry wasted effort, they wasted time, and they'll do it again, and they're doing it right now. At a conference, just as a side story, a speaker who was peddling the idea of Rosen-style multicast VPNs, layer 3 VPNs, they at the time wanted to carry customer multicast addresses in PIM, not in BGP. So the theory was PIM was meant to carry multicast routes. BGP was not. So he made this blanket statement that BGP was not meant to do this. Yakov Rector comes up to the mic. You can see this guy trembling. This is the speaker. And Yakov Rector says, do you know what BGP was invented for? What was it designed for? No. BGP was meant to carry 4,000 IPv4 classful addresses. That was it. That's the first 3-napkin diagram. Okay. Since then, we've added classless, CIDR. We've added multi-protocol. We've added V6. We've added VRFs. We've added a whole bunch of things. Who are you to talk about what BGP was designed for and not? And that guy just, right? But next conference, same presentation. Like, why are we here? What's the point? So I'm only going to explain one of all these pictures that I've added to my presentation. Who recognizes this picture here? The painting. Oh my God. It's by Van Gogh. It's called Angelus. It's actually a copy of Millet's Angelus. And it's basically two farmers at the end of the day pausing to say, thank you for the day. I'm not religious. I'm not about to become religious. But I think we need more of this, that you just, at the end of the day, you step back and say, it was a good day. Not every day, but it was a good day. I'm here, I'm alive. We'll go on tomorrow. But yeah, we don't do that. We just do stupid things, we repeat them, and then we come back with bigger guns. What's next? So the chapter on layer 2 VPNs is coming to a close. Actually, most of layer 2s are going away. In many networks, they only have Ethernet. And so the only layer 2 technology, even on the customer side, is Ethernet. So the focus is on EVPN, which is BGP-based, so there's no fight there. But in general, there's a clear move to IP. So, I think we will have EVPN for a while. In fact, we'll have layer 2 VPN of different kinds for a while too. Once things are in the ground, they stay in the ground for a while. VPNs themselves are changing. So a lot of people are now talking about do-it-yourself VPNs, AKA SD-WAN. MPLS is changing, not always for the better. I'll leave it at that. Much more is being done with BGP. I think it's a good thing. BGP-LS, I am a little ambiguous about, but BGP flow spec and BGP EVPN, BGP for anything you want. There's this idea that you carry JSON over BGP. Yeah, sure. Why not? But in general, this chapter is kind of coming to an end. And I have moved on. I'm now working in the management plane. So if you think about what's happening in the router, you have a data plane, a control plane, and a management plane. Well, the management plane is also, the Uber thing, the SDN layer, the whatever you want to call it. And I used to be very much against that, but I can see the value, and I know that there's some things that are better done centrally, and there's still many things that should be done in a distributed fashion. So one of the things that I'd written somewhere, but I forgot to say is, or maybe it's in the next slide, yeah. When you have these kinds of situations, when you're really passionate about something, which is good, passion is important, but then you get all this pushback and you get these people telling you different things, you need to know who you can trust from the point of view of, is this technology good? Is this idea good? Are we going in the right direction? You need to do your homework. Have I looked at all the aspects of the problem? Have I prototyped whatever bits I could prototype of the problem? At some level, you just need to trust your own instinct. And this is, again, where your teachers and your homework builds up your confidence that you are on the right track. You do have to be stubborn. There is an aspect of this that you have to stick to your guns, but you have to listen. And I will say that there's some very smart guys I've talked to who just can't listen. In a way, the more strident they're shouting, the more you should say, I must have something good here, otherwise they wouldn't be fighting so much. Which is a bit negative, or I don't know, but. And then, once done, move on. I mean, you may have a little more things to do there, but get it done, move on, leave all the emotions behind, get to your next thing, because there's a lot more stuff. Very easy to say, very hard to do in the spur of the moment. You've also invested so much in it, but it's very important for your own psychological health. I'll leave you with this. This is a patent that was filed, we applied for in 2001. It issued in 2006. It is now expired, so feel free to implement. We never asked anyone for money on this. You will see some keywords here. Virtual network, local intervention, which is basically I'm going to provision each device by itself, not in pairs, not the whole thing together, but each device by itself. Label base and label range, which is needed for the label block stuff. Yeah, so that was it.
Maybe you have an opportunity to answer one or two questions, if there are any.
Out of time.
We do. Well.
Okay, I will.
Okay, well, then let's
tired.
pose them. Come on. Who has a question for Mr. Compella? I do find it interesting myself that on this day where on a typical day, there are about 3 companies calling our office asking us to implement an EVPN VXLAN network. But on this NLNOG day, the 2 longest presentations were about MPLS. It's interesting. Yes. Ben, you have a question for Mr. Compella.
Mostly in jest, but you mentioned a whole bunch of interesting address families over the course of the time. What do you think's next? What could you mentioned JSON? I think that would be a great addition. Why not just provision signaling? DHCP. I reckon there's some interesting innovation that can be done here.
So the mention was in jest. The original request, when I heard about it, was not in jest, but the people who repeated to me were also joking. So I don't expect that to happen right away. But I think the idea that BGP is a protocol that allows you to distribute information. Today, we mostly use it for routing, but then we could use it for the link state. We can use it for flow spec. I mean, for flow spec, it's really interesting. I'm not going to send you a route, but I'm going to send you a filter that you can apply so that traffic doesn't get into the network. Right. So if you find things that you can use BGP for in the places that BGP is deployed, I think BGP is general enough to do that. I think we have to be very careful that if you break BGP, you break a lot of things. So one thing that you might do is to say, I'll clone BGP, run it on a different port, not 170, but whatever the next port is. And say, but I'll use the same mechanisms. And I think that would be a very powerful thing. And that would be a way to play with BGP. And then you could do things, back in the day, we talked about exchanging information between providers on what the cost of carrying certain traffic across my network would be, or for a certain latency or whatever. Brokerage, right? Bandwidth brokerage. You could use BGP for that. But you don't want to use BGP for that. You could say, I have a protocol that scales nicely, that is very general purpose. I think that idea that what you want, these are the characteristics, these are my requirements, and what the protocol offers, if they don't match well and then you try to like hammer it in, that's not great. But when it does match well, yes, do it. But JSON was tongue-in-cheek.
I mean, the cat's out the bag the moment FlowSpec was mentioned, right? Because it's not really a root at all anymore.
Should I expect a draft from you?
Don't dare me.
Mr. Van Pelt.
So sorry that the talk went long. Let it go. Thanks for the talk. This was great. I work on VPP. I use Bird. It doesn't do LDP. Can I call you sometime to get BGP signaling done in VPP? That'd be pretty great.
Cool.
Great. Thanks.
Yeah.
Kirita Kopela, everyone. Thank you. And unknowingly, Ben gave me the link to the last section because there is a cat that is out of the bag. Actually, our last part of the day is going to be the quiz. And why is the cat so important? Because one of the prizes is a cat. It's not in a bag. It's in a box because it's a robo-cat. And it could be yours.
The fuck is dit?
If you
That's a MacBait, hè?
win the quiz. There is also a very nice tool to make your rack installations a bit easier. No, it's much more elaborate than a hammer. And I can tell you one other prize is a set to hack your credit cards and stuff. It's also very good, very nice, very good prize. And there is a main prize, and if you win that, I hope that you are here with a car, because otherwise you have an issue. Now, last year, last year, you may remember that the quiz was a little bit strange in that the correct answer to all questions was yellow, I believe.
Yes, but that was not our fault. That was
well, I've been assured that this year is going to be totally different.
Who told you that? We didn't.
Oh, okay. Oh, I thought that this year it would be red.
Maybe.
Oh, okay.
I mean,
right.
How much did you pay us for that?
There has been a lot of thinking and preparation for this quiz. So
it was multiple days.
A lot. That's a lot. Multiple is a lot.
So, actually, who hasn't done the quiz with us before? All right, I see one person, 2, 3. Okay, just a couple of them. Perfect. So we're using Kahoot. Grab the app, because I heard it's faster, and being fast gives you more points. So the way this works, for those who don't know, we will ask the question. You get 20 seconds to answer it on your phone, or if you want, on your laptop. And the faster you answer, and answer correctly, you get more points. Whoever has the most points at the end gets the prize. So it's super simple. In theory, the questions are probably hard. We have some weird networking questions, we have some non-networking questions, and we have some very non-networking questions. And I believe we don't have any on DNS this year.
Aww.
Just be very nice to you guys this time. Yeah, you ready?
Maybe.
Uh-oh. Yay, there we are. All right, yes, so open up your apps. Either scan the QR code or give in the game pin. And once we think we have enough players, we're just going to start and see where this ends.
How many is enough? Like 5?
Yeah, let's do it now. It's fine. Oh, I forgot about this music.
I did not.
This is your sleep music, right? You just turn it up every night and then just go to sleep.
My wife told me not to.
After how long?
Like a minute.
Oh, that's pretty fast.
Yeah. How many people do we have here? Like 150? Okay.
Oh, for those who are on the stream, you can try to participate. However, you're not eligible for any prizes, and there's probably enough delay for you to never get enough points anyway. But feel free.
You could just mash a random color really quickly, though.
If it's red, it might actually work.
Yeah. Or, you know, not red. Ooh, Unicode.
Is it though, or is it just the mark?
I don't know. Will's rainbow worked fine. Is anybody having trouble joining?
Whatever your browser does, maybe, I think.
Well, this is
I
a
don't
Mac,
know.
so...
Oh, so new? 15? I don't know.
Anybody having trouble? No?
No? So, I'm seeing a lot of names again and again. All right. Let's just go for it.
Yes.
Okay. So, is somebody not ready? Speak now. Oh, I see one hand up. Yes. We're all looking at you now. Don't worry. No pressure. No pressure at all. Over there, the person who was fidgeting with the phone. Glasses up. That means it's this is the hard part. Or just a very hard name to spell. I don't know. The dame. No pressure at all.
Should have done that at home.
But if you didn't know...
I haven't read them.
I don't think I ever read them as well. I just got roped into doing this.
This is true. Because I asked you and you said yes.
Yes.
Okay.
Yeah, that's usually how this happens.
Yeah.
All right. I hear the music again, so I guess it's just time to go because these people are thirsty and hungry.
We are getting started. We are doing 15 questions. They are in random order, so we don't know what's coming next.
Oh, really?
Yes.
Oh, cool.
Well, apparently we are at work. Not even sure what's happening next.
No. Quiz.
Okay, good. What part of IPv6 space is allocated as global unicast? An easy one to start with.
Maybe.
For the audience, maybe not for you.
No, I don't know. I mean, none of these answers look right to me. There are no dots in there.
Yes. Actually, there are lots of dots in there.
Oh, those are colons.
Yes, which are 2 dots.
Ah. That's actually really bad. Well done.
I am surprised.
Yes.
All right. Well, off to a good start. All right. Question 2.
It's a multi-select one. Which are valid address families in the Linux kernel? There are multiple good answers.
You wrote this question.
I wrote this question, yes. I just looked at the source code and picked a few. do you know the answers?
I'm not sure I memorized this one, no.
Perfect. All right, that's about a 50-50 split.
Yeah.
So how many of you guessed? Hands up.
Yeah, that tracks.
Yeah,
that
perfect.
tracks.
All right, let's see who guessed correctly and quickly.
On to question. Oh.
Oh,
Teun.
Teun.
Yes, the real quiz starts now. All right, question 3.
What's the frequency of the quartz crystal in quartz watches?
Peter convinced me there's only a single answer to this. I hope he's right.
I mean, in like 99.9% of the cases, it's a single answer.
Well, that's good enough.
Works for me. Let's see if everybody's guessing.
I would be guessing. They were guessing.
They were guessing. Correct, though, for at least the most of them.
Yeah, not too bad.
Let's see if Teun did it well. Oh. He just fell off the screen.
Teun. Question 4. Arrays start at where? I'm really happy with this picture I found.
That's really nice. It would even be better if you had the picture with like the buttons all randomly arranged.
Yes.
Like a psychopath.
Yes, but that one wasn't to get these images.
Oh, yeah, this one's free.
Yes, this image is free.
And doesn't need attribution.
Also true. You all got it right. Congratulations. This was a freebie. I hope you were quick.
Oh, did we have streak bonuses again?
I think we have streaks, but no streak bonuses. Also wonder who R is. Oh, RST. Okay. All right. Well done.
Next one.
Question number 5.
What is the ether type for frames carrying IPv6 packets?
Rinse spoiled this in his presentation 3 months ago.
Also, the bytes are in the correct order for the network.
They are in network order, yes.
So
Which is not the order they go over the wire.
No. Because why would you?
Yes.
Are you seriously network engineers? Well, okay. Continue onward.
Yeah.
Ooh.
Are these questions too hard?
I
or is it the children that are wrong? Question number 6.
What does VPP stand for? Another freebie. Let's go.
This one's for you, Pim. I have to say, some of Pim's slides really did look quite volumetric.
It's true. And he also discussed VLANs.
Yeah.
Not VXLAN.
Yes.
Yes. Well done.
So proud. Well done. Next question. Ooh. So who is RST? Nice work.
Nice.
Question 7.
What's the required distance between the vampire taps in 10^5? As some of you are old school, you should know this. Wow.
Now explain it.
Yeah, so apparently it has to do with the wavelength of the signal, that it doesn't intersect or something. I don't know. It was an interesting read, and then I forgot all about it.
Just like everybody here.
Yes. Has anybody actually used 10^5 ever? I see. Yes, gray hair, gray hair. Will. Oh. I don't know. Well,
Yes.
yes.
Well done. Question number 8. How many words are in the title of BCP 38? I'll give you a hint. I couldn't let you pick between possible titles because they wouldn't fit.
So 3 very long words?
No.
Oh. I mean, if the RFCs were German, you probably could have done it.
Yes, or Dutch. Finnish.
Or Finnish.
No, it is a really long title. I didn't memorize it, but it has 14 words.
And people guessed really hard, even though we've discussed this BCP today.
Yeah.
Oh.
I think yours is coming up. This will be exciting.
Very good.
Question number 9.
Which of these comics is French?
Aren't they all?
Yes, they are francophone, as they call it. But not all of them are from France.
Okay.
The country of the baguette.
En de omelette fromage. En de croissant.
And the tourne. Oh, very
Nice,
good.
nice.
Very good. So the rest of them are Belgium.
That's a trick question. That's mean.
No, it's not. It is a semantically correct question, which is maybe the best kind of correct. after
Otto's
technically
coming up to
correct.
3. So how many prizes were there?
I heard 3 or 4.
Okay, nice.
I hear 4. So,
Okay.
Klerk, get on it.
Yeah. Question number 10. What is the MBR partition type for an EFI system partition?
Only 4 choices, and it's only 1 byte each.
The GPT version is actually full UUID. So
this is easy.
Yeah.
I actually don't know.
Oh, not bad. These people boot.
Yeah.
Not
I
bad.
just suspend. Sorry.
We could just stop. This is clear.
No,
No,
how many
that-
questions do we have? I think we have 3 questions left. So
Something like that, yes.
Anything can happen.
Question 11.
Which non-obsolete RFC has the most verified errata?
I think you found there was an API you could query.
No, well, yeah, kinda. There's this Python project that allows you to download all the RFC errata in JSON format.
Right.
And then a little bit of shell magic will give you answers.
Yeah.
Except it's
such dedication.
I know. It was hard.
Yeah.
Oh. No, it's the open PGP message format with 53 verified erratas, and the rest of them have fewer.
So is it like a bad document?
I don't know. It's about open PGP.
Fair. Fair. All right. Okay, interesting. Let's see what happens next.
Which of these countries does not yet host an NLNOG ring node?
If this changed in the last 2 days, pretend it's 2 days ago. But
Yes.
I don't think it did.
I don't think it did.
Tony confirms.
I actually forgot the answer. Oh no, wait, I know.
I know which country came in as the latest one.
Yes. That's the joke.
Yeah, because there was Guam.
Yeah.
But the answer here is
It's
Malaysia. Which is almost the one picked fewest.
Yes. There's this nice map on the NLNOG rings website. Just look at it next time, because maybe there'll be another question about this. Oh.
He's over there.
They can face off now.
Yes.
All right.
3 more questions. What horse feed is marketed as a wonderful warm treat? I actually wrote this question 4 or 5 years ago.
Does it still exist, this brand?
Yes, but they changed the slogan.
To?
A wonderful one treat. It used to be a delicious one treat.
Okay.
I'm not making any of this up.
Did you try it?
I have once fed it to a horse.
Doesn't count.
Okay. Nice.
Very good. It was yellow. That's
Oh.
why it went right.
Shit, have they all been yellow?
No.
I think some of them were red.
Yeah.
Okay, good. Okay, few more questions left.
Ooh.
What if yours actually wants the second prize?
Well, then he has to I
Vote
don't know,
strategically.
yeah, slower.
Yeah.
2 more questions. Let's go.
Yes.
In music theory, what chord consists of notes D, G, and A in that order?
I heard somebody say I know that.
Did they mean I know that, or I should have known this? My piano teacher is now going to be very disappointed in me.
You have a piano teacher?
No.
Oh.
No, I'm terrible with music, which is fine.
That's
the answer is in the order.
So why would you pick Among Us? Because it was yellow? Wow. Well, at least we're having fun.
All right, last question.
That is the last question.
No, one more.
Do you remember what it was?
No.
Me neither.
Cool.
All right. Well, it
All right.
all comes down to this.
A few things can happen still, yeah. Which of these is not a character encoding?
Oh, we're sorry.
I actually didn't know about many of them before I saw this question.
I found 2 errors on Wikipedia researching this. It was terrible.
Did you fix it?
No. I'm gonna do that tomorrow.
Well done.
Patchkey is the Commodore 64 character set. So this is slightly surprising.
So what is ISKI?
Indian.
Ah.
And BSKI doesn't exist.
No, because it's ASCII with a little bit extra.
Yes. Sounds like extended ASCII, which also doesn't exist.
Bad ASCII.
Yeah. And of course, EBCDIC is the IBM mainframe thing. All right. For the final score, a podium. Number 3, Molly Miller.
Very good.
Number 2,
Joris, the second prize.
Come over there.
I
And
think it's
number
going to be
1,
RST. Yes.
RST.
Well, come on up and claim your prize.
4 prijzen?
Yeah, we also need to download an Excel sheet now, I think, because we also need to know who the 4th.
Otto. It popped up briefly, number 4 and 5.
Okay. You see, I was too easy.
That was too easy. Well, we don't get that a lot.
No. Number 4 is Otto over there.
Number 4 is Otto.
Well done.
Otto has received a setup.exe. I hope it runs on OpenBSD.
Maybe it does.
Congratulations. Number 3, Molly Miller. It's coming up. It's for you.
A set of tools, I think.
Yes.
Anything but a hammer, I heard.
Okay. Number 2, Joris.
It's a box.
It's a box. Congratulations.
It probably has a box.
Have a lot of fun with your box.
And I believe there's a cat for RST.
Good luck getting that home.
Yeah.
What is it?
Yes, show us.
It's an actual live cat.
It says Lego. I like it.
Oh. It's not a box.
Well, if you want to know, it's the 75192.
The Millennium Falcon.
Millennium Falcon.
The big one. The big one. Congratulations. Thank you all for playing.
All right, congratulations. And everybody, thank you for participating.
We won something.
Oh, nice. Dankjewel.
Dankjewel.
All right, let's hand it back to Niels for
Yes.
the closing ceremony.
Thank you. All right, well, indeed, that brings us to a close. It's amazing how fast this day went by, for me at least. There are, before I give the floor back to Natalie, there are a couple of things I would like to mention. When we leave this room, then there is always the nice task for the board to make the room a little bit clean. This is one of the perks of being on the board, so if you like to clean rooms, then please come on the NLNOG board. Alternatively, please, when you leave, look around, take empty cups with you and throw them in the bin. I was also told by the streaming staff, Sven and Denise, and I think that we may want to applaud for them, because I think they did a perfect job today. That the videos should appear on YouTube by Friday. And that those will be the loose videos of each presentation, because obviously now we had the live stream. Natalie, you tried to show me what I forgot, but you can also say it yourself. Take it away.
Okay, thanks, Niels. Yes, first of all, I would like to thank all you for joining us today. And also our speakers. I really had a good time. I thought the program was excellent, but I'm biased. But because we made the program, but we're super happy with everybody who sent us thoughts for presentations, suggestions, submitted stuff. So thanks a lot for that. Also the people watching remote, I heard we at one point had more than 200 people watching remote, which is super high for remote participation. And what else? Yes, goodie bags. If you want one, bring it home with you, because we are going to clean up, and we will either bring all the goodie bags that are behind with us, but you won't be able to get it back if you go downstairs and then leave it here. And that leaves me with, last but not least, thanking our sponsors again. I'm going to name them all again. So a big, heartfelt thank you for sponsoring. Yeah, and we hope to see you at the New Year's drinks, 3rd Friday in January. Thank you very much to Juniper Networks, KPN BV, RIPE NCC, Power DNS, M6, Duocast, i3DNet, NLAX, LoanApp, Arista, Retten, Internet Society, Quansa, OpenBSD Amsterdam, Nokia, Smart Optics, LeaseWeb, Fibering, Fusix Networks, 10IT, Alkira, NTT, Solid Optics, AVM, Kentic, OpenGear, Nexpertise, BIT, SpeedIX en Tweede Golf. Thank you very much.